I would like to announce that I am starting a new course on building a microservices based application using Spring Boot. In this course, we are going to build a bookstore application using Spring Boot, Spring Cloud, and Docker. As you can see in this architecture diagram, we are going to build a catalog service, an order service, a notification service, and we are going to build a API gateway which delegates the request to one of these services. And there is a bookstore web application, which is a customer facing web application where users can browse the catalog of products and then place an order. And we are going to secure our microservices based application using OAuth 2, and we are going to use Keycloak as identity provider. And within this application, there is various types of communication happens, like there is a synchronous communication between services, like order service will call catalog service through a REST API call. And there is an asynchronous communication where order service put an event in the message broker. In this case, we are going to use RabbitMQ, and notification service is going to consume those events and then process accordingly. So if you take a look at these modules, so here we can see catalog service. This is a simple REST API for managing a catalog of products, in our case books. And we are going to use Spring Boot and Spring Data JPA and PostgreSQL. And then there is order service. This is also exposes REST API for managing orders and also publishes order related events to the message broker. We are going to use RabbitMQ for this. And also it is secured with Spring Security, OAuth 2 and Keycloak, because only authenticated users should be able to place an order or view their placed orders, right? So we are going to secure them using Spring Security, OAuth. And in this module also, we are going to use Spring Data JPA, PostgreSQL and RabbitMQ. And then there is a notification service which receives the order events published by order service, and then it sends notification emails to the customers. Here we are going to use Spring Boot and RabbitMQ. And there is a API gateway which acts as obviously as a gateway to the internal backend services, because we don't want to expose all our internal microservices based architecture to the consumers. In our case, here our bookstore web application is the consumer, but if we are going to expose any of our services to the public, we don't want to expose all of the internal structure of our services. Instead, we isolate all of them behind an API gateway, and we will only expose APIs through API gateway. And we are going to talk more about it in the upcoming videos. And here we are going to use Spring Boot and Spring Cloud Gateway for implementing our API gateway. And finally, there is a bookstore web application, and this can be built in a wide variety of ways. Like you can use a single page application frameworks like Angular or React or anything like that, or you can build it as a traditional server-side rendering technologies like Thymeleaf, etc. So in this case, my main focus is on building this part, like API gateway, authorization server, and various microservices. But to make it complete, I'm going to build this bookstore web application also, and I'm going to use Thymeleaf and Alpine.js, and also I'm going to protect this web application using Spring Security, OAuth 2 and Keycloak. So these are the services that we are going to build. And obviously I know you might be thinking of where is my config server, where is my Eureka server, all these things. Typically when people build a Spring Boot based microservices, all of those services are being used. But lately most of the companies are using containerization technologies like Docker, Kubernetes for running their services. So I am thinking of building this application and hoping this would be deployed on a Kubernetes cluster. When using Kubernetes cluster, some of these services might not be required. What are the services that are offered by Spring Cloud modules are already provided by Kubernetes. So for example, Eureka Server is kind of a load balancer. But in Kubernetes, there is a services concept which automatically provides that load balancing concept. So I would say it is a redundant to again build Eureka server and then deploy into Kubernetes. So we are going to talk about various options and why we are choosing one approach over the other as we go along in this series. So now, what are the learning objectives from this series? So we are going to cover a lot of things that are part of building this microservices based application, and these are some of the objectives that I would like to cover in this series. So first thing, obviously we are going to build REST APIs using Spring Boot, and we are going to learn how to use Spring Data JPA, Postgres, and then use Flyway for database migrations. And as I mentioned, we are going to have some asynchronous based communication, and we are going to use RabbitMQ for that and see how we can communicate between different services in an asynchronous fashion. Also, we are going to implement OAuth based security using Spring Security and Keycloak. And we are going to create an API gateway using Spring Cloud Gateway, and we are going to create Swagger documentation at the API gateway level. Instead of accessing a separate Swagger documentation for each service, we would like to have a consolidated Swagger documentation that is exposed by the API gateway level. And then we are going to build some resiliency features like a CircuitBreaker or retrying or timeout using resilience for J. So here, when we place an order, it is going to call catalog service to check whether the product exists or product price is correct or not, things like that. So that is going to happen by a REST API call. So in that case, we are going to use RestClient, and we are going to use resiliency for J to apply all those circuit breaker logic. And also we are going to write some of the jobs. For example, when a customer places an order, we are going to use a job scheduler to pick all the new orders and then process them. But one thing is, when you are deploying this service, maybe you might run multiple instances of the order service. So in such cases, we should there is a chance that there are multiple job schedulers get triggered on different instances, and there could be a duplicate processing of the jobs. So to prevent that, we are going to use ShedLock to apply distributed locking. And then as I mentioned, there is a communication between order service and catalog service. There we are going to use RestClient, and then there is another approach also to build a RestClient using declarative HTTP interfaces. So here we are building our web application, and it is going to talk to API gateway, and here we are going to use declarative HTTP interfaces to have a API invocations. So, and then we are going to learn how we can make local development setup much easier and simpler using Docker, Docker Compose, and Testcontainers. As we build various services and features, we are going to write tests also using JUnit 5 and rest assured and Testcontainers, and Availability for testing asynchronous flows, and WireMock. So here, as I mentioned, order service is going to talk to catalog service. So while testing, we need to mock this communication. So in that case, we are going to use WireMock. And we are going to use Thymeleaf and Bootstrap for CSS. And here Alpine.js, if you haven't heard about Alpine.js, I would recommend to take a look at it. So the main reason why I am using Alpine.js is all our services expose REST APIs. So instead of again consuming the service responses and then build Thymeleaf based rendering, I use Alpine.js to directly consume those APIs and then render the web UI. So we'll see how we can use Alpine.js and then consume those REST APIs and build the UI layer. And this is all going to be covered as part of this course. And on top of it, I am planning to cover more advanced topics like how to monitor and then implement the observability using Spring Boot's Micrometer and then Grafana stack like Grafana for visualization, Prometheus for metrics scraping, and Loki for logging, Tempo for tracing. And finally, I would like to explain how we can deploy this application, entire microservice based application on Kubernetes. So these are the three things I may cover, but if I cover at all, they most likely be as a membership viewer. Like you may have to take YouTube membership to see this, or if I ever publish this as a Udemy course, maybe you need to buy. So this is the plan. And just to give heads up on what is required to start with this course. If you want to follow along, that is the best approach, that if you are really interested to learn, instead of just watching the video, I would highly recommend to follow along each video and try it out. Because if you just keep watching how somebody else is building, that could look like very easy, but if you really try it out, you may encounter some issues, and then you learn how to debug and all. So I highly recommend you to follow along. So here we are going to use Spring Boot 3.x and then Java 21, and we are going to use Docker heavily. So I highly recommend you to install Docker Desktop, and I am going to use IntelliJ IDEA. But if it is up to you, but I highly recommend you to give it a try, IntelliJ IDEA, if you are not using it yet. There are some nice features, and it has powerful features as well. And also, as we are building a lot of REST APIs, we are going to use Postman, or if you are interested to use any other clients like Insomnia or anything like that, you can use whatever you like. I would like to show you the BookStore application, how it would look like once we complete the entire application. So here is how the BookStore application would look like. So here in the catalog, we can see various books, and we can navigate across different pages, and we can add books to the cart. So if I try to click on this cart, this is protected page where without logging in, it will redirect me to the login page. So here is the Keycloak's login page. So I am logging in with my credentials. Once I logged in, I can see the cart page. Here we can increase or decrease the quantity of products, and I have pre-populated some of these details because I'm lazy to type all these details again and again. So now I can place the order, and the order is created with the status new, and there will be a background job that keeps polling for the new orders and then automatically mark them as delivered. So to simulate this order processing in an automated fashion. So if I click on orders, I can see all the orders placed by the current customer, and I can click on any of these, and then I can see more details about that particular product. So this is the overall application, and if I try to log out and log in again, there is a provision to register as well as a new user. So this is the overall application that we are going to build. As you can see, this is a very simple shopping cart application. The purpose is not to build the greatest shopping cart application here. So the whole purpose is to learn microservices concepts and how to implement it using Spring Boot. So I cut down all these nice features. For example, there is no product page. Usually you may want to click on this book and then see more details about that product, but that is not going to teach you anything new. like you know how to render a page when you have the data, so you are going to replicate the same thing that you know. So I have removed all those things that are not going to teach you anything new, and only put the features that you learn something, a new concept. So this is the overall application, and I'm sure we're going to learn a ton of things about Spring Boot and microservices while building this application. Our API gateway is running on port 8989. So here I am accessing the Swagger UI at the API gateway level, and I have configured all the downstream services to be shown as groups here. So right now we are seeing the catalog API endpoints here, and if I select orders, it will show all the order service API endpoints here. So we don't have to go to a different Swagger documentation page for each service. Instead, we can see all the services documentation at the API gateway level. So in addition to that, here is how our Grafana stack-based monitoring looks like. So here I have automated this process of creating the dashboards and then configuring Loki, tempo for various monitoring aspects. So if I go to dashboards, I can select the service, and then I can see various monitoring details, like what are the API endpoints and how many requests are fired. So various there are many free dashboards available on Grafana site. We can leverage any of them. So here is one of the dashboard, and if I go to explore, so here there are various data sources. Tempo is for tracing, and Loki is for logs, and Prometheus for metrics. So here if I select a Loki, and I can select the container and which container I want to see. For example, I want to check the logs of order service. So here I would like to select last 30 minutes, and here you can see various logs of order service, and you can also see the trace ID. If you click on this tempo link, it will take you to this specific log related trace, and you can see how it performed, and you can dig into more details. So this is how we can configure various Grafana stack for monitoring. We have Loki, tempo, Prometheus based monitoring. Okay, so this is what we are going to build as part of this microservices course. In the next video, we are going to start first talking about what is microservices architecture and why we went from building monolithic application to microservices in the first place, and what are the pros and cons. So we're going to start with understanding microservices, and then we'll start building catalog service. In the previous video, we talked about our BookStore application, and we said we are going to build BookStore application by following microservices architecture. So first let us understand what is a microservices architecture is. So there are a lot of different types of definitions, but this definition resonates with me very well. Microservices is an architectural style where large applications are composed of small services that provide specific business capabilities that can be deployed and managed independently. So let us understand some of the key parts of this definition. So whenever we are building a large application, obviously we will divide that entire application into small subsystems, and then we glue them together to make it as a whole system, right? So here, instead of deploying all of these parts, submodules into the same one big application, we are going to deploy them independently. And how do we divide this entire application into small services? We should divide this based on a business capability, not based on the technical abilities. So here we are going to divide our BookStore application into catalog service, order service, notification service. Maybe in the real world there will be a customer service or inventory service, things like that. So we are not going to divide. It's like backend database operations as one service, and business logic as a separate service, and web layer as a separate service. That's a technical based division, which we should not do. So here our services should provide a specific business capability. In this bookstore application context, so here catalog service, it provides the business capability of managing the catalog of products. So in our application, it is a very simple one where we have a collection of books, and that's it. But in the real world, there could be like categories management and category hierarchies and products and category associations, things like that. So basically this catalog service provides everything that is required for managing catalogs in the bookstore application context. Similarly, order service takes care of everything that is related to order management. So we need to divide our whole large application into small independent services that takes care of specific business capabilities. And then there is other phrase where that can be deployed and managed independently, which means you should divide your services in such a way that they should be developed and deployed and managed independently, which means if you are building a catalog service and order service, they should be built by the same team or different teams and can be able to deploy these services independently without relying on other services. So if I am building a catalog service and then I found some bugs or I want to add some new features, I should be able to deploy the new version of catalog service without affecting other services. So we need to plan accordingly. And also managing independently means we should have the infrastructure that can deploy each service independently without having the dependency on other services. Before microservices architecture become widely adopted and popular, we used to build applications following monolithic architecture. So let us see how a monolithic architecture looks like and how it is different from microservices and understand pros and cons of the approach. So here, let us imagine if we are building the same bookstore application in a monolithic architecture, this is how it would look like. So there will be one single application which contains all the functionality of catalog, orders, notifications, and the web application. And it will be deployed as a single application. And it is going to talk to whatever the database and message brokers or authorization server. So finally, it is going to be deployed as a single application. So looks like this is much simpler option, right? So let us understand what are the problems with this monolithic architecture and why people choose microservices over monolithic application for certain types of projects. So here, let us talk about monolithic architecture pros. So simpler development. So considering, let's say you are going to work on a monolithic application. So most likely you have a single code base and you check out the repository and you work on it, and what are the required dependencies, you can spin it up, and relatively it is easier compared to working on the microservices. Which what do I mean by that? So if you are working on multiple modules and based on the microservices, you may have to spin up multiple services in order to see the whole application running, and usually it has more services required to run the application. For example, here we have only one database, but in microservices architecture, maybe we need to run 4 or 5 databases where each database instance is managing by one specific microservice. So like that, it is kind of a little bit difficult to work with microservices from the development perspective. Compared to the monolithic architecture. And the second part is easier testing and debugging. Let's say we are working on a monolithic application and there is some issue coming up, like whenever you are trying to place an order, it is throwing some exception. So in a monolithic application, you can simply trigger this operation and put a debugger in your IDE and then walk through, okay, where it is failing exactly, and you can navigate from the user action to all the way up to where it is getting exception. But in a microservices architecture, it is much more difficult because you are going to trigger an operation which starts with one service, and then it may call another service that may call another service. So it is going to be a bit difficult to test and debug as well. Think about testing. So here you can trigger a testing scenario, and then you can test the entire flow, because the entire flow is running as a single process. Whereas in microservices architecture, you trigger one operation in one service, and that is going to maybe call another microservice, and that may again call another microservice. So in order to test, you either test the entire flow as part of the end-to-end test, or you may have to mock the invocation of one service to another service. So there is going to be more effort for testing and debugging compared to the monolithic architecture, and simpler deployment. So when you think about the deployment process, it is like there is a single application and you need a bunch of infrastructure components. And compare this with the microservices architecture, where you have n number of services and each service has its own components like databases or queues, etc. And it is going to be a lot more than a monolithic architecture deployment process. But there is significant cons also for this monolithic architecture. So difficult to scale subsystems. So when you think about scaling, for example, in our BookStore application, or think about the Amazon e-commerce system. So there will be a lot more requests to browse the catalog than people actually placing the orders. So in that case, maybe they want to run more instances of catalog service than order taking process. But in a monolithic application, you cannot scale independent only one module. So if you want to run more instances, you need to run the whole application, multiple copies of the same application in multiple times. But we don't want to run the whole application. We just want to scale one particular module, which is kind of couldn't do in a monolithic architecture. And compare it to microservices. In the same case, when there is a huge traffic for catalog browsing, but very limited traffic to the order processing, you can run maybe 5 instances of order service, but 20 instances of catalog service. And difficult to adopt new technologies. So this is one of the bigger problem, like for monolithic application, usually in the enterprises, once an application is created, it is going to run for years and years, and it is going to grow over the time by adding more and more features. And it is kind of difficult to upgrade to newer versions, because there will be a lot of library integrations, and if you want to migrate to a new version, or even you want to use newer technologies, you need to think about the compatibility with all other components that you are currently using. So relatively, it is very difficult to adapt to newer versions or newer technologies. For example, you might think notification processing can be done much faster if you use, let's say, Rust instead of Java. You might want to use some other technology or library for one of the module. But in a monolithic architecture, that is not possible, or even if it is possible, that is going to cause a lot of trouble. Whereas with microservices, it is because typically a microservice code is reasonably small compared to monolithic applications. So it is easier to, even sometimes you may end up choosing a wrong tech stack in the beginning, and you want to migrate to a completely different programming language or a different framework. So that is relatively simpler compared to monolithic architecture. Higher chance to become big ball of mud. So typically this monolithic applications has this problem. As I said, in the typical enterprises, over the years, new developers come in, new features are requested, and people keep adding code over the time. And also, as you probably know, most of the times people work under the pressure of delivering based on the tight deadlines. So people are going to take shortcuts, and then it becomes like a mess. Like initially you may design it like, okay, order module will talk to catalog module, but not the other way around. But there may be some scenario somewhere, and one developer will start calling order module from catalog module, and the next developer follow along. So it becomes like a circular dependencies, and over the time things are going to get messy. And unless there is a strict process in place or technical capability in place, usually things get messy in the monolithic architecture over the time, and usually people call it as a big ball of mud. So because of these concerns, and people start looking for alternatives, and then came up with the microservices architecture. So in the microservices, as we have already seen, each business capability is implemented as a separate microservice. And here again, this is not a silver bullet, because we have seen some problems with the monolithic architecture. Doesn't mean we should all go for microservices. Every architectural choice comes with set of pros and cons. We need to understand what are the pros and cons, and weigh whether these challenges worth taking the risk or not. So let us see what are pros and cons of microservices architecture. So the pros are, as we have already discussed, we can scale individual services. So as I already mentioned, in typically e-commerce application, there will be a lot more traffic to catalog browsing than people actually placing orders. So in microservices architecture, you can run 20, 30 instances of catalog service to serve the high traffic, but you can run only 5 instances of order service. So you have that ability to scale up and down each specific service. You don't need to replicate the whole application to run multiple instances of the application. Smaller code bases are easy to reason about. So one another benefit of going with the microservices architecture is typically microservices are smaller code bases, and we can spend a week or so and try to understand the whole service implementation. But if you think about monolithic application, most of the times when a new person joins an organization and a project, if it is a big monolithic application, it is next to impossible to understand the whole system of it. So most of the times we get a new request, and then we kind of try to figure out where we can make this change, and then change it, hoping that it doesn't affect in any other areas, because we are not 100% sure, because we don't know the entire system. But compared to monolithic architecture, microservices are easy to understand. There will be smaller code bases, and if you spend a decent amount of time, you can understand it holistically. Easy to adopt newer technologies. As I mentioned, sometimes we make bad tech choices. So in that case, instead of living with the bad tech choices forever, we can rewrite the microservice in a different tech stack. For example, currently we decided to use Spring Boot and Postgres for managing catalog service. But down the line, maybe we face some problems, or we want to choose MongoDB or some other database instead of PostgreSQL. So that is kind of a relatively small effort instead of doing the same thing in a monolithic architecture. Or maybe we want to implement a notification service in a different programming language altogether, maybe in Go or Rust. Maybe that is that's a service that receives very high traffic, and maybe you want it to be highly performant. Maybe you want to use Rust for it. So that is possible when you go with microservices architecture. So less dependency on other team deliverables. So one of the challenge in monolithic architecture is, let's say you are building one feature. So if you think about monolithic architecture, we choose a Spring Boot some X version, and while building this order module, the team realized that there are some bugs which are fixed in the next version. So they want to migrate it to the newer version. But if we migrate it to the newer version, maybe some functionality is going to break in the catalog module. So if this team want to migrate to a newer version, catalog team also has to upgrade their dependencies as well. I mean, it is going to automatically update because it's a single application and catalog functionality is going to be broken. So we need to coordinate both order management team and catalog management team has to coordinate and then upgrade the libraries or framework version in a coordinated fashion. So sometimes the other teams have higher priority tasks. Maybe they want to, they plan to release some new features. They are not interested to upgrade to the newer versions of some library. So like that, there are dependencies, issues, and it is relatively difficult to deliver when it is in a monolithic architecture. And compared to that, in a microservices architecture, let's say order service team, again, they want to build some new feature or fix some bug, they can do without affecting other services because their service is completely independent and they can upgrade from Spring Boot 2 to 3 without waiting for catalog team or notification team. So these pros looks good, but again, one thing we should really understand is nothing comes for free. There will be a cost for any benefit. So then let's understand what are the cons of it. As I already mentioned, the first rule of distributed computing is don't do it. So what does that mean? So if at all possible, if your application can be built with a simpler architectural style, first go for it. Distributed computing is hard. No matter whether you have skilled developers or not, distributed computing is hard. So if you want to go for a distributed microservices architecture, you should have a good reason to go for it. And you should have technical capability to tackle those distributed computing challenges. So you need to understand the cost of it, because here when you go for microservices architecture, you need to consider a lot of things like what happens if one system goes down? Does it affect others? Does it have a cascading failures? Let's say our API gateway is the entry point for the whole backend system. So we need to take care of making API gateway always highly available. And also what happens if catalog service goes down? Does it affect the other services? So we need to think about all these scenarios when we are going with a distributed architectural style like a microservices. And difficult to test and debug. As I already discussed, compared to monolithic architecture, it is very challenging. Let's say user try to place an order and it is failing. In a monolithic architecture, you can put a breakpoint and then just navigate through where it is breaking. But in a microservices, you typically start an user action in one service and then you call it another, and maybe it is calling another service and it is putting a message into the queue and some other service is consuming it. So it is kind of it navigates to multiple services, and sometimes you couldn't run all the services in your local. So it is going to be a challenging to test and debug. And complex deployment process. Definitely microservices application deployment would be surely going to be complex than monolithic architecture. So you need to, earlier you have only one application to deploy, and even if you follow DevOps practices and then you automate the things, here it is going to be 10 different applications, 10 different components. So it is going to be deployment is going to be complex with microservices. And then performance issues. So earlier everything is run in a single process. That means when you are calling from order modules to catalog module, it's the same process and it is going to be a simple method call within the same application. So there is a very less performance impact. But compared to that, with microservices, When order service is calling catalog service, it's entirely a different application, and there comes the networking latency issues and all. So there will be definitely performance issues, and you need to think about how to solve those issues by employing like a caching or running multiple service instances. So you need to consider that performance impact when going with the microservices architecture. Let us see a quick demo of some of the benefits of going with the microservices architecture. So here our application is running. So here I have run all the microservices and their dependent components like databases and RabbitMQ. Everything is running, and now I'm able to browse through the catalog, and I'm able to add products, and then I can place an order. So everything is working fine. So now imagine this order service goes down. I am stopping this container. So now order service is not running, but still I am able to browse the catalog, and I can see, and even I can add the product. But if I try to place an order, then only it is going to fail. But it is not like a all or nothing. Still, some of the components are still functioning, and users can still browse through the catalog. So imagine for Amazon-like application, being able to still browse through the catalog, and then you can still see the recommendations. Maybe only you cannot place order right now, and meanwhile that can be fixed. So it is not like okay, one component is failed, which is going to take the entire application down. Typically happens in a monolithic application, but here you can make your application partially working without taking your entire site down. We have talked about some of the pros and cons of each microservices architecture from the technical standpoint, but in general, choosing the tech stack is not entirely based on the technical merit of a technology. So for example, first of all, if you are a junior developer, most likely you might not have the luxury to decide which technologies we want to use. Most of the times, either your architect or tech lead or some on-site counterparts, they decide on what technologies to use, and you most likely go with it. But as you gain more and more experience, and if you are transitioning from a developer to a tech lead or architect, you may be asked to come up with a tech stack, what technologies we want to use. And initially you might think, okay, let's use the most powerful tech stack, and it will help our application. But it is not entirely based on which technology is the perfect one to go for. For example, the criteria is not entirely based on the technical merit. There are many other things that a tech lead or an architect should take into account. For example, let's say we want to build some application, and let's say order service or notification service. And if you are taking a look at how the technologies or programming languages are evolving, you might see, okay, Go or Rust is performing better than some other programming languages. So can we go for Rust for using notification service? Because evidently it seems much more performant than other programming languages. But as I said, the decision to go for a particular programming language or a framework or a library sometimes is not purely based on the technical merit. We need to think about, do we have the developers that know how to use Rust? Do we have the developers to use, let's say, React or Angular? So we need to take our team skills also into the account, because you may think, okay, we have good team members who can learn new things, but it is not like you are experimenting something. You are building a production grade application, and sometimes we may have that luxury of experimenting for a couple of weeks and then upskilling and then building the application. Sometimes we may are going in a tight deadline driven development, and we may have to go for tech stack which team is most familiar with and know how to build it with the best practices. And in the previous video, when I mentioned I'm going to use Thymeleaf for building web application and RabbitMQ for message broker, some people ask why not go for React, why not go for Kafka. And that's a valid question that we should all asking. And the reason could be, some of the reasons could be technical. In this particular series context, my focus is more on building the microservices using Spring Boot, not building the front end. But to make the application complete, I am building this, and I know building a front end application using Thymeleaf better than I know how to build it using React or Angular. I can build it, I know how to build it, but it may not be perfect, or that may not be my focus. I just want some front-end UI so that I can explain the other things in a visually appealing manner. So that is one criteria. But coming to why RabbitMQ? Why not Kafka? So again, as I mentioned earlier, no powerful tool come for free of cost. So definitely I think Kafka is much more powerful and feature rich than RabbitMQ. But you also need to think about, as an architect or tech lead, if you are responsible for making tech choices, you need to consider the cost of making a tech decision. So here, we all think Kafka is cool, Kafka is more popular, why not go for Kafka? How many of the team members know how to run Kafka in a production grade manner? Typically, Kafka should run as a cluster of multi-node application, and you need to think about how many partitions you want to make, and how many team members know when one partition goes down, how the auto rebalancing happens. So though it is feature rich, it comes with a decent, more steep learning curve. Do we have that skill set of Kafka? You may think, okay, we should learn. As I said, definitely we should learn, but sometimes we run with a tight deadlines, and we may have to go with what we really know better. Maybe the team knows how to operate RabbitMQ very well, and then considering the application functionality, maybe RabbitMQ serves our purpose. For example, let's imagine if we have the requirement where when a customer places an order, we want to fire an event like order created event, and there is a notification service that needs to send an email to the customer. And also imagine there is an inventory service where it needs to reduce the item inventory levels, like there were 1,000 quantity, and now in this order we are reducing by 1. So using Kafka makes sense in that case, where you fire an event and all the consumers, notification service, inventory service, each consume that event and then take their respective actions. But in this application, we don't have inventory service. We have only one consumer where it publishes an event, and then notification service consume that and sends an email. So considering all that, like our application doesn't need Kafka-like functionality, and Kafka is have a steep learning curve and difficult to manage at the production grade level. So I choose to go with RabbitMQ. So the reason one of why I am discussing all this is, when you are stepping up from a developer to a tech lead or an architect, you need to think about all these things. It's not just about how quickly you can spin up Kafka using Docker Compose in your local. You can do that. You can just read a blog post and then you can implement consuming Kafka messages and everything. That is doable as a developer. But running the same tech stack in a production grade manner involves a lot more thinking, and you need to weigh in the benefits versus efforts. So if you are a tech lead or an architect, think in terms of those lines and then make tech decisions. When we think of building a microservices based application using Spring Boot, typically we use some Spring Cloud modules. So if you go to spring.io and navigate to Spring Cloud project, here you can see a wide range of modules, and some of them are commonly used while building microservices based application. So one of it is a Spring Cloud config. So what is Spring Cloud config? So typically while building any Spring Boot application, we store application configuration in application.properties file or YAML file. But instead of that, because we are building a set of microservices, and instead of putting configuration of each service in their services only, what we can do is we can maintain all the applications configuration in a central repository. The repository can be a simple Git repository, or you can even use a database or console. So anywhere you can put all the services configuration in a centralized place, and you can use Spring Cloud config module so that whenever you start this any of your services, it will in the bootstrap time, it is going to talk to this repository and fetch the configuration of that particular application and starts the application. So this way there is a facility where you can centrally manage all the configuration in a single place. So even if you are using Kubernetes for deployment target or not, you can use this even with a Kubernetes. But I would like to keep it simple. That's why I'm not going to use Spring Cloud config server. But if you are interested, I have written a blog on how to use Spring Cloud configuration. If you go to my blog, there is a microservices tutorial, and you can read about it. So in the context of Kubernetes, we usually use config maps and secrets for storing application configuration. And we will see how we can do this in a Kubernetes context. But for now, we are going to put application configuration in the application.properties file or override them using environment variables. But this is the concept behind Spring Cloud config server. And similarly, another commonly used service while building microservices is service registry. So Spring Cloud supports different technology-based service registry. You can use Eureka, or you can use Console. The concept is we don't run one instance of a service typically in production. We run multiple instances. For example, I spin up 3 instances of catalog service instance 1, instance 2, instance 3. But if some other client want to talk to this service, which one it should talk to? Because there are 3, and client shouldn't take the responsibility of figuring out, okay, I want to talk to instance 2 or 3. So what this service registry do is, so here this is a service registry. Assume we implemented that using Eureka. So whenever we spin up any of these instances, it is going to register with the service registry with a common logical name. All of them are going to register as catalog service. So then Eureka registry knows that under the catalog service logical name, there are 3 instances running. And for any reason, if one of the instance goes down, it will immediately remove that from this catalog service list. So if any client wants to talk to catalog service, instead of directly talking to these instances, they will interact through Eureka server. So first it will raise a call catalog service through service registry, and it will take care of delegating to one of the registered instance, so that you don't have to know how many instances are running. Even if one of the instance goes down, Eureka registry will take care of routing it to one of the available instances. So before using Kubernetes, or even still today, if you are not running on Kubernetes, this is definitely something we should be using. But if you are deploying your applications on Kubernetes, there is a very similar feature provided by Kubernetes. For example, in Kubernetes, each service runs as a pod. So let us say we want to run our catalog service in 3 pods. So there are pod 1, pod 2, pod 3. And Kubernetes also provides a component called service. So here, when you run service, it will automatically act as a load balancer. I mean, all these pods will be automatically register with this. And when you are talking to catalog service, you don't directly talk to pods. It will provide a logical name, public facing name, and you talk to this service and it will take care of delegating to one of the pods, just like how service registry works. So in the context of Kubernetes, I don't think it is necessary to run service registry. I mean, if you want to run for any reason, you can definitely go for it, but I don't see any reason to use Eureka server or any service registry when you are planning to deploy your applications on Kubernetes. So in our BookStore application, we are not going to write any service registry component. We are going to leverage Kubernetes service concept. I think now we have fair enough understanding of what is microservices architecture and how it compares to monolithic architecture, what are the pros and cons of each architectural style. So I think we are ready to start building our application. But before that, I would like to talk about few things to set up the development environment. As I already mentioned in the first video, we are going to use Java 21, and I recommend you to use SDKman. I am using currently MacBook, and SDKman works out of the box with Mac and Linux. And I think if you are using Windows, by using WSL, I think you can use SDKman with Windows as well. And if you are wondering what is SDKman, it helps in installing Java, and you can even switch between different versions per project. For example, you are working on one project which uses Java 17 and you are working with a different project which uses Java 21. So using SDKman, it is easy to install multiple Java versions and then switch between different Java versions per project based. If you want to learn more, earlier I have made a video on how to work with SDKman. So I gave the link in this project readme file. So here you can just check out this video to learn, and install Docker desktop. And I'm going to use IntelliJ IDEA. I would recommend you to do, or if you are comfortable with other Eclipse or STS or NetBeans VS Code, you can use any of that. And I'm going to use Postman. So we are going to start building our first service, catalog service. And meanwhile, if you are either new to Spring Boot or you want to brush up on a few Spring Boot concepts, I have my blog, and there are a lot of material that you can go through to brush up on the Spring Boot basics. So somebody asked me, like, is there any prerequisites to follow this tutorial series? I would say having a basic knowledge of Spring and Spring Boot would really help. But if you are not familiar with Spring Boot, I would recommend to go to SivaLabs.in, and you can check out Spring Boot tutorials. So here you can see the various tutorials that you can brush up on that will help you to follow along with this. But even if you are not familiar with it, I will explain what we are doing. But if you go through some of the some of these blog posts, that will really help you to immediately understand what I am trying to say. Okay, so in the next video, we are going to start building our first microservices catalog service. We have talked about the BookStore application that we are going to build, and we talked about what is a microservices architecture and how it is different from monolithic architecture, and what are the pros and cons of each of those approaches. So finally, we are going to start building our first microservice, catalog service. In this video, we are going to set up our catalog service, and we are going to configure everything that is required for building our microservice. But we are not going to directly build our APIs right away in this video, but we are going to configure everything that is required. So typically this is called a walking skeleton, which means you have everything you need for building the application, but the main functionality is yet to be built. So we are going to set up a catalog service, and this is a very important step because as this is the first service that we are going to build, we are going to configure a few things which are going to common for other services as well. So Please follow it through and don't skip it. I have created a repository in my GitHub account called a Spring Boot Microservices course. Right now there isn't much. We have a README file with all the project related information. And usually while building our products in real world projects, we typically use tools like Jira or Trello board or something like that to keep track of what are the features that we are going to build and then work accordingly. So I would like to follow in the similar fashion. Personally, I prefer to make a note of what are the tasks we need to do and then break down each task into subtasks. So it will help me to keep track of our progress and also identify the subtask dependencies. Sometimes one task needs to be divided into multiple subtasks, and we need to identify what is the first subtask we need to do and then what is the second one. So if you note it down, it will become more and more clear. So that is what I am going to do in this series also. And GitHub provides a facility called projects. If you log in into your GitHub profile, you can see this projects option here. So if you click on this, there is an option to create a new project. And if you click on new project, it will show various templates here. And for us, I think Kanban board makes sense. So I have selected Kanban board. So let us take a look at what is there in the current Kanban board here. So I have created few cards that are related to catalog service building, and we are going to pick up one card after another and then gradually build our application. So here right now I have created only cards that are related to catalog service only, but going forward I will be creating similar cards for other services as well. So right now there is a card for creating a root Maven project, and then there is a card for catalog service walking skeleton. So in this current video we are going to implement these two cards, and in the upcoming video we are going to build the APIs, and then in another video finally we are going to Dockerize our catalog service application. So let's start with creating our root Maven project. Let us start with the first card here. So this card has two subtasks. One is to create a root Maven project with so and so Maven coordinates, and then create .stdkman RC file. So first let us create a root Maven project with these coordinates. So in the project root directory, I am creating pom.xml file, and I have set the same group ID, artifact ID, and set the packaging type to POM because it is a root module and it is going to have child modules. And also I configured Java version to use 21 and then set the compiler level accordingly. So that is our first task. And what about the second? Create .stdkman RC file. So what exactly is .stdkman RC file? If you remember in the previous video when I talk about we are going to use Java 21, and I recommended using SDKman for that. So basically SDKman is a tool that you can use to install different versions of JDK, and not only JDKs, you can also install Maven, Gradle and other tools as well. So if you are using Linux or macOS, you can directly install this SDK using this command, or if you are on Windows, probably you can use WSL and install SDKman. So once you install SDKman, you can take a look at what are all the JDKs that are supported by SDKman. So you can run SDK list Java, that will show different vendors and what are all the JDK versions supported by that particular vendor. So usually I either use JDKs from Temurin or from Zulu. So you can select these JDK version IDs and then you can install whichever version you want to install. So for example, I already installed this 2102 Temurin. So if you want to install any Java version, what you can do, you can run command like this: stk install java and specify the version ID. So it is going to download that particular version of JDK and then automatically install, and it will ask you whether you want to set it as a default or not. So once you install this, you can use that version in your projects. So when you install JDK, when you install SDKman, it will automatically create a configuration file in the location of your home directory /sdkman/etc/config file. So in that config file, there is a property called sdkman auto env. By default, it is set to false. But if you change it to true, we can automatically enable certain versions based on the .sdkman rc file. So right now I changed it to true. After that, we already have .sdkman rc file, and I set Java version to 2101 Temurin and Maven version to 396. So what happens by having this file? Whenever I cd into that particular directory, those versions will be automatically gets enabled. For example, so right now I have Java version as 21, right? Because I have specified Java version to like this. Suppose if I change it to 1708, which is already installed. So now if I cd back, and then if I try to cd into same directory again, it will automatically see that .sdkman rc file and then enable those specific versions for this particular shell. So by enabling this auto environment to true and then having that .sdkman rc file simplifies enabling certain versions of tools in a particular project. So I would recommend to use this facility, and which enables you to seamlessly switch between different versions based on the project that you are working with. So this is why we have .sdkman rc file here. While using build tools like Maven or Gradle, one common best practice is to use Maven wrapper or Gradle wrappers, so that anybody who wants to work with the projects, they don't need to pre-install Maven or Gradle. They can directly use the wrappers and then run any Maven command or Gradle commands. So let us see how we can set up wrappers. So with Maven, we can simply run wrapper command. It will automatically download the wrapper distribution and copy it into your project directory. So here we can see there is a .mven folder. Within that there is a wrapper, and there are wrapper files, and also you have mvenws.cmd. So if you want to run any project related command using Maven, you can simply use the wrapper mvenw clean package. So it is going to use the wrappers and then run the particular Maven command here. We are done with the first card, so let us start with the second card. This is for creating catalog service working skeleton. So here we need to create a new Spring Boot application with the name catalog service, and by selecting all these dependencies. So I went to start.spring.io, and then I have provided the project metadata like artifact ID is catalog service, and then package name is com.sivalabs.bookstore.catalog, and I have selected the Java version as 21, and I have selected web because we are going to build RESTful APIs, and I have selected validation because we are going to perform some bean validation. We are going to use Spring Data JPA with PostgreSQL database and Flyway for database migrations. And we are going to monitor using Actuator and Prometheus. And we have selected Testcontainers for testing. And there is dev tools and configuration process. These help in during the development time. So I am going to generate the project with this criteria, and I am going to copy the generated project into our project. Let me add the catalog service module into our parent form. So here I have added catalog service as a module. So now IntelliJ IDEA identify this as a Maven module. Now let us quickly take a look at what is already there in the generated application. So here, based on the dependencies that we have added while generating this application, all these dependencies are already added. So now let us take a look at the code. So under src main Java, there is main entry point class here, which we usually run to start the application. And under src main resources, there is application.properties file, which contains only application name automatically configured. There are no DB migrations yet. And under src test Java, usually whenever we generate a Spring Boot application from Spring Initializer, an integration test is created, which just checks whether the context can be loaded or not. And while generating the application, we have added test containers as well. So from Spring Boot 3.1.0, they have added support for test containers, which not only can be used for writing test, we can also use it for local development as well. So if you want to learn how test containers helps for running the local application, so I have already made a video on Spring Boot 3.1.0 test container service connections and local development support. So I will add this link in the video description so you can take a look at it. So basically what test container support does is, so this is the class that is automatically added when you add test containers and any of the supporting technologies. For example, we have added Spring Data JPA and Postgres container. We have added Postgres dependency. So when you add Postgres, it will automatically configure this PostgreSQL container. This is coming from test containers as a bean and added this at service connection. So basically, if you run this class instead of the catalog service application, if you run this, it will automatically spin up a PostgreSQL database container as a Docker container, and your application will be configured to talk to this Postgres instance. So if you are depending on any external services like databases or RabbitMQ, you can configure those containers as beans, and if you simply run this, it will automatically start all the dependencies and the application also. So it will simplify running the application locally very much. So when we generate this code, by default they use the latest tag, but it is not a good practice to use latest. Instead, you should explicitly specify which version of Postgres container you want to use. So I changed it to 16 Alpine. So now what we can do, I'm going to add few properties here. So instead of running on 8080, I want to run catalog service on port 8081. And server shutdown mode, instead of immediate, I want to go for a graceful shutdown, which gives some time to complete the existing processes. So right now with this process, let us start this application and see. So to check, currently I am running a portainer container. So that's what I am seeing here when I run Docker PS. But now I am starting this application using test catalog service application. Remember this, if you run main method which is there under src main Java, it is not going to automatically start these containers. Instead, if you run this application class under src test Java, which is test catalog service application, it is going to start this container and automatically configure our application. So now the application is started, and I'm going to access the Actuator endpoints here. So by default, Actuator is enabled and Actuator health endpoint only exposed by default. So for now, let us expose all the Actuator endpoints. So by using this property management.endpoints.webExposure includes star, this exposes all the API endpoints of Actuator. So let us restart our application. So earlier when I mentioned Docker PS, only portainer container is running. Now we started the application. If we check, we can see there is a PostgreSQL container running and Testcontainers root container is running. So whenever I stop the application, it is going to remove this Postgres container automatically. We don't need to explicitly remove it. So now if we take a look at Actuator endpoint, so there are a lot more Actuator endpoints are exposed. And right now, if you go for info, there is no information is exposed. So let us fix this one. If you check the Spring Boot reference documentation, there is this generate build information section where if we add this build info executions to our Spring Boot Maven plugin, let us first add to our catalog service here. It is going to add the build information, which we'll see in a bit. And also there is another plugin that we can use, Git commit ID Maven plugin. This will pull all the Git information regarding our repository, and then it will generate a Git properties, which will be included in the information Actuator endpoint. So let us add this plugin. So with this plugin added, now let us run the package, go. Now if we take a look at under target classes, so our code goes into this com.SivaLabs package and everything, and then there is a git.properties file which contains all the information about the our current repository. So here you can see which branch we are currently working on, and who is the user committed last time, and what is the commit hash. So all these details are there. And also if you take a look at inside meta-inf, there is a build info.properties. So here you can see our build information, what is the Maven artifact ID and group ID. So when this artifact is built, so all this information is there. Now if you start the application, you can see all this build information plus git information as part of our info Actuator endpoint. So here you can see build information and branch commit ID details. So you can actually customize this a little bit. For example, we can customize our git commit ID plugin. So let me go to, so here I'm going to make some customizations here. So what we are doing, we are specifying only include these properties, git, what is the branch. And so basically if you check our git properties file, there is a lot of information there, but we may not interested to show all of this information for security reason or whatever. So we just want to include only these 4 properties regarding the git commit information. So we can customize this like this. So with this, let us again run this package goal here. Actually, when we build the artifact, this automatically happens, but because we are currently running in the IDE, we need to run this so that it will generate the git properties file. So now if we take a look at the git properties, it only included the 4 properties that we want, and we configured these 4 properties only. So this is information is enough we want to show in info API endpoint. So with this, let us restart. And take a look at, so still it is not showing all that information because by default in our application.properties we haven't configured anything, but git info mode is configured to be simple. If we make it to full, it will show all the properties that are there inside this git properties file. So let me restart this now. So here you can see all the properties that we added in our Git properties. Here we can see all that information. So you may ask why we want to show these details. Imagine you are working in a project where there are multiple members from different countries are working, and you don't know, when you are deploying into some environment, you might think you deployed your own version, but somebody else makes some changes and deployed their changes also into the common environment, and you don't know which version is running. And this really helps. If you go to this Actuator endpoint, you see this abbreviation git commit id, and you can come back to your repository. So this is our code repository, right? So here you can check, okay, let's go to these commits, and you can see this is the commit id that we are seeing in this. So you can exactly figure out which version of code is currently deployed. So especially if you are working in a distributed environment and you are deploying to a common dev environments, this is coming handy. So now we have done this, and we have added git commit id plugin and customized it. Okay, so we have done these two parts. So now let us add Spring Doc dependency. So right now we don't have Swagger documentation support. There is a Spring Doc OpenAPI library that helps in creating this Swagger documentation very easily. So here, because we are using a Spring Web MVC, not WebFlux, we can add this dependency. And if you are using WebFlux, there is other dependency that called WebFlux UI. So right now we can add this dependency. Let us close all of them. So in the dependencies, let me add it here. Okay, and reload. Now if I restart this application, I should be able to see default OpenAPI documentation, Swagger documentation. So currently there are no operations defined, but we can see that we will be able to access our Swagger UI documentation. After we added our API endpoints, we can come back and we can see how we can use this REST API Swagger documentation. So it is as simple as simply adding this, but later we can see there are a lot of configuration properties. If you want to change anything, we can change that. So let us go back, and here we have added this one, and rest assured. So when we are writing integration tests, there are various ways we can write integration test. We can use test rest template or rest assured. So personally, I like rest assured library. So we are going to use rest assured. So let me add rest assured testing library here. We are not going to write test in this video, but let us add this as well. So this is also done. Next, we are going to configure our spotless-maven plugin. So this spotless-maven plugin is to automatically format our source code. So basically, in the beginning of our careers, we take pride in arguing about whether we should use tabs versus spaces, or if we are going with spaces, how many spaces. So that was kind of a fun, but as you get older and older, you don't enjoy that kind of debates very much. You want to just, as a team, agree upon some formatting and just go with it. Debating on those silly things doesn't entertain you very much as you become experienced. So we are going to use this spotless-maven plugin, and whenever you run any goal like compile or verify, it is going to automatically check whether the code is formatted correctly or not. If it is not, it is going to fail the build, or we can also use some goal which automatically formats the source code. So let me add this here. So This is the spotless-maven plugin we are adding, and it gives the flexibility to use different formatters. Right now, I have configured this to use Palantir Java format, which really formats code very well, especially if you are using our Java 8 features like lambdas and everything. There are other options also, like you can use Google Java format. So this library feels much better for me. And once we added this, we can go to our terminal, and if we try to build mvn wrapper clean package, so it is going to automatically check. Here the current code is not formatted according to the spotless configuration. So it is also giving the suggestion that you can run spotless apply, which automatically formats the source code. So let us run spotless:apply. So this is going to automatically change the source code. Okay, now we are not inside catalog service. So now let's run this. Okay, so now the code is automatically formatted. So we are done with this as well. First, let us fix one thing in the current code base. So if we run, we have run our application locally using this class. That is fun, it is running. And if you take a look at this test, which is generated by default, now let us stop the application and run this. Currently, it is going to fail because it will try to run the application, but it is required to have database connection, but we don't configure anything in our application.properties file, so it is going to fail. So what we can do, we can leverage Testcontainers configuration that is part of this, and we can start the integration test. So instead of putting this bean definition here, we can create containers config and move that configuration to this class. So we are going to move this to containers config, and we are also going to move this bean definition into this class. So now we can change this here. Now we should be able to run our application locally just like the way we used to, and also in our test we can import this and run this. So basically we are reusing the same container definition for both local development and testing as well. So now you can see the test is passed. There is one catch with our spotless-maven plugin configuration. Right now we have configured spotless-maven plugin for catalog service, so we are able to run that spotless apply or check within the catalog service. But going forward, we are going to add more services, and instead of going into each service and then running this one, I would be able to run from the root application itself. But right now, if we go to parent folder and try to run this, run the same spotless apply command. So here you can see it applied for the child project catalog service, but the same plugin configuration is not there in the root project, so it is going to fail. But actually we don't need to apply it in the root project, but it is kind of a fail. So what we can do, we can simply add the same plugin configuration in the parent POM as well, just to be able to run that from parent project itself. I think we don't even need all these specifics, but to keep it consistent, let's leave it, because we are not going to put any code within the root project itself, but just to be able to run this formatting and everything right from the root project itself, I am adding this plugin. So another option, now you can see it is working fine. Another option would be like in our root project, we put all these plugins and everything, and then if we inherit from the root project of our own, instead of relying on the Spring Boot parent project, we don't need to redefine that. But I would like to keep all this project in a separate way instead of inheriting from this one, so that if at any point of time in future, if you want to move from catalog service being a module within this repository, if it wants to move to a separate repository itself, it would be loosely coupled. So I personally like this approach where each module, if whenever I want to move out of this common monorepo, I will be able to do that without inheriting from the parent one. So I like this way. Just the trade-off is, even though we are not using this spotless plugin at the parent POM level, we need to declare this. So now we are able to run this spotless code formatting right from the beginning parent project itself. Cool. Next, we are going to work on creating Docker Compose file for PostgreSQL. So why do we need that? So currently, with the help of Testcontainers, we are able to simply run this test catalog service application, which is going to take care of automatically spinning up a PostgreSQL container and runs the application. We don't even need to configure the database properties here, which is going to be automatically configured using service connection support. But eventually, we are going to build all our application as Docker containers and then run entire application as containers using Docker Compose. So there anyway, I need to configure all these dependencies like PostgreSQL, RabbitMQ, and all these other dependencies. And currently, when Testcontainers spin up this PostgreSQL container, by default, it is going to start PostgreSQL container with 5432 port inside the container, but it is going to map to a randomly available port on the host. So if I want to connect to it, I need to check which port it is mapped on my host, and then I need to connect to that. There are ways we can map it to a fixed port using Testcontainer desktop, but as I am going to anyway create those Docker Compose files, I should be able to use that for during local development as well. So I'm going to create these Docker Compose files. So here I'm going to create the file deployment /Docker Compose /infra.yaml. So here I'm going to define this catalog database. So here let me make it. So we have defined catalog database and we specified what is the username and password, and I mapped it to the 15432 on my host machine, and I also defined the health checks. So now if I start this PostgreSQL using this configuration, and I should be able to connect to it from my application. For that, I need to define database properties here. So let me configure these properties. So here I am configuring Spring data source URL to JDBC PostgreSQL localhost and host port 15432 and PostgreSQL. And here I am using this environment variables. Like if you want to override with a different value, you can set this environment variable db_URL, which is going to take a higher precedency. If you don't define any of these environment variables, it is going to take these default values. So if you are running in a Docker environment, you can set these values to point to a different databases. So with this configuration, now I should be able to start this container defined using infra.yaml, and then I should be able to run the application by using catalog service application instead of test catalog service application. So here I am going into deployment Docker Compose folder. Here I can run Docker Compose -f, because by default it is going to look for docker-compose.yml or compose.yml file, but our file name is different, so we need to mention -f infra.yml up, and I am running in a detached mode in the background. So now once I start, the database will be started. So let us check that. So here I am using a tool called Portainer. It is kind of a GUI tool for Docker containers. Here I can see all the containers running, what are all the images I have. So it is not mandatory, but I really like this tool to check what are the containers running. If I want to clean up some containers, I can do this. So this is a very handy tool here. So I recommend, if you want to try it out, try it out. So here we can see the catalog DB is running fine. Now going back to, now I should be able to run application by starting catalog service application itself. Okay, the application is started. Now let me access the Actuator endpoint here. So it is working just like the way it was when we are running test catalog service application. So let me know if it confuses you, because there are two different ways of running the application. The only reason I am configuring this infra and then be able to run catalog service application is anyway we are going to share some components like a RabbitMQ, which is going to be shared by both order service and notification service. We can still make it work using reusable containers concept, but to me it is kind of a little bit confusing. So I want to be as simple as, first you start all the required components for the whole microservice project. Like we currently define only catalog DB. In the upcoming videos, we are also going to define orders DB and RabbitMQ and Keycloak, and just start all the required components once, and you can run your applications locally by simply running the respective application. It can be simple. So that is the reason we have different ways. But at any point of time, if you don't want to run multiple services, you should be able to simply go and run your application by starting your test catalog or test order service, which only starts a subset of components that is required for this particular service, and you should be able to run it. Now we are done with this subtask as well. Next we want to add GitHub action for our catalog service. So what we can do, we can define our GitHub action flow under .github/workflows/catalog service.yaml file. So here I'm going to define our GitHub actions. So basically GitHub actions is a CI system where as soon as you commit your code, it can trigger the build process, and you can define what you want to do with within the build. So here, instead of putting all the services in one single file, I prefer to put it in a separate file, and then whenever we change catalog service code, then only this pipeline should trigger. So instead of without that kind of a configuration, if we change something in, let's say, order service, I don't want to run catalog service pipeline again. I want to run this catalog service only if anything changed within the catalog service only. So that is how I configured it here. So we are giving it a name, and then we are specifying whenever we push changes, and only if any files changed within this catalog service directory, then only it should get triggered, and it triggers on any branch. If you want to restrict to a specific branch, we can configure it. For example, you just want to run when code changed or pushed to only main branch, you can specify it. But I want to run this pipeline for every branch. So next we are having multiple build pipeline phases. In the build, we are using Ubuntu based, and then we are setting the working directory, because our code is not in the root project. our code, this pipeline should run within the context of catalog service. So here we are configuring the working directory is inside the catalog service, and we are setting the defaults for this pipeline to the same working directory value, which is same. And here are the actual steps. So the first one is to check out the code, and then we are setting up Java 21 by configuring what is the Java version we want and which distribution. So this is going to take care of setting the Java 21 version for our build. And we are also enabling the cache. So for the first time, it is going to download all the dependencies, which usually takes quite a bit of time for the first time. But then onwards, it is going to cache those dependencies, and only when you change any of your dependencies, it is going to re-download all of them. Otherwise, it is going to reuse the cache. And then finally, we are simply running the verify build, which is going to execute both unit test and integration test. Right now, we don't have any, but we are going to add more in the upcoming videos. So with this pipeline in place, we are able to, we are mostly done. And just to make sure we are not messing it up, let me check one more time. So from our root project, we should be able to run this same command. And one more thing to remember, here we are currently using test containers for running our integration test. There is one default integration test, right? But because I have Docker running on my local, it is working fine. But in the GitHub Actions, by default, these runners already includes Docker running, so it is going to work just fine. So it is, we are able to build locally fine. So now is the time to actually commit all of our code and then look at pipeline execution. So I'm going to commit here catalog service module setup. So now we push the code. So let us take a look at. So automatically it picked up the pipeline and it is executing our build. So the pipeline executed successfully and our tests are also be able to run. So we have our initial setup ready. Right now you can see we are just running the test. We are not creating any Docker image or anything like that. But in our upcoming videos, we are also going to build a Docker image out of our catalog service and then push it to Docker Hub. So we are going to take care of that in the upcoming videos. Now we are done with setting up GitHub action for catalog service as well. So we are almost done, but there are a couple of things that I would like to improvise. So here, if you remember, like whenever we write code, it may not be perfectly formatted, and then it is going to fail the build. And then again, I want to run the command spotless-apply to format this, and then again I run the tests and verify everything is working fine. So it's kind of a sometimes we need to do multiple steps before pushing the code. So usually I am very lazy to remember all that commands and everything, all the syntaxes of those commands. So I want to use some kind of a utility that will enable me to do this a little bit simpler way. So one of such tool is, earlier usually I used to use shell scripts to automate these processes, but I kind of find another nice utility called this task. So it is a simple utility which you can define various tasks like this, and you can run task hello, and it will execute all the commands that you mentioned here. So you don't need to remember various command syntaxes like this. You can simply provide command names easier to remember, like here hello, task hello, and it is going to run all these commands. So we are going to use this tool and make it simpler to run various commands. So here you can install this in different ways. If you are on Mac, you can simply install it with the brew command, or if you are on Windows, there are different ways. So you can follow along this installation guide and then install it. So I have installed this tool. Now I can see task version, it is installed this version of the task. Now how we can use this? We can create task file. So let me create this. So in our project root directory, I'm going to create this task file, and I have already prepared this. I will just walk you through what we are doing in this file. So here we are defining some variables that we use across in different commands here. So here we are defining what is the operating system, because if it is Linux, we can use mvenw to run any maven commands, but if you are on Windows, we need to use mvenw.cmd. So for that, I am using defining what is the Go operating system here, and I am trying to figure out, should I use maven wrapper this one or this one. So if it is Windows, I am saying use maven.w.cmd file, else use maven wrapper command. And then I am defining where is the Docker compose files defined. So in this directory, deployment/Docker compose. And what is the infrastructure Docker compose file? Within this folder, there is infra.ml. So I defined all these variables here. Now under the task section, I have defined various tasks. So this is the special default command where if you don't specify any name for a task, it is going to run this default. Here we are triggering test task. So under test task, we have a dependency on the format task, and then it is going to run these commands. So under the format commands, we are using maven w, maven wrapper, and spotless apply. So this command is going to apply the spotless formatting. Once it is applied, it is going to run this maven clean verify. So whenever you run task test, it is going to first apply the formatting and then run the test in one command. You don't need to remember all of this. And also there is a build task where it is going to simply run maven verify. But for build, if you want to run maven install or some other command, you can run this. In addition to that, we have start infra. So we have our infrastructure component defined in infra YAML file. So whenever we run start infra command, we run docker compose, and we are referencing this infra YAML file up -d detached mode. And stop, we want to stop this containers and then remove them here. So restart, sometimes we just make some changes and we want to restart. So it is kind of a simpler utility. First you stop it and then you sleep for let's say 5 seconds and then start again. So it's a simple utility. So now that we have this task file in place, let us see how our usage would look like. So first, if I don't define any task, if I simply run task, so you can see first it is applying maven spotless, and then it is running maven clean verify. So it is going to run all the test commands. Okay. Now if I want to start the containers right now, if you take a look at our container here, right now it is running. So I'm going to first remove it. So now there is no catalog DB running. So now what I will do, I will use task start infra. So it is starting the infra database here. So It is as simple as that. I don't need to remember seeding into that directory and then writing docker compose command. I can rely upon this simple command here. So it is going to start up. So now if I want to stop this, I will simply say stop infra. So whatever all the components that are defined are removed now. So it is kind of a very simplify our various testing and execution. So simply you don't need to remember all these complex commands and their syntaxes. Instead you can simply define all of them as commands here, and you can simply run task test, task format, task build, task start infra, things like that. So in my opinion, this greatly simplifies your day-to-day work, and I highly recommend you to try it out. But it is not mandatory. If you are fine without using this, that is absolutely fine. But personally, I highly recommend you to take a look at it. Now we are done with this task. We have done all these subtasks as well. So I'm going to move it to done. And in the upcoming video, we are going to implement both get products API and get product by code API endpoints. So I hope this video is really helpful. We haven't actually implemented the actual API endpoints, but we set up all the groundwork and we are ready to implement our actual logic of product management. In this video, we are going to start implementing the API endpoints of catalog service. So here we have a couple of cards that are created for implementing the API endpoints to get all products with pagination and to get a single product with the given code. Before start implementing these API endpoints, first let us talk about how we are going to organize our code base in a different packaging structure. So typically in our APIs, we divide our code into a controller layer, service layer, and repository layer. So basically, controller layer handles the web layer request, and then it will delegate the actual business logic execution to service layer, which talks to the repository in order to get the data from database or to persist the data into database, things like that. So this is very commonly used pattern. And there are different ways of structuring our code base by placing these controller services and repositories in a different packaging structure. So one of the commonly used packaging structure is package by layer. So here we'll have some common root package. Typically it is like a com.company name.project name, and then they put controllers package and all the controllers will be placed in that package. And then there is a services package where all the services will be placed, and there is a repositories where all the repositories will be placed. Though it is widely used, there are very problematic issues with this structure. Why? The first thing is it starts with a very clear intention of, okay, product controller is going to talk to product service and product service is going to talk to product repository. But as new requirements coming, sometimes product controller will talk to product service and also customer service, and product service will talk to product repository. Also, it may talk to customer repository, vice versa. Like it will end up like one service may call another service, or one service will call different components repositories. So it will become very much tangled, and it will become a maintenance nightmare. So how we can make it better? And also, while navigating the code structure, let's say you are implementing some feature related to products. So here you will end up touching each package, and you can feel that it is not isolated in its own packaging structure. So because of these issues, the alternative is packaging by feature, where again you will have some root package and you have packaging structure with features like we have a products feature, we have a customers feature, we have a orders feature, things like that. And everything related to products will be placed into this package. Everything related to customers will be placed into this structure. And of course, there could be some common code where any of these packages will use those common code. But again, this is a little bit idealistic, because sometimes it is not all about everything related to product we can place into a products package only. Sometimes our customers might want to get some products information. So in that case, again, it becomes tangled. Again, there could be circular dependencies, things like that. And also, personally, again, this is fine. Somehow I prefer not to put anything web related directly into this package. I want to put everything related to products into the products package, but all the web layer components like product controller, customer controller, they should be moved into a different package. So that is also another option, like a packaging by component. Here again, you will have some common root package, and everything related to web will go into web, and again inside web you can create different packages for different features. But in the domain, there will be a domain package. Inside the domain you will have different features like products and customers. So you will put all product related things here and customer related things here. But again, why we need to do this? Why not? What is the problem by going with package by layer, right? We can ask. So let us take a scenario where you want to create a new product, and that logic is there in product service, and product service will perform some validations, like it should have a code, unique code, and price should be greater than some price. So things like that. There are some kind of a validations, and you are doing that validation in, say, product service, and then if everything is fine, you are calling product repository to persist the data into database. Now if we expose the product repository directly by making it public, so anybody can directly inject that into any of the controllers or any of the other services, and then they can directly use the product repository to persist the invalid data into database. They can set the product price to 0 or a negative number, and then they will be able to persist that data. So they can violate or bypass those validations. Whereas here you don't actually make product repository or customer repository public. It is only package protected, and only customer service and product services are public ones. So anybody who deals with products should call product service and do the operation. They will not have the direct access to product repository or customer repository. And here anything related to web layer, we can put it here, or sometimes we may use any messaging system where some other component or some other application, they put a message into a queue, and our queue will consume that and then talk to our domain. So similar to web, maybe we can have some kind of a messaging system, and then those will start the processing here. So that is the reason I would like to separate out web layer from the domain. And again, it is not always like you will have a completely isolated flows. That means product only talks to product service and product repository, things like that. Sometimes, let us say we have an application where customer can favorite some products. So in that case, let's say if I want to view my customer profile information, I can get the customer main details using customer service, which internally talks to customer repository, and get the data. But I also want to display customers favorited products. Maybe all the favorited product IDs are persisted in some table here, and once I retrieve all the product IDs that are favorited by a particular customer, I will give all those IDs to product service and fetch all those product details. So here anyway, product service and customer services are public, and they can be used by any other web layer components. So it is not always like only product controller will talk to product service. Maybe other controllers or other messaging systems they want to use, they can use these components. But the key point is you will only have access to these services. Nobody will directly have access to these repositories, because there will be some kind of a validations or integrity will be maintained at this service layer, services level. So we should not bypass them and directly give access to this repository. So we are going to follow this structure in our application. And again, this is not like a set in stone. You always need to, any of these recommendations are based on some common practices, and you should consider whether your application is complex enough to follow any of these patterns, or sometimes maybe a simple this package by feature is good enough. Maybe our application could be very small, and it is definitely fine to follow package by feature where you put controller itself in the same package. So always you need to consider them as guidelines, and you need to always evaluate, is this suitable for my current application or not, and then pick one of the approach. So we are going to follow this pattern, and let us start with implementation of get all products API with pagination. Let us start with the implementation of get products API with pagination. So here we have a few subtasks. So the first one is create Flyway migration script for creating products table and populating some books data. So as we have seen in the earlier videos, we are using Flyway for database migrations. So we are going to create database migration script under DB migration folder. Here we are going to create our first migration, v1 __ create products table.sql. So here we are going to create our table structure as this. So we are creating a sequence that starts with 1 and increment by 50. And then we are creating a products table, and the ID will be automatically generated by taking the next sequence value of product ID sequence. And we will have a code which is unique for product, and each product have a name, description, and an image URL, price. So it is very simple products table. And another thing is to populate books data. So we are going to add some static data here, v2 __ add books data.sql. So here I got some of the books information from Goodreads website. So here I pulled some of the good book names and their descriptions and their image URLs from the Goodreads books, and I have put some random price for it. So we are inserting around 15 products into the products table here. So here, if you notice, this is a pattern where we need to follow while using Flyway database migration. V and the sequence number 1, 2, 3, 4 like that, and you need to have a separator like __, 2 underscores, and then you can give any descriptive name for the file and .sql. So what happens if you do this? When you start your application, Spring Boot will automatically try to apply these migrations into our database table, which will automatically create one Flyway migration table, and it will keep track of up to what migration it has already applied the SQL scripts. So that suppose if we add these two and now you start the application and these two are already applied, next time when you add a third P3 script and then you stop the application and restart, it already knows that these first two are already applied. So it is going to execute only the third script. So that way you don't have to worry about up to what point we have already executed and all that. That will be taken care automatically. Okay. So we have these two scripts, and if we just start it, we will be able to see the products table created and the data is inserted into the tables. So we have already seen how we are using task utility to automatically start the database, things like that, right? So I'm going to use the same utility task and start _ infra to automatically start the database using Docker Compose. So I have started that, and there are different ways. I mean, you can use any of the DB client that you prefer. for example, I have IntelliJ IDEA Ultimate Edition, so I can directly connect to the database right from here. If you are preferring any other tool, like another open source alternative is dbeaver. So you can also use this dbeaver to connect to the database. So here we connect to this database right now, and right now in the public schema there is no table like products is created. So now let us start our catalog service application by running this catalog service application class under src main Java inside the catalog service module. So now I am running this. So basically it should apply the Flyway migrations and then create the products table and insert the sample data. You can even check that in the console log itself. So here you can see Flyway migration applied to 1 and 2, successfully applied. Let us check that. Let me refresh. So here we have two tables. One is for our own products table, and automatically as we are using Flyway for migrations, it already created Flyway underscore schema underscore history table. So what does this table contains? So it will keep track of all the migrations that are already applied. So here you can see we have type is SQL, and this is the script that we have executed, and it also maintains the checksum. Because once a SQL script is applied, you should not tamper that. That means you should not add one more row here, or you should add some logic here. So once a script is applied, you should never touch it again. If you want to perform any modifications to the database tables, you need to add another migration script. You should not touch it. If you change it, when you start the application again, it is going to fail by comparing these checksums. So never touch already applied migration script. So this way it keeps track of what are all the migrations that are already executed. So now if I create another one, only the third one is going to be applied. So okay, now that we have Flyway migrations in place, we can say this is done. So the next one is make default page size configurable with a value of 10. So this is the API endpoint we are going to implement, and we are saying we are going to use pagination, and we are saying by default return per page 10 products information. So let us first start with this implementation of the controller, and then we'll see how to configure this. So as I mentioned, we have this common root package like com SivaLabs bookstore catalog, and inside that I'm going to create web dot. So as this is only related to catalogs, I am not again creating web.catalog controllers. I am directly creating web controllers dot product controller. And as we are implementing a REST API, we should use REST controller, and we can use a request mapping annotation at the controller layer level, so that we don't have to repeat this same common API/products for each of the API endpoints. So once we have it here, we are going to implement get mapping, and we are going to return, let's say, a list of products, get products. So assume this is how we are going to implement our API endpoint. But again, as specified in this, we need to accept the page request parameter and then return only a paged information, right? So how we are going to accept a query parameter? So we are going to use request param annotation, and here you can see we are specifying a default value so that it will automatically make it as a non-mandatory, non-required query parameter, so that if user explicitly doesn't pass page query parameter, we are going to take it as 1. and it is if they explicitly pass any value, it is going to take that value. So we have that here. Next is we need to create our JPA entity, and then we need to go ahead and create a product service, all these things. So how we are going to do this? Under catalog, we are going to create a package called domain, and under domain we are going to create product entity, and you will have product repository, and you will have product service. So if you take a look at it, we need to mark our service as Spring service, and also typically service layer is considered as the transactional boundary. What does that mean? So you will typically start a database transaction when you invoke any product service public method, and then you perform all the actions in that method, and then once it is successfully completed, you will commit the transaction. But if there is any exception occurred during any of this service layer method execution, you want to automatically roll back that transaction. So this is why we typically maintain the transaction at the service layer level. Now we are going to inject private final product repository, and we are going to add it in constructor. But it is not yet made as any Spring Bean, but we are going to use Spring Data JPA. So our product repository is not a class, it is a repository, and we are going to extend JPA repository, and this product is, it should be product entity, and okay, this is not. So by default, we can create our product repository simply by extending JPA repository, and we need to specify what is the entity type and what is the primary key. So right now we haven't yet created this product entity here. So let us do that. So first we are going to add at entity and at table and specify the actual table name here, and then we are going to add all the properties and then setters and getters. So here we have ID, which is the primary key, and we are using product ID sequence that we have already defined, and then we have product code, product name, description, image, URL, and this. So we also have a default constructor and a all args constructor, and also setters and getters. If you prefer to use Lombok, you don't need to write all this boilerplate. You can use Lombok annotations, but personally what challenge I faced is I personally never faced any challenge with using Lombok. But if people are using other IDEs like Eclipse, so sometimes I see Eclipse plugin not being installed properly in Eclipse, and then people struggle to follow along. So that is the reason I am not using Lombok. But if you prefer to use, feel free to go ahead and use Lombok annotations instead of writing all these constructors and setters and getters by hand. Okay, so we have product entity, right? So here we are using the same, let us see here, while creating this we are creating the sequence, right? Product ID sequence, we created that. So we are pointing to that sequence name and then name it as a generator, and we are using that. So this is a common sequence based ID generation setup here. And you know, for column it should not be null and it should be unique. And we are also using Java bean validation API annotation that says this is required. If you try to save by any means without the product code, it is going to throw exception. So things like that. And here you can see we mentioned it should not be null, price should not be null, and also it should be minimum of 0.1. I mean, it should not be null or 0 or negative amounts. It should always be something positive. So this is our entity. Next, if we take a look at our repository, we have extended, that is sufficient for now. And if we go to our service, we have service, and let us say we are going to return get all products, public list get products. So here we are going to take the page number also, because we want to return only a subset of records, not all the products. So let us say, how do we implement the logic? So Spring Data API already provides the capability of doing the pagination, sorting and all that. So we are going to use that. So how do we use that? So here you can see find all takes a parameter of pageable argument as well. So let us create pageable. So pageable, we can create a pageable implementation using page request of whatever the page number and the page size. So this is supposed to be a configurable property. Just for now, let us use constant here. And whenever you are using pagination, always apply some sorting also. Otherwise, whenever you try to apply pagination and get the next set of page, it won't be consistent because you are not specifying the exact sort option. So always, whenever you are using pagination, always specify the sort option as well. So we can create sort by name. This is nothing but the property of our product entity. So we have name. So we are going to sort by name, and we are going to specify this sort also here. Okay, now we have pageable and we can pass this. So here, if you take a look at it, it is going to return a page of product entities, not a list. So what does page has? So for now, let us return null. So this products page will have various pieces of information like what are the total elements available. For example, in our products table, there are 15 products, and this is going to return 15. And get total pages, because we specified page size as 10, it is going to return total pages as 2. And similarly, you can also get complete data like here. You can specify, you can call get content to return the first page of content, actual content, and also you can specify what is the current page number. So you can get all this data, and you will be able to return what is necessary for the API. So here, if you take a look at it, we need to return an object which contains total elements, total pages, page number, is first, is last, so and the actual data. So this is the response format the API is supposed to return. So what we can do, first we are going to create a record with this structure, and then we are going to populate that and then return it. So let us create a record of, here I am going to, under domain, I am creating a record called paged result, and it is taking a generic parameter of type T, and I am specifying there will be a list of T type, whatever it is. It can be a product, it can be a customer, whatever. I can use it in a generic fashion. And then I am specifying it will also contain total elements, page number, total pages. Is it the first page? Is it the last page? Is it has a next page or previous page? So all this information we can obtain. So I have created this paged result, and I am going to return that instead of the list. So here I need to populate this and then I need to return. So let me so here I can pass. So how we are extracting the actual data from page. So it contains the actual data for this particular page. It also contains the total elements. It contains the current page number and total pages. Is it having first or is it the last page? So all this data we can obtain from this result, which is nothing but actually, let us see the type. So it is page of type product entity. So this is the type and we are able to extract the information. But here we need to consider one interesting thing. So this page number is actually starts with index 0 from the Spring Data API point of view. But usually for consumers, they will say, give me the first page, second page, like that. So we are going to assume that in the product controller, the first page means index is 1. So while performing this, we need to check whether page number is greater than 0 and then reduce it by 1 and then return it. So what we can do, we are going to assign page number equals to, if page number is less than or equal to 1, we are going to take it as the page number 0. Otherwise, we are going to simply reduce it by 1. So even though if they try to break the API and by giving -1 or -10 as the page number, we are going to consider it as the page 0, first page, and we are going to use it. But also while returning here, when we call get number, it is going to say 0. It is not going to say page number 1. So while returning also, we should increment that so that they can see the first page with the page number is 1 instead of 0. Okay, so now we have this, and in fact we can directly return that. We don't need to even hold it in a variable. Okay, so now our get products is good, and what else we need to do? In our controller, it is going to let us inject this. So here this product service should be public. Okay, we have constructor which takes product service, and that is fine. And here I am going to pass page number, and it is going to return page result of product entity. But here is another thing. So this product entity, as I mentioned, for now let us make it public, let's say. So we are able to call get products, and then we talk to the database, and then we manage to populate the result in the desired format and then returning it. So one thing we need to take into account is, should we expose our direct entities to the front end in the sense API as a API response? Should we do that or we shouldn't? So for most of the applications, we should not be doing that, because if there is any change, you want to change the response field names or column names or anything, that is going to directly affect it is kind of a coupled, our database structure and the API response is kind of a coupled. You can tweak here and there some things, but still it is better to keep them separate as long as it is possible. So here I prefer, instead of exposing the product entity directly as a response, I would like to create product as a record and then only expose the necessary fields. I mean, ID shouldn't be required for anybody who is consuming this API. All they should know is they need to know the unique code and name, description, image, URL, price. They don't need ID. So what we can do, let us create product which is a record. Okay, and here let us see, we don't need to have ID, we have code name description, and we should also include string image URL. Okay, so this formatting will be taken care later. So let us make this public. Now instead of returning product entities directly from product service, we should be returning products. How can we do that? Now right now we are returning a page results of product entities. So this page of any type has a map method. We can pass some mapper and then convert it into product. So let us do that. So let us create a product mapper. And it can have, we don't need this, and to product. So it is taking a product entity and then it is creating an instance of this. So why it is okay, it is big decimal. In product it is marked as double, so we are changing it to big decimal. Fine. So we have a static method which takes a product entity and then populate to product and returning it. So what we can do here, it is going to return page of product. So we are getting this which returns page of product entities, and then we are mapping it using this method reference to page of products. Okay, now we are again parsing, extracting all the data, and then we are returning page result of product. Now if we go back to our controller, it is going to return product, not product entity. And now let us make it as package protected, not a public one. Now let us see if everything compiles fine. We don't need this. Cool. So now let us once again quickly go through a few important things, and even though some of these details are small, let us pay attention, because this access modifier is something that we can use for imposing some of these restrictions. For example, product controller doesn't need to be a public class, because the framework Spring Boot is going to invoke this. Nobody else is directly going to use this class, so we don't need to make this controller class as public one. And also the controller, it doesn't need to be public, and the handler methods doesn't need to be public. So you can remove public from all these things. Okay, so next, if you go to product service, only from the domain package we are exposing service and some models here, page result and product are the models, and none of other components should be public. So here we have public class, and then we don't even need to make it public for the constructor, and we are using all these public methods to implement the actual logic. This is fine. And product repository also doesn't need to be public, because it is supposed to be used only by the product service. So any other package should not be able to directly call any product repository methods. So similarly, the product mapper is an internal utility. So it doesn't need to be public as well. And similarly, we are not revealing this database technology specific, the implementation details, JPA, whether we are using JPA or whether we are using Zook or some other thing. Nobody should bother about it. So this is an internal implementation detail. So we are not making it as public either. But this product is a component that we are sharing with the web layer also. So it is a public record. Similarly, page result is also a public. So these two are being shared across the packages. So though it may look like what is big deal by making this public or not public, because this is going to protect from becoming the mess. So instead of letting everything be public and then slowly some other domains start using this, and then it becomes circular dependencies, and then it may get messy. So following these simple patterns will help us to keep our specific packages isolated, and you can impose all the restrictions. For example, here right now we are not creating any products, but in case if you are having an implementation of a create product, you can centralize all the logic here so that nobody is able to directly call product repository and store an invalid product data. So everybody should use product service only, and we will perform the validations. So that is the whole idea. The implementation is almost ready, except that we are still hard coding this page size. So as per the requirement, we need to make it a configurable property with a default value of 10. So let us implement that. So I'm going to create application properties as a record. And here I'll make this as a integer value, page size, and I would also like to specify default value of 10. Also, I would like to have some minimal value as well, so it should not be anything negative. So from 1 onwards it can be anything. So we also need to mark it configuration properties prefix with our application properties will be prefixed with catalog. So now we need to do two things. One is in the root main entry point class, we need to enable configuration properties and specify application properties. So this is one way. Another way is you can enable configuration properties scan. So here you don't need to specify these property class names. It will scan through from this root package and then identify all the configuration classes like this, which has add configuration properties. So you can follow whichever approach you prefer. So I'll follow this one so that I don't have to specify names. And next, we need to configure the same value here, catalog.pagesize equals to 10. So if you want to change, you can change, but I like to keep it as 10. So now we need to inject that into our service, private final application properties, and here we can use that properties.pagesize. So we don't need to hard code this. So now we are completely done with this implementation. Now let us restart and manually test our API endpoint. So the application is started. Now let us go to our browser. Because it is a get endpoint, we can test it directly here. So I am accessing 8080/API/products page equals to 1. So here you can see it returned data and also returned total elements is 15 and page number is 1. Total pages is 2 because we specified default page size as 10, and is first because this is the first page, it is true. Is last false because there is a second page. Has next true. Has previous false because this is the first page, there is no previous page. So now let us access page 2. So it only contains 5 records because this is that second page, and totally there are 15 records. So in the second page the 5 records are written, and here you can see page number is 2, total page is 2, and is first page false, is last page true, has next false, has previous true. So we are able to get the data with pagination support, as defined in this requirement. Also, we should always keep in mind that whenever we are implementing this collection based response, we need to think about this pagination support. Why? Let's say if we are talking about data that is ever growing, for example, products can have millions of records, or let's take orders or something like that. So they can keep adding more and more data, and the table may end up containing millions of records. So if you don't implement pagination and if you try to return all the data, so it is surely going to get out of memory exception. So always whenever you are implementing API endpoint that return a collection of records, think about, is it ever growing data? Then always apply the pagination support. Cool. So we have implemented this, and we are getting the response in this structure. Now all that is left is to implement the unit and integration tests. Let's start writing unit and integration tests for our API. So before writing the tests, let us understand Spring Boot's testing support. So basically, as we have seen, we have this flow. We have controller, we have service, and we have repository. So now when we write an integration test, the idea is to load all the components and then make an API endpoint call and then verify the response. So this is where we can use @Spring Boot test annotation. So basically the @Spring Boot test annotation is used to write an integration test which will load the entire application components. And there are other testing support annotations as well, like slice test annotations. So if you want to test only the controller layer, you can use @WebMVC test. Similarly, if you want to test only the repositories, and based on the technology you are using, in our case we are using Spring Data JPA. So you can use @Data JPA test for testing only repository. So if you want to test the integration test, we can use @Spring Boot test annotation. Otherwise, why you may wonder why we need to test only controller or only repository. For example, you want to test only a repository layer. For that, you don't need to load either service or controller level. So in that case, you can just load these repositories and then you can test it alone. Similarly, you just want to test various scenarios. What if service layer returns some exception? What if service layer returns this kind of a data? So in such scenarios, again, you don't want to load all these things. You just mock service and then you can test various scenarios for the controller level. So basically you can do that. But considering our API, it is very simple. There is no business logic in the service layer, and it is sufficient to test with the integration test itself. But for just education purpose, we are going to write an integration test, and also we are going to check how to write a unit test for repository as well. So now let us go back to our code. Earlier already we have one default test. So here right now we have already one test that just testing whether application can be started or not. That's it. We are not testing any business logic here. And also we are going to write more integration tests. So instead of adding these annotations for every integration test, let us create one base class here. So here I'll name it as abstract integration test, and I will make it as public abstract, and I'll move these annotations into this one. And one more thing is, by default Spring Boot test may start on the specific port, but here it is advised to use random port, so that if you are running your tests in a pipeline like Jenkins, it won't conflict with other pipeline executions. It will always pick one of the available random port and then run the test, so it won't conflict with the other pipeline execution. So we are going to choose random port here. And also I mentioned we are going to use rest assured for testing API endpoints. So as I said, the application is going to start on a random port instead of the defined 8081. So how do we know the port number? we can use at local server port. So this is going to bind whatever the random port the application is going to start to this integer here port. Now we can use at before each, and we can bind this URI to this, or you can simply just map it to port. So it is going to take the local host by default. So now we assign the rest assured port to this randomly started port number. So now we can use rest assured for invoking the API endpoints. So this is the basic setup that we need, and we put it in the base class itself, so that we don't need to duplicate this logic in every integration test. Now with this one, let us extend this abstract IT. Now first let us test this. So this is one thing to understand. Every time whenever you are making change, make small amount of change and immediately test it without waiting for till end, and you make a lot of big bang changes and then test. If it is not working, again you will need to debug why it is not working. So always make small amount of changes and then immediately try to test it, so that you will quickly know where exactly you are breaking it. So it is working fine, so we did not break anything. Now let us write our test for product controller. Again we are extending it from abstract IT. Test void should return products. I'm going to copy this snippet and I'll explain. So here we are using this from rest assured. We are saying content type should be JSON, and when we are issuing the GET request to /API/products endpoint, we are expecting the status code to 200, and we are now we are asserting all the data of the response. So we are saying the data field should contain 10 elements because our default data size is 10. And how do we know that it is going to return total 15? Because in the seed data here we have inserted 15 products, right? So it is going to start the application and it is going to apply all this, and it is going to contain a total 15 elements. So we are asserting that. Page number is 1, total pages is 2, and other fields we are asserting. So here what is happening? Again, we have this containers config file which define the PostgreSQL container using test containers, and then we are importing that in our abstract base class here, and our actual test is inheriting that. So when we run this one, it is going to spin up a new PostgreSQL container, and our Flyway migrations will be applied and the data will be inserted. Now it is going to execute this test and it is going to verify the response here. So let us run this one. So it is working fine. Cool. So this is how we can write an integration test. One recommendation is always whenever we are testing, we should make sure that our test data is in a known state, which means here we are making an assumption that okay, we have this Flyway migration script, and we are making that assumption. Products table is going to contain these 15 records. So instead of making that assumption, each test should ensure that only this particular data set is present in the database. then we can confidently run our execution. Otherwise, maybe during in our product controller test itself, let's assume there are multiple other tests also where they are going to insert new records into the product database, product table. So in that case, it is not going to return exactly 15. Depending on the order, it may return 15 or 16 or 17, something like that. So the recommended approach is always make sure that you are having a predefined set of data, known state. So how we can do that? So let us create a resources folder. So now we have under src test resources, let us create a file called testdata.sql, and here what we can do, we can write a SQL script to initialize the data. So again, right now I am just using the same sample data which we have in this script, but I am truncating the products table and then inserting the same set of data. But you can change the data, or you can simply put some dummy data here, but right now I'm just using the same data set here. Now once I have this one, what I can do, I'll go to this product controller test and I will add at SQL. So here I will add this test data. So by adding this annotation, what it does, it is going to execute this SQL script before every test method execution. So the benefit is, let us say you have another test here, should create product. Okay, let's assume we have a test that successfully insert a new product into the products table. So now without this SQL, if this test runs first, it is not only going to contain 15 records, it is going to contain 16 records, and this will fail. Otherwise, if this test is going to run first, it is going to succeed because it will already have 15 records. So it becomes a flaky, like you never know when it is going to pass, when it is going to fail. But with this one right now, what happens? Every time before executing any test, it is going to run this SQL file. So it is going to truncate all the data, existing data from the table, and it is going to insert some known set of records. So now whether it is going to execute this test first or this test first, it doesn't matter. It will always contain 15 records, and then you can assert based on that, and you have predictable outcomes. So that is why we can use this approach. Now let us remove this and run this test again. So it is also successful. So that is how we can write an integration test. Now what about the unit test? So here, as I mentioned, currently the product service doesn't have any business logic here. So again, I would not even go for writing a test for product repository, because we are just extending from the JPA repository and we do not have any of our custom methods also here. So basically you are not required to write any test that tests the framework features. They are already tested and they are working fine. But for our learning purpose, so if we are going to write any custom method here, and then how do we test a repository? So let us take a look at it. So as I mentioned, because we are using Spring Data JPA, we are going to use at data JPA test annotation. So this is called a slice test annotation. So we are testing only one slice of our entire application. So here we are just testing this slice. Okay, so by default, when you add this one, it is going to start a database with in-memory support database. But here in our application, we do not have any we do not have any in-memory supporting database libraries like H2 database or HSQL. We did not add any such dependencies in our application, so it is going to fail. But we don't want to actually test with in-memory database because we are using PostgreSQL, and in production we are going to use PostgreSQL only. So we should ideally be testing with Postgres only. So how do we test with the Postgres? So as I already mentioned, we are using test containers. So by using test containers, we can simply use these properties for database testing. So first property is to turn off the behavior of spinning up a data source with in-memory settings. So right now we are saying don't try to create a database instance with in-memory settings. And second, Spring data source URL, this is a special JDBC URL where it is containing this TC : prefix, and this is going to tell test containers to spin up a PostgreSQL container using this tag. So it is going to use PostgreSQL with 16 Alpine based image, and it is going to application is going to configure to talk to that database instance. So with this we can run a test that is going to talk to a PostgreSQL. Fine. Next is here we can auto wire product repository. Next we are going to run a test like this. So again this doesn't make much sense. So here product entity, because we are testing the framework feature, we shouldn't, but just to demonstrate how to run. So now here we are calling find all, and we know that it is going to contain 15 records. But again, the same rules apply here as well. Instead of relying on existing data, we should always set up the test data, and we can ensure that it is going to contain 15 records. So let me run this. So this is also fast. So this is one approach. Let's say you don't want to configure like this. Another option is you can still again import the configuration. Right now we have containers config where we have already configured this PostgreSQL container, right? So just like the way we are using that container configuration using @import, you can also do that for our repository test as well. So here with this property we are simply turning off this spinning up the local in-memory database, but here we are not configuring to use test containers, but we are saying that by importing containers config here. So it is also working fine. But the tricky part is here right now it is containing only one Postgres bean definition, so it is going to start Postgres only. But imagine if it is our order service, in addition to Postgres you will also have other containers like RabbitMQ. So in that case, just importing this, it is going to start not only Postgres, it is also going to start RabbitMQ also, which is unnecessary for testing our repository. So I would recommend is, if you are testing repositories which only talks to the database itself, then this is the recommended approach. Like you just configure this magical test containers URL, and it is automatically going to spin up the Postgres or any other database type. Like you can spin up any other SQL database by specifying the respective MySQL, MariaDB, Postgres, and then specify the image tag, and it is going to automatically do that. So this is how we can write repository tests using data.jpa test annotations. Now that we have written tests for this get API products endpoint, we are done with this card and we are moving it to done, and we are going to work on this get product by code API endpoint. So here we need to implement this API endpoint, and if the product exists with the given code, we need to return this response. Otherwise we need to return with a HTTP status code 404 and with this response, and we are going to write tests for it. So let us go back, and this time let us start with repository. So here when somebody give a product code and then ask for it, a product may exist or may not exist. So what we can do, we can return an optional of product entity and find by code. So Spring Data API has this feature of derived query. What does that mean? So when we write a method like this, which starts with find by, it is going to strip off this prefix, common prefix, and then try to come up with a where clause to get the product. So here it is going to remove this, and then it will see where code equals to whatever the code value that we are passing. So it will become like select star from products where code equals to the value we are passing in. So we don't need to actually write the query, and Spring Data API automatically figures this out and then execute it for us. So we have this method, and we are going to write a method here, public. Okay, it is automatically completing. So get product by code, we are taking the code, and then we are fetching the find by code from the repository, which is going to return optional of product entity. But we don't want to leak our entity information to anywhere else. So we are mapping it to product mapper to product. So it is returning the product record instead of the product entity. Okay, so now that we have this, now let us add the API endpoint here. Okay, it is giving the auto completion, and instead of returning product, we can say response entity of product, and which is mapping this code here, and it is calling product by code, and let us map it. If it exists, we are going to return with status code OK, or else throw product not found exception. But we don't have this class yet, so let us create this under domain. It is going to be public one, and we are going to extend this with the runtime exception here. Public, and we are going to have product not found constructor, and also I'm going to create a public static factory function with code for code. So just a small utility where we can simply construct this exception by calling this method, and we don't need to specify the entire message here. So now here, going back to we don't need to construct it like this for code. Okay, so what is happening here, we are calling the product service get product by code, and then it is going to return optional of product entity, product not entity, and if it is there, if the object is there, it is going to return response entity dot OK, so which is going to return with status code 200. If it is not found, it is going to throw product not found exception. Okay, now let us check. I think we have a good enough implementation to test it manually. So let us start the application first. We are going to start our catalog service application. And if we go to Postman and let us take one of the product code. So this one. So we are checking 8081/API/product/P100. So it is returning the data as expected. If we are writing some non-existing product, it is throwing kind of a big stack trace and a default error message. But this is not what we want to return when it is not finding this product with the given code. So we need to handle these exceptions. But here in our handler method, we are not handling this exception. We are simply throwing it. So what we can do, we can implement a global exception handler, and then there we can handle product not found exception. So how do we create global exception handler? We can, under web, I'm going to create exception dot global exception handler. So this is, we are going to add REST controller advice. So this is a advice, like it is going to apply cross-cutting concerns. It is going to take care of cross-cutting concerns. So here we can add, okay, let me, instead of typing the whole thing, I'm going to copy paste it here. So basically we are creating a global exception handler, and we are extending this response entity exception handler. And basically Spring Framework 6 come up with a support for handling RFC. Let me take you to a blog post. So if you go to Spring Boot tutorials, there is exception handling, and there is so here Spring Framework 6 added a support for this problem details API specification RFC 7807. So if you take a look at this, how we can handle this exception, here is how. So we can create an exception handler like this, and then it is going to throw default exception. If we want to handle any specific exception, we can handle it like this, which takes whatever the exception we are trying to handle, and then we can create an instance of problem details. So here we can construct all the respective fields, and then we can set whatever the values that we want to return, and then return it. So we are following the same thing here. So I'm going to give a link to this blog post in the video description. So let us go back, and so here we are doing the same thing. So we are handling this product not found exception here, and we are constructing problem details object. So here we are setting the status, HTTP status code as not found, because product not found means we want to return 404, and we are setting various other details. The title is product not found, and our type is, we are giving some made up URL. Just if you want to publish any of our error codes, we can do something like this. And then we are setting the type service name. So in addition to the main details, if you want to provide any additional fields, we can set it like this. Let's say we want to say which service this exception came from, and what is the kind of I mean, is it a generic exception, or is it any specific security related exception? So something like that. If you want to add any other fields, we can add problem details start set property, and you can set whatever the values you want to. So you can create a global exception handler like this, and then you can handle all the exception. And one important thing is, if you want to handle any specific exception, you can do like this, but also add one exception handler that is generic one. So we are handling here generic exception. So whenever some unknown exception is thrown, finally it is going to handle by this. If it is any of our controllers or anywhere, if it throws product not found exception, this is where it is going to be handled. So it is always advised to have at least this generic exception handler, so that our end consumers of our API won't see like this generic response, which may reveal what kind of technologies we are using, and this may be a security issue. So we don't want to reveal any of our implementation detail. So this is how we can use global exception handler advice here. So with this, let us verify, restart, and then let us check. Okay, now it is returning the proper expected format. So here it is saying product not found with code, so and so, and all the other details. So this is how you can implement generic exception handler, global exception handler. Fine. So let us compare, is this in line with the expectation? So here the detail is saying product with code not found, but I think we are returning a slightly different error message, product not found with code. So let us fix that as well. So here is where we are constructing that product with code not found. Okay, so now it is going to return with this error message. So everything is fine. Let me test it once. So it is returning as expected. Cool. Now let us check what else we need to do. So this is done and this is also done. Now let us write the test for it. So we already have an existing test. First let me stop this, and if I go to product repository test, so basically earlier as I mentioned, we can write test for our own methods here. We are not required to test the framework built-in methods here. So I'm going to remove this, but first let me create a test and should get product by code. So I am using GitHub Copilot, so based on the context it is giving decent auto completions, but anyway I'll go through the explanation. So here again we are running this SQL script, which means it is going to insert all the sample data, and we are trying to fetch one of the product by code and then comparing this other details, name, description and image URL and price. So here that is what we are doing. First we are getting find by code, which is going to return optional of product entity, and we are calling or else throw. That means if there is no product found, it is going to throw exception and our test will be fail. And we are just comparing the code is same and the title name is same and description is same. And so here it is not the price should be big decimal, so new big decimal of. Okay, so now let us run this test. So both are success. So fine, I'm going to remove this because okay, I'll leave it here, and I'm going to write another test to verify if I'm trying to get a product with a non-existing code, it is going to return some optional of empty. So here I'm going to so here let me write should return empty when product code not exist. So here we are giving some invalid product code or non-existing product code and then trying to call this and asserting it is empty. So let me run this test again. Cool. So when a product exists with a given ID, product code, we are getting the expected response. If you are trying to get a product with an invalid or non-existing product code, it is returning an optional of empty. So we are checking is it empty or not. So our unit test is done, and finally let us go to our controller level test. So here we can write a similar test for product. So I am going to copy the snippet because they are very similar. So here so what we are doing in this test should get product by code. We are making an API call to API/product/code and we are specifying P100. and we are expecting status code to be 200, and also we are extracting the response to product object, and then we are again checking whether these details are equal to or not expected values. And similarly, we are taking this invalid product code and then we are making a call to the same API, and we are expecting status code to be 404, and then we are asserting some of the details. We can add more details if you want to. So I don't think we have these codes here. So now let me run this test and see. So all of them are succeeded. Cool. So this is how we can write tests for API using integration test. So here is a common thing, like if you are writing integration test, then only use @Spring Boot test, because when you use @Spring Boot test, it is going to load the entire application. Whereas if you are using any slice test annotation like @DataJPA test or @WebMVC test like that, it is going to load only partial components, maybe a repository or a controller like that. So it is going to be faster. So if your intention is to test only one slice of the application, always use this that specific slice test annotation and then test it. Okay, I hope we have completed this two as well. So we are done with our two API endpoint implementations. And in the next video, we are going to take a look at how we can Dockerize our catalog service application and then be able to run both our catalog service and then PostgreSQL DB in Docker, and then be able to call the API endpoints. In this video, we talked about what is the better way to organize our code using different packaging structures and what are the pros and cons of different styles of code organization. And then we went ahead and implemented the both API endpoints, like getting all the products with pagination support and getting a product by code. And then we have implemented our database migrations using Flyway. And finally, we have written both unit and integration tests using Testcontainers. So because this is our first service implementation, we have talked a lot about how things are supposed to be done, what are the best practices and all. So I hope we have a strong foundation now. So our next API implementations will be much faster. We have completed the implementation of catalog service APIs, and in this video we are going to focus on Dockerizing the catalog service, and we are going to configure Docker Compose files so that we will be able to run entire catalog service, both the service and its dependencies like Postgres, using Docker Compose. And then through GitHub Actions, we are going to build a Docker image and then publish it to Docker Hub. So let's get started. I have created a card to Dockerize our catalog service, and this contains 4 subtasks here. So first we need to configure our Spring Boot Maven plugin to create a Docker image with this name, sivaprasad_bookstore catalog service. And then in order to publish our image to Docker Hub, we are going to create an access token, and then we are going to configure the Docker Hub credentials as secrets in our GitHub repository. Finally, we are going to use our GitHub Actions to build the Docker image and then push it to Docker Hub. So let's start with Spring Boot Maven plugin configuration. Usually, if you are trying to build a Docker image, usually you will create a Docker file and then you specify the steps you want to perform, and then you run docker build -f docker file and you will give it a name. But Spring Boot Maven plugin and even Spring Boot Gradle plugin makes it very simple that you don't even need to create a Docker file. Behind the scenes, Spring Boot Maven and Gradle plugins, they use cloud native Buildpacks and build a Docker image. So we don't need to create Docker file itself. So let us see how we can use the Maven plugin, Spring Boot Maven plugin, and create a Docker image. So first let us create a custom image name here. Let us configure it. So here I am opening pom.xml of our catalog service. So here I am creating a property called Docker image name, and here I am giving my Docker Hub username SivaPrasadReddy / bookstores hyphen the project ID, artifact ID. So it is going to be like SivaPrasadReddy / bookstore catalog service. And then I'm going to configure my Spring Boot Maven plugin here to build the image with the custom name. So here, if you don't specify any custom name, it is going to take whatever the project artifact ID and version, it is going to create with that name. But here we want to create with a custom name. So we are specifying that different name here. And one thing to remember is by default, Spring Boot Maven plugin is going to use Buildpacks and create a Docker image that is suitable for AMD architectures. But right now I am using Apple MacBook, which is a ARM architecture based. So in order to customize and make it work for my ARM based architecture, I am going to use a different builder, which is going to create a Docker image that is compatible with my ARM architecture. If you are running on Linux or Windows, I don't think you need to configure this. But if you are on Mac M1 based laptops, you should be able to configure this and build the Docker image. So with this configured, now let us go to our console and how we can build a Docker image. So here I am using this command menw pl catalog service, that is to specify the submodule. So here I am specifying catalog service submodule, and I am using spring-boot build-image. So this is the plugin goal that we can run to build a Docker image. And while building the Docker image, I don't want to run the test, so I am skipping it. So now I am running this command, and as you can see, behind the scenes it is going to use cloud native Buildpacks, and then it is going to build a Docker image. So here, if you are running it for the first time, it is going to take some time to download all the dependent tools, and then it is finally successfully built the image, and it gave this name SivaPrasadReddy / bookstore catalog service and latest tag. So this is how simple we can create a Docker image for Spring Boot applications. So the first one is done. We are able to configure that and we are able to build this. So next thing is create a Docker Hub access token. So I have logged into my account, and if I go to my account page, and here if you go to security tab, here you can create a new access token. So here you can give some description, and then you can specify a read, write, delete, or read, write only. What are the permissions you want to give? At least we need to have read, write, and you can generate a token. And once the token is generated, copy that token value, and we are going to go to our code repository here and go to settings. And if we take a look at secrets and variables and actions, so here we are going to create a repository secrets. So the first one is our Docker Hub username. So my Docker Hub username is SivaPrasadReddy, and I'm going to create another one, Docker Hub token. So here I'm going to paste my secret value, Docker Hub token, access token. So I will update it later. So once I created these two, I should be able to use, there is a GitHub action called login action. We can use this login action, and then we are able to log in into our GitHub account, or sorry, Docker Hub account. So let us copy this and go into here. So after building our application, we are going to log in into Docker Hub, and then we specify Docker Hub username and Docker Hub token. So here we successfully log in into our Docker Hub account. So next is we are going to build Docker image and then push it to Docker Hub. So let us see how we can do that. So here we have added another step to build and publish the Docker image. Here we are running the same Spring Boot build image goal, and then we are skipping the test, and we are finally, once this image is ready, we are pushing same username / this is the name it is going to be creating, right? So we are pushing this image to Docker Hub. So one thing to remember is we don't want to do this for every branch. Only whenever the code is merged to main branch, then only we want to perform these two actions, logging into Docker Hub, and so we are going to add this if condition that says only if the current branch is main, then only we are going to perform these two steps. So this is how you can configure your GitHub actions to log in into Docker Hub and then build the Docker image and push it to Docker Hub. So our GitHub actions configuration is also ready. But before pushing it to our code repository, first let us locally build the Docker image and then run entire application in Docker Compose and then verify everything is fine or not. In our deployment Docker Compose folder, we already have infra.yaml where we are going to create all the dependent services like catalog database, order database, and Keycloak, RabbitMQ in this infra.yaml file. And all of our application services like catalog service, order service, they are going to be defined in apps.yaml file. So here I'm configuring the catalog service like this. As we have seen, we are going to use the image /bookstore catalog service. So this is how this is the name we have given to our catalog service. Okay, and here we are giving the container name as catalog service, and we need to provide some environment variables to be able to connect to the database. So earlier, if you take a look at our application.properties of our catalog service, we are specifying db_url as an environment variable. If this value is present, it is going to take this, otherwise it is going to take this default URL. But now that we are running both database and our catalog service in Docker containers, so the names will be different. It is not going to be localhost. It is going to be the container name of database. So we can override these properties using environment variables. So Spring Boot already provides one mechanism where if you want to override any of its configuration properties, we can provide them as environment variables, but with a capitalization and using underscore instead of dot. So for example, we can override like this. So underscore capitalized, and instead of dots underscore, you can provide this value like this. But however, I personally prefer to configure our application properties like this with some language independent way, like whether you are using Spring or some other framework or some other programming language, it shouldn't matter. So simply you can configure the environment variable using db URL, db username, and db password like that. So that is why I have given configuration like this. So now instead of configuring the environment variable like that, we can use db URL equals to JDBC PostgreSQL, and here this name is whatever the name we have given to this container. So this is the container name. Okay, this is going to become the host name. So that is what we are going to use. And also the port is containers port, not the port that is mapped to host, not 15432, it is 5432. So both containers are running inside a Docker. So we are going to take this as the host name and this as the port number. Okay, so that is what we configured, and also configured DB username and DB password like this. And this service is running on 8081, and I am also mapping it to host 8081. And also here I am mentioning this service is depending on catalog DB based on the condition that service healthy, which means when you run this service, it is going to wait for catalog DB to be up and running and also healthy. So here we have defined some health checks. So until it is fully up and running, our service is going to wait and then start the application. And finally, here we are limiting how much memory it should take by this container. Okay, so this is all for now. Going forward, whenever we are adding a new service, we are going to add more and more services to this apps.yaml file. Okay, so now we have our configuration, everything is ready. Like earlier we have used a Taskfile so that we don't have to manually run all those commands, right? So similarly, we also going to expand this to run the services as well. Earlier we have defined infra DC file. Now let me add apps.yaml file. And earlier we have defined build, just verify, but we are going to actually run Spring, so catalog service and Spring -boot : build image -d skip test. So when we run build, it is going to run this one, and it is going to build the Docker image. Next, similar to how we have start infra, stop infra, and restart infra, we are going to create start, stop, restart commands that is going to start not only infrastructure related things but also our applications. So how we can do? So I'm removing this infra. And here earlier we mentioned only infra.yaml file, but when we run just start, we want to run not only infra but also our application. So here I'm going to change apps. So let me add this to here as well. So basically for Docker Compose, you can specify multiple files, -f and file name, -f and file name. So I'm simply using that. And for restart, again, I'm stopping it first and then sleep for some time and then starting again. So with this, one thing I would like to do is whenever I run start, I would also first run this build command. So how we can do that? So like this. First we are specifying the dependency. So whenever I call start, I would like to first build it. Okay. Now let us go to console or terminal here. And first let us make sure containers are not running. So first here, let me remove it. Okay. So now let us check simply by running task start. So first it is going to build the Docker image here. So now both the catalog DB and catalog service started. So now let us go back and here you can see both of these containers are running. Now let us verify whether we can make an API call here. So here I am calling localhost 8081/API/products. So here I am able to get the response, and let me test for getting one product. Okay, so I am able to access this one also. So locally for running both catalog service and then dependent DB is now as simple as running task start. So if you make any changes and you want to restart, simply call task restart. So it is going to be very handy during the development time. I have pushed the changes into our repository, and automatically the GitHub Actions pipeline got triggered. So here you can see it ran all the tests and everything, and then it is able to log in into our Docker Hub account, and then it built the Docker images, catalog service, and then finally push to Docker Hub. So here. So it is successfully be able to build and push the image to Docker Hub. Now let us go to my account, and then when I click on the repositories, here I can see BookStore catalog services published into my Docker Hub account. So that is how we can completely automate this building and pushing the image. So I think we are done with building the catalog service for now. We are done performing all these subtasks, so I am marking it as done and I am moving it to done lane. So I think that's all for catalog service. In the next video, we are going to start working on order service. In this video, we are going to create our order service, and we are going to do the common order service setup just like the way we did for catalog service. And then we are going to understand how RabbitMQ works and what are the kind of messaging pattern it supports. And we are going to configure our Spring Boot application with RabbitMQ integration. I have created a card for setting up order service. So here again, similar to catalog service, I have listed down what are all the subtasks we need to do for setting up a walking skeleton of our order service. So while building this order service in the last few videos, we have extensively talked about various things like how to structure our code into various packages, and how to add a Spring Doc Open API, Rest Assured, and Git Commit ID plugins, Spotless plugin for code formatting, and how to set up GitHub Actions for building and creating a Docker image and pushing it to Docker Hub, and how to set up Flyway migrations for setting up the database tables and all. And finally, how we can configure our Spring Boot Maven plugin to create the Docker image with a custom name. So all these things we have extensively discussed and then implemented for catalog service. So I'm not going to again repeat all of that. So what I have done, I have created order service with the starters that we need for our order service, and then I have set up the common things which we have discussed here in our repository also. So let us take a quick look at what we are going to select here. So we are going to build a RESTful API and dev tools and configuration processor for local development, and we are going to use Spring Data API with Flyway and PostgreSQL. And a new thing is we are going to use RabbitMQ, where we are going to publish the order related events to RabbitMQ, and notification service is going to consume them. And we will use some validations, Actuator, Prometheus for monitoring, Testcontainers for testing and local development, and resilience for J is for applying resilience patterns while communicating with the catalog service. So these are all the starters we need to add, and then I have generated the application and copied the code into our repository. So in the root pom.xml, I have added this module order service, and then within the order service, so I have added all these customizations for our Spring Boot Maven plugin. I have added the custom builder for ARM based image generation and gave the custom image name, and added Git Commit ID plugin and spotless-maven plugin for code formatting. So this we have already discussed all these things earlier. And also we have added Spring Doc Open API and Rest Assured for testing. So nothing new here. And in addition to that, if you take a look at our application here, again there is nothing much yet that is order service related. So I have created an exception class called order not found. So we are going to need this in the upcoming API implementations. And again I have GlobalExceptionHandler. Again, this is very similar to how we have implemented for catalog service. And regarding the configuration, so this is, we are all familiar with it. And one thing to remember is by default we are using port 25432. For catalog service we used 15432, so that is a different database. And RabbitMQ configuration, we are going to configure our RabbitMQ in the Docker Compose, and we are configuring this default values. So this is one. And next we have created Flyway migration scripts. Here in our service we have simple two tables. One is orders and another one is order items. So in the orders table we have default primary key and a generated order ID number and username who placed the order. So as of now we don't have any security in place so that we don't know who is the logged in user who is placing it. So for now we are going to statically use some name, but while integrating with the OAuth security we are going to use the actual logged in username. And then we are going to capture who is the customer this order is placed for, and what is the delivery address and the status. So all these things, again order items, for one order there could be multiple items, so we are going to capture all of that here. So this is a simple order related tables we have here. And under SRC test Java, again this is very familiar. When we generate with the test containers, it is going to generate this, and then we refactored the configuration to a containers config. So here is one new thing in the sense, earlier we have seen a Postgres container definition. In addition to that, because we have selected RabbitMQ in our starters, it is going to add this RabbitMQ container definition as well. And by default it is going to it came up with latest, but I have used some actual version here instead of giving the latest. And again we are familiar with this base abstract integration test class. And then this is the default test that is generated. So this is the common setup that we have done. In addition to that, I have created another order service YAML file under GitHub workflows. So again it is very similar. We are going to check if there are any changes under order service only, then this pipeline is going to be triggered, and we are going to build this and then log in into Docker Hub and then push into Docker Hub this custom image name. So this is workflow setup. And the next important thing is in infra, earlier we have configured catalog DB. Now we are going to use a different database instance, not the same database instance. We are going to use another orders DB. Again, we are going to use same Postgres 16, and we are giving the container name orders DB here, and same configuration. So this is BookStore RabbitMQ. Here we are using RabbitMQ, and this is the custom container name we are giving, and we are specifying if these are the defaults, but if you want to change any value for username and password, you can change it. So these are the values. This is the AMQP port, and this is the web UI port. So once we start this, we can go to this port, and then we can see web UI for RabbitMQ. And here is the health check. So this is the common setup we have that is ready to start with order service actual feature development. As discussed earlier, we are going to use RabbitMQ as our messaging system to communicate between order service and notification service. So the use case here is when a customer placed an order, we are going to send a notification email to the customer saying that your order is successfully placed. Or when the order is successfully delivered, we are going to send an email saying that your order delivered successfully. Or if it is cancelled for any reason, we also send an email notification saying that your order is cancelled for so and so reason. So then why to use messaging system, any messaging system at all? Why not create an API endpoint in notification service and call from order service? Why should we use a messaging system? So the reason is when we are designing our application using microservices architecture, we need to think about failures and be able to gracefully handle those failure scenarios. For example, what happens if the notification service is down? When a customer placed an order and our order service is up and running, we received the order, we persist the order details into our database, and then we need to send a notification and assume notification service is down. So how do we handle that? So we need to think about can we handle some of the use cases in a asynchronous fashion? Not everything needs to be in a synchronous communication. So here, just imagine we received the order, we persisted the order into our local database, Postgres, whatever, and then later we process them in an asynchronous fashion. So first we send a message to one of the messaging system, and then notification service can consume that and process it accordingly. So in this way, there is no need for notification service up and running. Even if it is down for some time, whatever reason, still order service can continue to take the orders, and then they simply put the message to RabbitMQ and they can forget about it. So at that time, if the notification service is already up and running, well, it is able to receive the message and then process it immediately. But if it is down, maybe after 10 minutes or even 1 hour, if it is back up, then it can continue to consume those messages and then process it. So this way, this processing is loosely coupled, and even though both systems are not up and running at the same time, the application still continue to function. So that is the benefit of using asynchronous communication with messaging systems. So that is why we are going to use RabbitMQ as our messaging system, and then implement sending the notification emails using this asynchronous communication way, instead of making an API and then calling it from order service. Then the next question could be, then why RabbitMQ? Why not Kafka? Why not some other thing? As I discussed in the previous microservices introduction video, in this particular application context, RabbitMQ provides sufficient capabilities to handle the scenarios. But if we have a different scenario, maybe we can go for other more feature-rich platforms like Kafka. So let us understand how RabbitMQ works, because RabbitMQ is slightly different in its behavior than other messaging systems like Kafka. So if you are coming from a background where you have used Kafka, it is slightly different. So it is important to understand how RabbitMQ works differently. So here, if you have used JMS like old messaging systems, ActiveMQ, like they are also a little bit different, where a producer sends a message to a queue, and there can be consumers to that queue which directly receives the message. Similarly, there can be topic. If you want to publish and have multiple subscribers, there can be topics where a producer publish a message to the topic, and there can be a number of consumers, and each of them receive a copy. So that is how those traditional messaging systems work. But here with RabbitMQ, there will be an exchange, and as a producer, once you send a message to this exchange, you send it with a routing key. So based on the routing key, it is going to forward that message to one or more queues, and each queue can have one or more consumers, but at any point of time, only one consumer will receive a message. So what is this Rabbit routing key? What is this bind key? So let us understand that. So think of it like a post office, where if you want to send a mail, you don't directly send it to the person, right? You send it to the post office by writing an address to it, and then they deliver it to the home, right? So in the similar way, you always send the message to the exchange and specify the routing key. And there are different types of exchanges, and there is a mechanism where you bind each queue to this exchange with a specific type of routing key process. And then based on that, exchange will forward that message to one or more queues, and consumers will consume it. So let us understand what are the exchange types. So first, there is a direct exchange. So it is the simplest among all the other type of exchanges, where you simply specify some key equals to routing key equals to some value, and it is as simple as that. And whenever a producer send while binding this queue with the exchange type, you specify all the messages with a particular routing key equals to this value should be sent to these queues. So if you have a direct exchange, you can configure like this is orders queue, where any message with routing key equals to orders, forward them to this queue. And probably this is accounts related queue, and any message that comes with routing key equals to accounts, forward them to this queue. So like that, it is a very simple process, and there is no wildcards or anything like that. You just specify routing key equals to some predefined straightforward string, no wildcards, nothing, no pattern matching, nothing. So that is the direct exchange. And there is a second type like topic exchange. Topic exchange provides the capability of where you can specify the binding pattern with a wildcard patterns. What does that mean? So when a producer sends a message to this queue, and these queues will be bind with the exchange supporting a range of wildcard patterns and like this. So here you can specify orders.new.star. This is the binding key for this queue. So any message that comes with a routing key that fits with this pattern, orders.new. Let's say Hyderabad, orders.new.Bangalore. Let's say they are suffixing with the city name based on the delivery address. So all these messages can go to this queue. Like that you can configure. It is not an exact match like a direct exchange. It can be a pattern with wildcards. So like that you can configure. So based on that, whenever a producer sends a message, it compares that with the patterns of these bindings and automatically forwards that. So which means, let's say you send you can configure multiple queues, and if the message that received by exchange is matching with multiple queues, a copy of that message will be forwarded to each of those queues. So all the consumers will receive a copy of that message. And finally, the fan out exchange is, it doesn't care about binding key. Like whenever, if it is a fan out exchange, every message it received, it will automatically forward to all the queues that are bind to this exchange. It doesn't check what is the binding key or routing key. It just forwards every message to all of the queues that are bind to this exchange. So it is like a simple broadcasting message. And one more thing is, usually if there is only one consumer, it will always receive that message. But if there are multiple consumers for a queue, only one consumer will receive a message at any point of time. That means they simply follow round robin algorithm and then keep receiving messages by different consumers from the same queue, and they won't receive the same messages by both consumer 3 and 4 at all. So only one of the consumer 3 or 4 receive the messages from this particular queue. So there are other types of exchanges as well, but most of the commonly used are these 3 types. And in our case, direct exchange itself is sufficient for our scenario, where our need is, whenever an order is placed, we send a message with a key that orders new orders, and orders delivered, orders cancelled. So it is a very simple process, and in our case we can simply use direct exchange, or if there is a need for more consumers, then maybe we can go for topic exchange also, but in our case direct exchange is sufficient. So we are going to follow this direct exchange pattern, and we are going to implement our use case. So first I am making our configuration, RabbitMQ configuration properties in application.properties file. So here we are having a common prefix orders, and then we are defining the exchange name, orders exchange, and then we are defining queue names for 4 different queues: new orders queue, delivered orders queue, cancelled orders queue, error orders queue. So these are the queue names here. So after defining this, we are binding this to the application properties record with the prefix of orders. So all these values are going to be populated into these values here. So now we have a created a RabbitMQ configuration file, Spring Boot configuration class. So here we are taking this application properties injected into it, and then so this is the first bean we are creating with direct exchange. So here we are taking the order exchange name and then creating the direct exchange. So this is the first thing. So next one is we need to define a queue. So here we are creating a durable queue and we are taking the new orders queue. So here this is the new orders queue name. So it is taking the queue name and then defining a queue as a bean. Next we need to bind our queue with the exchange, and so here we are binding it like this. We are binding the new orders queue to the exchange, to our direct exchange, with new orders queue name only. So here it need not be exactly the queue name itself. So here you can even put orders new or new orders key. So anything you want. You can have another configuration property to define the routing key, but simply I am using the same order queue name itself as the routing key. But if you prefer to use a different routing key, you can configure. So it is as simple as that. So with these three, what we are doing, first we are defining a exchange, and then we are defining a queue, and then we are binding that queue to the exchange with a routing key here. So the routing key name happens to be the same as queue name, but it can be different. So once we have a configuration like this, we can do similar thing for other queues as well. So again, we are defining another queue as a bean, delivered queues, and then we are taking the deliver order queue name, and again configuring a binding to the deliver queue with exchange with the same delivered queue as a queue routing key. Same for cancelled orders binding here. So next error orders, and then binding. And finally we are going to use a RabbitMQ template for sending the messages and all. And what we are doing is, when we send a message, we are going to send a bean, and then we are configuring Jackson to JSON message converter such that it will automatically convert the message into JSON structure and then send it to the message queues. So it is going to perform automatically with this configuration. So with this configuration in place, and earlier we have already seen configuring our RabbitMQ in our infra file, Docker Compose infra file, and I have already started our components. So we have catalog DB, orders DB, and RabbitMQ started. And as I already mentioned, we can even access the GUI of RabbitMQ on this 15672. So let us check that. So here I am accessing localhost 15672, and I can use guest as credentials, and I can log in. So right now if you go to exchanges, so these are the default exchange automatically created when you start the RabbitMQ. Now I am starting the order service application here, and once the application is successfully started, it should create the orders exchange and then create all these queues that we defined in our RabbitMQ configuration file. So here we can see it is connected to RabbitMQ here. Now let us go ahead and check. In here we can see orders exchange is created. Now if you go into orders exchange, we can see cancelled orders is bound with this routing key cancelled -orders. Similarly, there is delivered orders, error orders, new orders. So all of them are bound to these respective routing keys. So now we have configured, and these queues are configured. Okay, now let us verify whether we can successfully send messages and receive messages by writing some sample code using Spring Boot RabbitMQ integration. So for demonstration purposes, I have created a controller here is my controller here. So what we are doing, we have a RabbitMQ demo controller. We injected Rabbit template and application properties, and then I have a API endpoint /send, which takes a my message record as a payload, which contains routing key and my payload. Payload contains simple content property. So here I can use Rabbit template convert and send method. So the first argument is the exchange name, and we have that name configured as part of our properties. So we are calling order event exchange. And then the next one is we need to send routing key. We are taking this routing key value from the payload itself, so that we can test sending a message to orders new queue, order delivered queue, like that. And finally we are taking the payload here. So this is the sending part, and we can also write a listener very simply using annotation approach. So here we have two listeners. One is pointing to this new orders queue. So this is the configuration property we have in our properties file. So this is the property name. So that represents the queue name here. So we are specifying that queue name here, and we are handling the payload. And similarly we have another listener for delivered queues, delivered orders. So this is how we have two listeners. So now let us verify by sending a message to this API endpoint and verify that. So here I am going to my postman, and here I am sending localhost 8082/send, and the JSON payload is routing key new orders. So this is nothing but same as our queue name. So if you go to here, so we have used the same queue name as the routing key, if you remember. So we are using this new orders as the routing key, and I am sending the payload content order created with ID 1234. So now I sent the API request, and now if I check in the logs, I can see I received new order created with ID, that is coming from our listener. So similarly, if I send a message to this delivered key orders, order delivered with ID 123. So now it should route to with this routing key, it should route to this delivered orders queue, and our listener should receive it. So now if we go to so here you can see delivered order delivered with this. So that message is coming from this listener. So we can confirm that our configuration is working fine, and we are able to send a message and receive a message. So but anyway, we are not going to receive any messages from this application here in the order service. We are going to receive like this from notification service. But we can confirm that our application configuration with RabbitMQ is fine, and we are able to send and receive the messages as well. So in the next video, we are going to start building our API endpoints for taking the order. We have our order service created with the base skeleton code ready, and also we have configured a RabbitMQ, and then we have already verified how to send a message and then receive a message. So we are ready to implement our next API endpoint, like create order API. In this video, we are going to implement that create order API, and also as part of this, we are going to explore how to use records as JPA embeddables, and then we are going to cover how to unit test controllers using Spring slice test annotations like @WebMVC test. And we are going to write our unit integration tests using Testcontainers, and also we are going to take a look at how we can use a library called Instancio for generating the test data. So usually while writing tests, we need to populate some beans and then use it. So there are many such libraries, but I personally like this library, so I'm going to demonstrate how we can use this library to generate the test data. So let's get started. Let's take a look at what we are going to do as part of implementing this create order API. In the earlier videos, we have already created Flyway migrations for creating orders and order items tables. So in this video, we are going to start with creating order entities, order and order item entities, and then we start building our API endpoint, post API/orders. And as we discussed earlier, currently we have not yet implemented any security, OAuth based security, but every order will be placed by some logged in user only. So in this video, we are going to create a dummy security service which simply returns one static username, pretending that that is the order placed by user. And we are going to write unit and integration test for this API endpoint. So here you can see what is the request payload would look like. So we are going to capture some customer details and then to which address the order should be delivered and one or more items. So here as part of the items, we are also going to take the product code, what is the name of the product and price and quantity. And if everything is successful, we are going to return 201 created with the order number. But there could be scenarios where you receive an order where product code is invalid, which does not exist, or if the price is incorrect than what it is there in the current catalog service. So we are going to check that and then throw the error. But in this first video, we are not going to compare that by calling the catalog service, that there is another card for that. So in this video, we are going to just take this payload and then store it in the database. And we are going to write test for that kind of scenario. Implementing create order API involves writing a lot of code. So instead of me keep typing while you are watching this video, I thought it would be better to create the code ahead of time and then walk you through each code snippet so that you will be able to understand what we are doing here. So here, first let us take a look at our existing Flyway migration script, which contains the database table descriptions. So we have our first table, orders, which is having a primary key auto-generated from the sequence, and then we have a order number that we are going to generate dynamically, and username represents the user or customer who placed the order, and then we have customer details like name, email and phone, and we have delivery address to where this product is supposed to be delivered, and order status and things like that. Similarly, one order can have multiple items, so we are capturing those details here. So first thing is we need to create JPA entities for representing these orders and order items. So let us start with that. So under domain package, we have order entity, which is a JPA entity. And you know, this is same thing that we did in the previous catalog service. We defined a primary key and then used sequence generator. And then these are common properties, order number, username. So, and we have a set of order item entities. So this is all we know about these things. And here we have one-to-many association from order to order entities, and in reverse we'll have many-to-one from order entity to order. The next important thing here is, if you take a look at our customer details here, we have three properties: customer name and customer email and phone. While we could have created separate properties like this, simple properties like this, there is a better alternative where we can use a customer record or even class, but record is simpler and better. So here I have created a record called customer, and then I have properties name, email and phone, and I have already added this Java bean validation annotations to validate the name should not be empty and email should not be empty, phone should not be empty, and email should be of email regex pattern matching. So once we have this record, we can use that, and then we can use that as an embeddable, and here we can provide this attribute overrides saying that how we want to map this customer property names to column names. So that way we are specifying store the name property value into the column customer underscore name. Store the email property value to customer underscore email. and phone values to customer underscore phone. So here right now we have this mapping, and when we store our object using JPA, it is going to store all these values into these respective columns. So easy, we don't have to separately manage all these properties. And even better, in the next scenario, let's say we have our delivery address. Here if you take a look at it, there are 5 or 6 properties that belongs to the delivery address, and instead of writing each of them as a separate properties, we are simply using this address and then using that as embedded object, and we are mapping with this attribute overrides how each property is supposed to be mapped to a different column. So the benefit with this one is, right now we are just storing the delivery address. Maybe in the real applications there will be other billing address also. So in that case you can simply replicate this, and then you can specify instead of delivery address you will have a billing address also, so that you don't have to create a different classes, or you don't have to write all these 10-20 properties separately. You can reuse the same object and still be able to map to different columns. So that is the advantage of this one. And one thing to remember, right now we don't even have this at embeddable annotation. Earlier you are supposed to have this class and with at embeddable annotation, but in the recent versions like Hibernate 6.2, we don't even need this annotation. We can directly use it like this. And also these records, we can use records instead of classes also. So next we have order status enum, again with the different statuses. It can be one of any of these states. So we are mapping that using enumerated using string, not as a ordinal number. And order can be cancelled. So when it is cancelled, we need to store what is the reason or any other comments regarding this particular order. And we have created it and updated it. And when we create an object, we are automatically taking the current date time here. And also usually when we create an any JPA entity, we want to store the created at once and never update it. So we usually don't want to update the created time. So we can set this updatable to false, so that this property won't be updated, this column won't be updated, even though when you are changing the status and then storing it into database. And we have this updated it. So now let us take a look at our order item entity. Again, these are straightforward properties, and we have a mapping back to many-to-one association, and we are saying optional is false, because obviously without associated order there shouldn't be order items. So we are specifying that here, and that's the entities. And again, if you remember, these are package protected, so this doesn't expose to outside of the package. So there is no public for this class. For order entity or order item entity, these are not public classes. So now that we have our entities created, we have order repository, which is extending from JPA repository, and this is the entity type, and this is the primary key. So while using Spring Data JPA, one thing to keep in mind is we usually create repositories for aggregate roots. So aggregate root in the sense, usually when you are talking about orders, first you create an order and order items be part of that order. Without order, there is no order items. So whenever you want to make any change or even create orders or add items or remove items, so if you want to make any changes to an order, you are supposed to do through order entity, not directly doing any changes directly on order item entity. So in that case, we consider order as the aggregate root. So we usually create repositories for order aggregates, JPA aggregates, and do any required operations through order only. Okay, so that's why we don't have order item repository. So we do any operation related to orders through order repository. So we have all this in place, and the next one to take a look at is a security service. As I mentioned, right now we don't have OAuth security implemented, and that is the reason right now I am having a simple method here, get login username, and I am returning a static string here. So there is no logic here. And once we implemented our security, we can determine who is the current logged in user, and then we are going to return that particular username here. Okay, so with all of these covered, let us now start with our API endpoint. So here we have our order controller and mapping the common path /API/orders at the class level. And we have injected order service and security service. We have looked at security service already. We are going to take a look at order service, which contains the most of the logic. So we have one API handler method for create order, which is taking create order request, and then we are looking up who is the current logged in user and taking the username, and then we are calling create order method on the user order service by passing the username and then request. So one thing to remember here, so usually it may be tempting to use, okay, we have order entity or even order DTO. Maybe if we have order DTO also, it is kind of tempting to use those instead of creating another object. But usually while creating an order, or usually any API endpoints, when they take certain payload, it is recommended to create a specific object representing that payload structure instead of simply reusing for other DTOs or other entities. The reason being, if you directly use order entity as the payload, so here when somebody looked at the Swagger documentation, they see ID property, they see order number, they see username, but these are not the values that we are expecting from the payload. Order ID is going to be generated and order number is also going to be generated within our application, not expecting from the client. And username, we are going to take it from our current logged in user context. So these are all not being expected as part of the payload. But if you use this order entity or even order DTO here, the Swagger documentation looks like we are expecting from the people who are calling our API. So it kind of misdirects what we are expecting as part of the payload. So always it is better to create a custom DTO or record, whatever you prefer, that represents clearly what is the expected payload. Okay. So here we have this create order request, which is taking a set of order items and customer and address, delivery address. Again here, this order item is a record. So in the models package, we have address. We have already saw this, and then there is customer, and now we are seeing order item, which again takes code, name, and price, quantity. So we have used Java Bean validation annotations to verify the integrity of this data, incoming data. So now let us go back to create order request, and we also specify not empty. So this set should not be empty. It should contain at least minimum one element in it. And also, because we want to validate this payload according to the Java Bean validation API annotations here, we need to add this @valid, which is going to trigger the validation within the nested object itself. Okay, so this is our payload, and then we have our response. It is simply returning order number, nothing else. So with that said, that is all we have in our controller layer. So basically controllers should be thin, where you just extract the data from the incoming request and delegate the actual logic to service, and then you return the response. So that's why that is a better way to organize your decoupling from the web layer logic. So it can be called from a web API endpoint. This logic, actual creation of order, can be called from a web layer, or it can be called from a job or scheduled jobs. So your service layer should be completely independent of any web related things. Okay. Now finally, let us go to our order service. So here in order service, again we marked it as a Spring service here, and usually the service layer is transactional. That means anything that happens here is going to be performed in a transactional context. It starts a new transaction here and execute everything in this method in a transaction, and if everything goes fine, it is going to commit the transaction. So here we injected order repository, and here within this method, first what we are doing, we got this create order request, and then first thing we are doing is we are using order mapper and convert the request to entity. So here it's a static method because we don't need any other dependency, so that's why it is not even made Spring Bean. It's a simple copying the properties from request to order entity. So here I am manually doing this, but there are libraries like mapstruct where you can configure it to automatically populate the data from request into entity. If you prefer to use that, go for it. And here what I am doing, I am creating a new order entity, and then I am setting this order number to a new UUID number, random number, and then I am setting the order status to new, and I'm populating the customer taking from request to new order delivery address, but mapping order item entity from the request here. So populating all of them and setting it. So just extracting the data from this request and creating the order entity. Simple. So once we have this, we are setting this username into this new order, and then finally we are simply calling order repository.save. This is going to save the order, and we are simply returning create order response with the created order number. Okay, so it is straightforward. We are just taking the payload and then validating it and then storing it into our database. What happens if we are passing invalid payload? What does that mean? So in our create order request, what happens if we are not sending name or email or phone number, right? It is going to throw exception because the payload is invalid. So what kind of exception does it throw? So it is going to throw method argument not valid exception. But currently how it is going to be handled? If you remember, we have our GlobalExceptionHandler, and by default we are extending this from response entity exception handler. So here if you search method argument not valid exception, so this is the exception it is going to throw when we pass invalid payload, means missing any required fields or passing some invalid data. So in that case it is going to throw this exception handler, but this exception handler will be handled automatically in a default mechanism, and it is not it may not be the format that you are willing to return. The error response may not be the format you want to return. So that is why we are overriding that in our global exception handler. We are overriding this method. So here we have this method which is handling that exception. So we are overriding this method in our global exception handler. So what we are doing here, because it is a method argument not valid exception, we can get all the errors that happens in the binding and then iterate through all of them and then fetch all the error messages and make it as a list of errors. And then we are as usually creating the problem details instance, and in addition to other details, I mean here in this case it is a bad request, so we are going to use the status HTTP status bad request, and also in addition to that the custom property we are setting errors is errors. So this is one way of handling how to handle some of the framework level exceptions. Like here, method arguments is not valid, so we are handling it in a customized manner. First, let us validate this implementation through Postman. So currently, we have our infra components running, database, RabbitMQ, everything is running. And right now, let me test with the Postman. So here, let me first start the application. So the application is started. Now let us go to Postman. Here I am passing the payload here with all the fields, and then let me submit it. So everything is fine, and we are getting the order number. This is a generated UUID, which is the order number. So our implementation is working fine. We got the status code 201. So everything is fine. Let us say we have country is mandatory, right? So what if I pass empty value for that? So we are getting the error response, and here you can see under errors, country is required. If there is more than one error, it is going to return all of them. So like that, you can return multiple errors. So the API implementation is working now, and we are able to test it manually using Postman, but writing automated tests is the better approach, right? So that is what we are going to do next. So here is our order controller, and basically you can write integration tests which loads the entire application, and then you can issue a request, HTTP request, which goes through all the controller, service and repository and perform everything talking to the real services, and then you can verify the behavior. That is usually integration test. But also you may want to unit test so that you want to test only the web layer. For example, here you want to test only the web layer for different failure scenarios. For example, in this case, what are the situations we can test this API endpoint? So here we are saying this is the payload, and we have various scenarios here. If you pass a set of items, that is valid, but if you don't pass any items as part of this request, that is one error condition. Similarly, there are many mandatory fields. What happens if you don't pass one of the field? It can be name, it can be email, it can be phone. So any of the fields missing from customer is a error condition. Similarly for address also. So except address line 2, all other fields are mandatory. So there are many failure scenarios that you can test, but here these are all failure scenarios that are going to fail at this binding level only. It has nothing to do with rest of the implementation. So in this case, instead of using a integration test, I prefer to use a slice test which tests only this controller level, so that I can pass different invalid payloads and then simply verify it is going to return bad request or not. I don't have to write an integration test which goes through all of this. Okay, so that's what we are going to do next. So under src test Java and web, we have order controller test, which is a integration test. So again, you should be familiar with from the previous videos. We have created abstract integration test base class, which has @springboot_test. @springboot_test is for integration test. This loads all the components in your application. So you need to mindful of that, because if your intention is to write only web layer component, you should be using slice test annotation like @webmvc test. If you're writing only repository test, you should be using @datasAPI test or JDBC test, whatever the technology that you are using. If your intention is to write integration test, then only use this. Otherwise, you are going to load the entire application context only to test one component of it, which is waste of time. And then we are importing this containers configuration so that when we run that integration test, it is going to run both Postgres and RabbitMQ, and our application is fully ready to serve. So here again we are capturing the dynamic port that our application is going to start. Usually it is a random port, so we are binding it to here, and in the setup method we are setting the rest assured port to that random number here. Okay, so this is the base setup for every integration test we have. So now one JUnit 5 feature is you can write tests in a nested class. So why should we write tests in a nested class? So right now in our order controller we have only one API endpoint, that is to create order. So going forward more endpoints will come, like we want to fetch an order for the given order number, or we want to fetch all the orders for a given username. So more endpoints will be coming up. So here instead of putting all of them at the high level, we can organize them in a nested class so that all the create order related API endpoint tests should be in this class. So it's not mandatory, but it's a good practice. And then next we have first use case where we are checking, given a valid payload, it should create an order successfully. And for that we are creating a payload using multi-line string templates here. So multi-line string support, so you don't have to concatenate all these strings with escaping the double quotes and all that. We can leverage this multi-line string support. So here we have valid payload. We have all the customers information, all the delivery address details, and we have one item also. So the payload is valid. So given that we are passing the payload, so here rest assured can take entire string payload, or you can even pass a Java bean, which is automatically behind the scenes is going to convert into JSON also. So here we are directly giving a string JSON payload, and then we are posting it to /API/orders API endpoint, and then status code we are asserting that it should be 201 created. And within the body we are checking in the response we should get a JSON response which contains order number to some value, not null value. It should be a valid some number. So this is our first test. And the second test should return bad request when mandatory data is missing. So here we are calling a utility method testDataFactory.create order request with invalid customer. So just for now assume that we have a method which creates create order request with invalid data, and we are directly passing that object into payload instead of string JSON payload. And then again we are passing that and then asserting we should be getting bad request. Maybe we can add more assertions, like it should contain, let's say this is the error, right? So we can write another assertion here, just like the way here we can say country is required, or whatever the field we are not passing, we can say verify this is required. Okay, so let us run this test and see. So now it is going to start both Postgres container and RabbitMQ container and automatically configure our application to talk to those containers and execute our tests. So here both of our tests are passed. So that is cool. So next let us take a look at our unit tests. So I have order controller unit tests. Here instead of at Spring Boot test we are using WebMVC test, and also specifying this is the controller I am writing test for, so that it doesn't need to load any other classes or any other controllers. We are just writing a test for this controller. And while using this at WebMVC test, it is not going to load any other beans except the web layer components, which means here our order controller depends on order service and security service. But while using this at WebMVC test, they are not going to be in the application context. So some way we need to provide them to be part of application context. So we are using this mock bean annotation and creating these two order service and security service. So what does this @mock bean annotation do? While creating the Spring application context, by default, while using this web MVC test, it is going to load all the web layer components and a framework level web layer related things. But it does need, our order controller does need an instance of order service and security service. By using this mock bean annotation, it is going to create a mock bean implementation of these two and then make them part of the application context. So they are simply mocks. They don't have any behavior. If you call any methods directly here, it is going to return whatever the default value they are going to return. They are not going to actually call this method. Okay. Now we auto-write the mock MVC and we are going to use object mapper from Jackson to convert object into JSON format. So we auto-write all of these. So both of these mock MVC and object mapper will be auto-configured while using web MVC test. Okay. Now before each, I'm simply mocking the behavior of security service.getLogin username because this is a mock, and when you simply call it, it is going to return null. So we are stubbing this behavior to return some any name. Here I am returning Siva. So now it's a little complex right now, but let us start with simple. So first, when we make an API call, we are going to pass the content, this payload. Let's assume some way we have created an instance of create order request with all the data that we need, and then we are using the object mapper and converting that into a plain string and posting that to API/orders, and we are expecting the status to be bad request. But when we make this call, we also need to specify the behavior of the dependent service. So when we call this, it is going to call order service.create order, right? So we are just mocking that behavior here. So how we are setting up, given order service.create order, and here we are saying if you pass the value Siva for the username and any create order request, it doesn't matter what values does it contain, any value, simply return null, because we don't care what it returns, because it is not even going to that phase also, because we are passing the invalid request payload. It is going to fail anyway at the binding time only. And I believe we don't even need to mock this because our logic is not going to reach to this point. But I'm just explaining, if you are writing another test where you are passing some data and it is going to fail based on the various condition, based on the what it is going to return. So this is how you can stub. Okay, this is how you can mock the behavior of method. Okay, in this case we are going to pass invalid data. I don't think we even need this one. Okay, so basically we are constructing the payload and then posting it and then asserting the status, HTTP status code is bad request. That is a simple process. Maybe you have done this many times also in the past. But one of the best practices to create the test data in a meaningful way. Meaningful way in the sense, we have test data factory class and we have various methods like create valid order request. So without going into the implementation detail, just looking at this method name, we can say this is a method that constructs a valid order request. And here create order request with invalid customer. So it conveys a meaning that it is going to create an instance of create order request, but the customer data is somewhere invalid. Create order request with invalid delivery address. Again, it conveys that we have a create order request that contains some invalid delivery address. Okay, so this is very important, where it is going to be really helpful. Suppose if some new person joins and they want to construct a new object with some use case. So these methods convey really what exactly this logic is doing without even going into the implementation detail. And we can use these methods in various test cases, because it is logically, it reveals the intention of what does this object do, what kind of a data it contains. By calling this method, what kind of object you are going to get and with what kind of a behavior. So from the readability point of view, it is very helpful. You can even, without writing all this, you can directly create order request object and then populate data wherever you require. For example, here we need data with some invalid. Right away here we can create that object. But here everywhere in every test, you are going to end up doing the same logic again and again, just with a slight differences. Especially as and when project grows, it becomes a struggle to understand where else we need to change all that logic. Whereas with these helper methods, it is kind of a centralized, where you can change in one place. Let's say we added one more field. You can come to this place and then we can add this here in a centralized and logical manner. So that is what we have. And here I am using parameterized test. So basically, in our case, we are trying to test the bad payload scenario, and we have multiple such scenarios. As I mentioned, if there is no order items, that is one case. If the delivery address is invalid, that is another case. If the customer data is missing, that is another case. So in that case, one option is to create a separate test for each of those scenarios, or another option is to use a parameterized test, where you can provide a source for that data. So in this case, we are using method source. That means it is going to automatically call this method, which returns an instance, a different instance of create order request. Here we are passing 3. Okay. So by specifying this method source, it is going to call this, and for every iteration, it is going to use one of the object returned by these values, these method invocations, and each of these methods will be passed as the arguments to this method, and we are executing the test based on the given create order request input. So here multiple things are going on. One is, first we are using parameterized test, and then we are using method source, and again within that we want to give a logical name so that while running the test, in the IDEs we can see what kind of a scenario we are executing. So here the first case is creating an order with invalid customer data. The second one is invalid delivery address. So how we can do that? We are going to use this static imports of arguments and then named. So using named, we can give a logical name to this particular use case and pass the actual request data for this test. So this way we can return a stream of arguments which is going to used by this test for every execution. Okay. Now let us run this and see how it displays. So if you take a look at this, it is showing 1 order with invalid customer, 2 order with invalid delivery address, 3 order with no items. So here we have customized this how we want to display the names that shows in this test results pane. So here we are constructing, first we are want to show the index and then the first argument. So the first argument here is this one, the scenario name. Okay. So this is how we can make it more pleasant for developers to show how we can write our test in a more easily understandable manner. So we have seen how to write integration test using REST API and test containers, and we have seen how to write unit test for our controller using slice test annotation. This is called slice test annotation for web layer, and we are loading only controller and mocking the dependencies of this controller. Okay, and then we are verifying it. So if you feel this is confusing or anything, maybe take a look at JUnit 5 documentation and read about parameterized test. It is simply to pass multiple values to this test and use that input in our test. And how to pass these different values? There are multiple ways. One is method source, or you can even say CSV source, or even you can provide enum values. So there are different types of mechanisms to provide inputs to the test. Here we are using method source, which means simply it is calling this method, and here we are passing a stream of inputs. And finally, each of these methods are returning create order request, which we are taking it as an input, right? So these are all these methods are returning create order request. Now coming to how we are preparing this data, this is where I said I am using a data generation library. For test data generation, I am using Instantio. So basically how it works, once we add this library, so here I have added Instantio JUnit dependency here. Once I added that, this is how I can construct. So by default, you can simply say instantio.off whatever the class that you want to create an instance for with some random data. You can and then you can simply call .create. Without any of this, you can simply call instantio.off whatever the class that you want to set the sample data .create. It is going to set the random data. But here we need some kind of some meaningful data for certain fields. For example, for customer email, it should be in a proper email format, like some alphanumeric character and @ symbol and some domain name. So we are customizing how some fields are supposed to be populated. For other fields, it is okay to have any kind of a random type of data. So we are using a different mechanism to set different values. One is generate. So this generate, we are saying for this field, within this create order request, there is a customer within that email. So for that, we are using this generator. So this generator contains several mechanisms, like if we want to generate some kind of a text, okay, otherwise booleans, characters, collections. So there are different ways of generation, and we want to generate using a pattern. So in this pattern, hash A represents any one alphanumeric character. Similarly, if you can use hash C, this is a lowercase character, one character. So here we are saying any 4 or 5 alphanumeric character and then use @mail.com. So we are saying generate a test data for the email field, but in this pattern. Okay. Similarly, for our orders, we want to set some valid product ID values like that. So here we created a static field valid order items, and we constructed some valid data, and here we are directly setting that value for this field, items field. Similarly, for country, delivery address country, we assume we want to use only certain values. So here I have a list of strings and it contains India and Germany. So here we can use this generator where it says one of this list. So whenever an object is created, it will generate country value based on one of these values. Okay. So similarly, here create order request with invalid customer. Again, we are using almost same thing, except that we are saying, so for customer phone field, set empty value, which is invalid. So you can do this for other fields as well, like a phone, if not phone, for email or name, you can. So overall, we are constructing a create order request with phone value as empty, and rest of the fields are same. Similarly, we are following delivery address with invalid delivery address. We are setting the country value to empty. And finally, create order request with no items. So here we are setting create order request with the items as empty set. So this way you don't need to worry about writing all the code for setting all the fields. For example, here it is, though it looks simple, we have a set of order items and then customer. Within the customer there are multiple fields, within the address there are multiple fields, so it might require a lot of boilerplate coding, whereas with this instancio it is simply populating all these fields. So we can see when we are running this, let us just print the request object. So I'm just printing the request so that we can see what kind of a data it is generated. So here for the first scenario, we can see it generated with order items, and then for customer it generated a random name and random email, and phone is empty, and delivery address with random values. Okay, for invalid delivery address, again it populated valid items, but customer is valid, delivery address, country is empty, and for all others you can see it is all some random data. So for last, items is empty, others are valid data. So like that you can use this library to set up your test data in a meaningful way. We have implemented the create order API in its bare minimum format, like we are just taking the payload and doing some basic validations and then storing it. But there is a little bit more to this API endpoint. So once we receive the payload, we need to call catalog service and then verify whether there is an actual product with this code and is the current price is matching with what we received as part of this request. So if either product is not there or if the price is not matching with what catalog service is having, it is an invalid request. We should respond with a bad request. So for that we are going to implement a client for catalog service in our order service, and then we are also going to look at how we can use resilience for J for handling what if the service is down, what if we want to retry. So we are going to use resilience for J and then implement that circuit breaker pattern and retry mechanism, okay, with a fallback. So that's what we are going to do in the next video. I guess we have a basic implementation of creating order API ready. So we are going to tackle the upcoming parts, like once we perform the order validation by talking to the catalog service, we also need to publish a message to the RabbitMQ saying that a new order created event happened. So we are going to tackle that in the upcoming videos. We have implemented create order API in its minimal form right now. That means we are taking the order payload and then we are checking basic validations, like whether the customer information is present or not, whether the delivery address information present or not, and whether order items contains at least one item or not. These kind of basic validations we are performing. But we also need to verify whether the product information like product code and product price are valid or not by calling catalog service. So that's what we are going to implement in this video. Also, we need to, when we design our application using microservices architecture, we need to think in terms of how to handle failure scenarios. I mean, we are going to call catalog service from order service. We need to think about what happens if catalog service is down. What happens if catalog service is getting too much traffic and it is serving request very slowly. And we need to design our order service in such a way that it should gracefully handle the failure scenarios when talking to catalog service. This is where we need to apply some resilience patterns like circuit breaker, retry mechanism, timeouts. We need to apply all these things. So in this video, we are going to use resilience for J for applying all these patterns and then implement our catalog service communication in a more resilient way. Okay, let's get started. If you take a look at the Spring Framework documentation RestClient section, we can see there are currently 4 different ways you can call other RESTful API endpoints. So here traditionally we have been using REST template for making calls to other REST API endpoints. But in the recent versions like Spring Framework 6, they have introduced two other approaches like RestClient and HTTP interfaces. So if you have ever used Spring Web Flux, you might have been familiar with WebClient, where it is a non-blocking reactive client to call the other API endpoints. So here these two new approaches are introduced that are based on the synchronous client approach. So REST client and HTTP interfaces. So in this video, we are going to use REST client for calling catalog service from order service. So in our future videos, we also can see how we can use HTTP interfaces in a different module. So right now, let's go ahead and implement this catalog service client using REST client. So first let us configure the catalog service base URL in our application.properties file. So here we have configured orders.catalog-service-URL and we are configuring the actual URL of the catalog service. Currently it is our catalog service is running on port 8081. So we configured this value here. Also we need to add this property in our application properties class. So here we have added catalog service URL property, which is going to be assigned this value. Okay. So with this configuration in place, we have created a new package under orders called clients. So inside this, we are going to implement our catalog service client. So first we are going to configure the REST client as a bean here using this configuration class. So here we have injected this for this bean definition method. We are injecting this application properties and we are creating our REST client using the builder pattern, and we are setting the base URL to the value that we are taking from application properties configuration. So this value. So that is going to act as the base URL, and we can specify only the rest of the actual URL endpoint segment. We don't need to put the whole URL for every request. So that is how we created our bean definition for REST client. So once we have defined this REST client bean, let us go ahead and see if we take a look at our catalog service API implementation. Under web we have controllers. In our product controller we have this API endpoint where we have /API/products, and it is going to this second API endpoint is going to take a /product code and then identify a product and then return product. So this contains code, name, description, image URL and price values. So this is the response we are going to get. If there is no product, it is going to throw product not found exception, and then we are going to get 404 error. So this is the endpoint we are going to call. So right now, in order to receive the product information, we also created this record in our catalog package. So we are going to get this response. If it is successful response, we are going to get these fields in the response. And then this is the actual client. We are going to use REST client to make the API call to this product catalog service. So we have defined this product service client registered as a Spring Bean here, and then we are injecting the REST client. Okay, now we have a method here get product by code, which takes code as input, and then here we are using REST client and making a get call, HTTP get call, and we are specifying the URI. So earlier we have mentioned the base URI to the catalog service URL, so we are just mentioning the rest of this actual segment /API/products/code, and this value we are specifying the given code value here, and then we are retrieving the response, and then we are trying to bind the response body to product class. Here this is a record. So if we get a successful response, we are going to bind the response JSON into product class, and we are getting the product bean as a response, and we are returning to this optional of nullable product. So this can be null, so it is we are using of nullable of product. So this is the basic implementation of product service client. But right now we are not handling any retry patterns or we are not even implementing basic try catch block for dealing with the errors. So nothing, we are just assuming everything might go smooth and it is going to be successful. And let us first verify with this implementation, and then we are going to see how things happen when there are failures. Okay, so we have this client implementation. Now let us go to our order service. So here earlier we do not have order validator. We have created a component called order validator and then injected that into order service. And then before proceeding to creating our order, we are calling this order validator.validate. So this is the new code we are calling. Earlier there is no order validation here. So now all the logic is there in this order validator. Again, this is created as a simple Spring Bean, and we are injecting that product service client into order validator here. Now there is a method called validate, and we are taking this create order request, which is coming from our API handler controller. So first what we are doing, we are iterating through all the order items, and for each item we are calling this client.getProductByCode, which internally go and talk to catalog service and get the product information, and it is going to return a optional of product. So we are calling this or else throw new invalid order exception. So when this happens, if it is returning optional of empty, that means the product code, there is no product with the given code. So in that case we are throwing order invalid order exception. Otherwise we get the product information successfully, and then we are comparing order price to item price in the payload that we receive this order price, and then we are comparing with the product price. If it is not same, we are again throwing the exception, invalid order exception. So basically first we are checking whether there is a product with the given product code or not. If it exists, we are then comparing the product prices. If either of these scenarios fail, we are throwing the invalid order exception. So we are not handling it anywhere, which means we are going to handle in our global exception handler. So in our global exception handler, we have added a new exception handler for invalid order exception. Again, this is very familiar, and this is a kind of a bad request scenario. So we are specifying the bad request HTTP status code. So this is how it is implemented right now. Now let us go ahead and run our application and see how it works. So currently I have started all the infrastructure services like catalog database, order database, and RabbitMQ. So I am going to start only order service, which means now if I try to place an order, it should fail in the sense it should say product code is invalid and it should not place order successfully, because it is not able to talk to catalog service. Catalog service is currently down. So let us go to our Postman, and here is our customer information, and we have specified all the valid data, and there is a product here we are saying P100 and then price is 34, which is actually matching, but the catalog service is down. So now when we place this request, it is saying in the detail you can see IO error on get request for this is null. So it is failing, but it is saying status to 500. Can you guess why it is giving 500 error instead of 400? So if you take a look at our product service client, here we are not handling any exception. So when we try to make a call to the catalog service, it is going to throw some communication exception, and we are not handling that exception anywhere. So it is going to bubble up all the way to the controller, and it is going to be handled by this unhandled exception instead of our invalid order exception. So let us implement try catch and then see how it behaves. So here we are right now handling all the exceptions and then returning optional of empty. So if there is any failure in making the call to this API endpoint, it is going to return, it is going to log the error and return optional of empty, and it will be handled by our validate method. Here it is going to check if it is empty, it is going to throw invalid order exception. So let me restart our order service here, and then let us make the same API call. So here now it is giving the 400 bad request exception as expected. So now it is working fine. Now let us all start this catalog service and then see how it behaves. So now that catalog service is going to be up and running, we should be able to successfully place order given if you are passing valid product code and price. So right now the price for product code P100 is 34. This is correct information. So we should be able to successfully place order. Yes, we got the success response. Let us verify the failure cases also. Let us say we are giving some invalid product code and trying to place order. It says invalid product code P100A. So what if we have the product code correct, but we are giving the price invalid? So here it is again saying product price not matching, bad request. So it is behaving as expected. But as I said, right now we are not handling any exceptions in a graceful manner. Graceful manner in the sense we are not trying to perform retries. We are not handling with the circuit breakers, things like that. So in the next section, we are going to first talk about how these resilience patterns will help you to build these resilient applications while communicating with the other services. First we talk about and try to understand what each of those patterns will provide, and then we are going to implement all those patterns using resilience for chain. Let us understand some of these resilience patterns and why do we need to apply them and how they are going to help us. So let us start with the first one, timeout or time limiter. So in a microservices architecture, most likely one service may depend on other service, and in this synchronous communication where service A calls service B, we need to think about timeouts. For example, we might be using different types of HTTP client libraries, like there is some HTTP client as part of the JDK itself, or we might be using some Apache HTTP clients, or we might be using OK HTTP library. So these different libraries comes with the defaults of different types. Some libraries wait for the response indefinitely, or some has defaults like 30 seconds or 1 minute. So you can't just leave with these defaults because they are not predictable. I mean, if you change the implementation to some other library, and it is going to affect because of those defaults. So it is always recommended to explicitly configure what is your timeouts when you are talking to external services, so that even if you try to switch underlying HTTP client library, you will ensure that all these timeouts are applied no matter which client library you are using. So if you are not implying those timeouts, or if you are not imposing those time limiting options when talking to external service, imagine you are this is service A and some endpoints talk to service B, and there are more requests to this endpoint 4 and 5, and more threads are allocated to handle this request, and they are going to indefinitely wait for service B response. Maybe this service B is performing very poorly and it is returning response very slowly, and more threads are going to be blocked and waiting for the response from service B. So in this case, even if there are more requests to endpoint 1, 2 or 3, they are not going to be handled. So it is always recommended to configure the timeout so that it tries for getting the response from service B, let's say for 2 seconds or 3 seconds, and by the time if it doesn't receive the response, it is going to timeout and return the failure, and you can handle in whichever way you want. So it is always recommended to configure the timeouts. So the second one is a retry. So again, While building the application with microservices architecture, we need to always think about how to handle failures or other services being down or being respond very slowly. So all these scenarios. So in many situations, maybe the current load on service B might be too high and it is giving a response poorly, I mean with a slower response times. But if you are going to retry for one more time, maybe you will get a response within the accepted timeout. So it is, instead of just calling service B once and then if you encounter exception, giving it up, you might willing to retry for one time or two times or three times, and then if you succeed in those three times, you can go ahead and return as a response. So instead of just giving up for first failure, you can apply some retry mechanism so that you can try for n times, and if it still fails, you can handle it accordingly. Also, while doing this retry mechanism, it should be configurable, like how much time we should wait for retrying again. Let's say you configure to try for three times, and it should not be like immediately again and again. You make a first call, and if it is a failure, wait for, let's say, 500 milliseconds and then try for second time. So like that, or even you can configure exponential backoff. So you can configure it in a different ways, but you can employ retry to reduce the failure scenarios. And the third one is bulkhead pattern. So let's take this example itself. So bulkhead is a concept that is borrowed from, let's say there is a ship, and if there is a problem and if it is flooding inside the ship, instead of letting water flow into all over the ship, they divide the ship into using bulkheads, so that even if one compartment is compromised, it is not allowing leaking the water into other compartments. So similarly, if we apply the same concept into our applications, let us say service A has few endpoints, endpoint 1, 2, 3, that are not dependent on any external services, but endpoint 4 and 5 are depending on service B. Imagine if we are using the same thread pool to handle all these requests, and if there are initially there are more requests for endpoint 4 and 5, and they are all waiting for service B's response and are blocked because some reason service B is very slow, and all of those threads are blocked. Now even if you are getting requests for endpoint 1, 2, 3, 4, 1, 2, 3, you are not able to serve these requests because all the threads are already allocated to serve endpoint 4 and 5 and they are blocked. So instead of implementing like this, if you separate the thread pool into two, one is to serve all the requests for endpoint 1, 2, 3, and a different thread pool for serving endpoint 4 and 5. So even if there are more requests, only the second thread pool is exhausted, but the thread pool 1 is still available to take more requests to serve endpoint 1, 2, 3. So you can handle in this way, so that if there is a part of the application that are performing poorly, still you are able to serve some other part of the system in an efficient manner. So that is bulkhead pattern. So the fourth one is circuit breaker. So let's again taking this example, if service B is performing poorly, for whatever reason, maybe it is taking too much load and it is giving very slow responses, or for whatever reason it is throwing exceptions continuously for the first 5 minutes or so. So in such a scenario, it doesn't make sense to send more traffic to that service. Instead, if we observe, okay, for the last 100 requests, almost 50% of them are failures, or for the last 5 minutes, all the requests are failing. So if you observe this, and then instead of sending more traffic to that service, you should voluntarily say, okay, anyway, that is going to fail. So instead of sending the traffic to that service, you consider it as a failure for a certain period of time. I mean, this is where we call this circuit breaker, where you open the circuit so that calls won't go through this service. The circuit is open, and then give some time for service B to recover from those failures. And then after certain interval, you forward a certain percentage of request only to check is it recovered, is it getting better now to handle the request, and if some percentage of requests are handled properly, then you can close the circuit, allowing all the requests to flow through to service B. So that is what circuit breaker pattern is. And rate limiter is maybe you build a service, and depending on its configuration, like CPU and RAM, you have certain limit of how much traffic you can serve. So you need to consider that and then implement a rate limiter pattern, so that if somebody is putting more load onto your service, instead of dealing with it poorly, you voluntarily say, I can't handle this much of load. Especially this is very useful to prevent DDoS attacks, or even you might want to apply to handle different customers in a different way. Like you might want to allow more requests from premium customers, or you might want to limit certain calls for normal customers. So something like that. So these are all various patterns that you can use while implementing this service to service communications. So in our application, we are going to use timeout, retry, and circuit breaker pattern. So in our application, we are not go ahead and use this bulkhead or rate limiter, but we are going to implement timeouts and retry and circuit breaker. We are going to use resilience for J for applying these resilience patterns here. And resilience for J provides explicit support for Spring Boot. So here we can add this resilience for J Spring Boot 3 dependency, and it also expects Actuator and AOP, but they are already pulled by other dependencies. And we can configure various defaults for different patterns. For example, circuit breaker, we can define some defaults, and then for retry and for bulkhead. So all these different patterns, there are coming up with various customization options. You can define the defaults, and also you can customize for a specific instance also. We are going to see how we can customize these options. And also it provides annotation based support, where you can simply use annotations like this and define the behavior that you need. So if you want to apply circuit breaker, you can apply circuit breaker using this annotation. Similarly, you can apply retry using this time limiter like this. So we are going to use annotation based approach, and also we can customize some of these properties using in our application properties. So let's see how we can apply these patterns and make our communication from order service to catalog service more resilient. If you remember, while generating the order service, we have selected resilience for J, which added this dependency, circuit breaker resilience for J dependency. But when you check the documentation of Spring Cloud Circuit Breaker, it is a higher level abstraction with two implementations, resilience for J and Spring Retry. Now when I check the documentation using resilience for J, Spring Cloud Circuit Breaker with resilience for J, the auto configuration support is there for circuit breaker and time limiter, but I didn't see any explicit support for retry mechanism. So though it is already pulling the dependencies from resilience for J, I can configure it. It looks very confusing for me, and instead I prefer to directly use resilience for J configuration instead of using Spring Cloud Circuit Breaker with resilience for J. This looks more simpler and straightforward to me, rather than injecting circuit breaker factories and then calling these methods. So what I'm going to do, I'm going to remove this dependency, and I'm going to add resilience for J Spring Boot 3 support. Okay, so with this we don't need this Spring Cloud dependencies configuration as well, so I'm going to remove this, and also we don't need Spring Cloud version here. Okay, so I have added this dependency. Let us take a look at. So resilience for J Spring Boot 3. So it automatically pull all the dependencies. Let us take a look at here. So it automatically add all the framework common here, circuit breaker, rate limiter, retry, bulkhead. So transitively it pulls all the modules that are required for applying various patterns. So it is fine just adding this one dependency. Now with this one, first let us think about how do we apply timeouts. So applying timeouts with resilience for J is a little bit tricky because let us go to check time limiter. So here for applying time limiter, the function that you are trying to apply should be returning a completable feature or something similar to that. So we need to change our implementation of this product service client. Instead of returning optional of product, we may need to return a completable feature of optional of product, which really doesn't make sense to me because I want to return this optional of product. The reason being why it should return completable feature from the perspective of framework, right? So currently you are running your logic on a thread and you are about to call some method which is you want to timeout. So you should not run the same method on the current thread. Instead, you should start it on a separate thread so that you can put a timeout, and then if you are not able to get the response within that timeout, you should be able to cancel it. So this method call, whatever you are trying to put timeout, should be run in a separate thread. So that's why they are expecting you to return a completable feature. And in order to use completable feature with time limiter annotation here, it's also imperative that you may need to use bulkhead also, so that it will use a different thread pool instead of the default one. So to me, just for applying timeouts, this is not very intuitive. So for applying timeouts, I prefer to simply put those timeouts for RestClient configuration itself. So here if you go to, this is where we are registering our RestClient. So there is an option where you can specify the timeouts for RestClient configuration itself. So that is what we are going to use instead of the resilience for J time limiter or bulkhead approach. So let us add that configuration here. So here what I did earlier, we have configured base URL, but now we are going to customize request factory. So here what we are saying, we are getting the defaults and then with connect timeout of 5 seconds, also read timeout of 5 seconds. So what's the difference between connect timeout and read timeout? So this connect timeout is when you try to first establish a connection to the target API endpoint node, it is going to take 5 seconds. But once the connection is established, successfully handshaken is done, then it is going to wait for 5 seconds to receive the response from the service. So these are two different timeout values that we are applying here. So with this, if we are calling our catalog service and if we are not able to connect within the 5 seconds and then within 5 seconds we are not able to receive the response, then it is going to automatically timeout. So without applying any resilience for J annotations or anything here, now we have successfully configured our timeouts. Now we have both our order service and catalog service both running. Now if we try to make a place an order, it is working fine. We are able to successfully place an order. But now let us simulate slowness from our catalog service. In our product controller in catalog service, let us write a simple method sleep, and it is going to sleep for, let's say, 6 seconds because we have configured 5 seconds for timeouts. So let us make it wait for 6 seconds and call it from our method. Okay, so when this method is when this API endpoint is called, it is going to sleep for 6 seconds before returning the response. But as per our configuration, it should time out within the 5 seconds itself. So let us verify by restarting our catalog service. Now it is going to give the response after 6 seconds only. Then in our case, our catalog service API call should, our order service call should fail. So now I'm going to try to place an order, and now you can see it is sleeping. Catalog service is sleeping and it is waiting, and it failed with bad request because it is not able to validate this product. And if you check the log in order service, error fetching product, and it's IO error and read timeout. So we are not able to get the response within the timeout. So we can see our timeout is applied. So let us change this to, let us say, 3 seconds only, or let us leave it, let us change it to 3 seconds and restart our catalog service. So even though it is waiting for sleeping for 3 seconds, we should be able to successfully place, because our timeout is set to 5 seconds. So now again I'm going to try to place an order. So it is successfully creating the order. So that way you can simply configure your timeouts while configuring this REST client or REST template if you are using for whatever reason. Going forward, it is recommended to use REST client, but for any reason if you want to use REST template, you can also configure the same custom request factory with the timeouts, and you can implement this timeout behavior. So that is how we can apply timeouts. So now let us again change it back to 6. Now let us see how we can apply retry mechanism, because if it is going to sleep for 6 seconds, it is going to fail, and we are going to apply the retry pattern where it is going to retry for let's say 3 times. Okay, let us see how to apply retry pattern now. If you check the resilience for the Spring Boot documentation here, you can see there is a lot of configuration support, and if you go to annotation based support, here you can see if you want to apply retry, you can apply like this. If you want to apply time limiter, bulkhead, circuit breaker, you can use the annotations and then configure it. Okay, now let us see what are all the configuration properties that are available for retry. So here you can see there are several configuration properties. Max attempts is 3. That means if you are applying retry, by default it is going to retry for 3 times. Wait duration is 500 milliseconds. So between successive retries, it is going to wait for 500 milliseconds. So like that, there are many available customization options. So you can tweak it based on your preference and need. So now let us go ahead and apply retry in our product service client in order service. So here I'm going to use @retry, and I'm going to give a name to it. So this is typically called backend name. So here I'm going to call catalog service. And here one thing to take into account is right now within the get product by code, we are having try catch. That means when it is called, even if it is going to fail, it is going into catch block and then it is going to return some value. So from the retry annotation perspective, it is not failing. It is this method executed normally and returned a value. So we should not be handling this error, and let us leave it as is, so that if it is failing, it is going to throw exception and retry is going to try for another time. If you are handling this with a try catch, it is going to assume that this method executed normally and returned a successful result. Okay, so now we have removed this try catch, and let me restart both catalog service. And if you remember, in our catalog service we still have this sleep method which is sleeping for 6 seconds. And in our product service, we are applying a retry. So ideally, we should be able to see it is trying for 3 times, because we have not configured, customized any behavior here. It is going to take a defaults and it is going to try for 3 times. So let us restart order service as well. So let me place an order here. So it is waiting, and let us take a look at the logs. So in our order service, here you can see it tried for first time, second time and third time. And finally it timed out. Okay, so the retry mechanism is working fine. Also, we can apply a default fallback mechanism. So what happens if it still fails after trying for 3 times? Okay, so we can configure a fallback method. Let's say like this. And there are 2 options how you define your fallback method. It should return the same as this return type, which is optional of product, and you can have whatever the name you want to configure here. And there are 2 options. One is you can use the same here whatever the input arguments you have, and you can have one extra throwable argument, or if you don't care about these inputs, you can just have throwable also. So in my case, just leave it to this, which has the input of the original method, and also we are having this throwable. So if you want to handle it in different way based on the exception that is throwing, you can take it into account. So here, this is a business decision what you need to do if it still fails. So it might from the technical standpoint, you might think that okay, you can do some default behavior, but if you think in terms of business, so in most of the e-commerce systems, it is not up to the technical team to decide what to do if you are not validate some order. So most of the e-commerce systems try to take customer order at any cost, and if it is not meeting certain criteria and it is not valid, so it will try to send email to customer and ask them to retry, to check the payment, whatever. So they don't want to lose the business. So if you need to take any fallback action, you need to check with the business what is the expected behavior. Don't assume anything and then implement something. So always check with the business what is the fallback behavior if you are not able to perform this action. Okay, so in our application, we are going to go ahead with returning empty, and then which is going to reject the order, but you need to check what is the expected behavior from the business. Okay, so now with this option, I mean it is going to be same, but we are going to check whether we are able to get this callback invoked or not. So let me restart order service. One more thing what you can do, maybe you can implement some caching where when you first be able to call this API, you can put this product into some kind of a cache using Redis or whatever, and then if it fails in the fallback method, you can take the previous cached value and then compare. So that is another option that you can implement if you want. So now let us just verify whether our fallback method is being called or not. So here it is waiting, and now if we take a look at the logs, so we tried for the first time, second time and third time, and it invoked this fallback method. Okay, so third time also it failed. So instead of throwing the exception, it called the get product by code fallback method, and still it returned the empty, and then it is becoming an invalid order. But this is how you can use the fallback method to implement any fallback behavior. maybe implement caching or take the order and validate it later. Whatever the business wants, you can implement that logic. Currently, we are using the Retry's default configuration. We have given the backend name as catalog service, but we have not customized any of its properties. Let's say instead of default retrying for 3 times, maybe I want to try for 5 times or just 2 times. So I can customize those fields using the backend name. So here, whatever the name that we gave here is called backend name. So what we can do, resilience for j retry backends dot, you can give the backend name here, and you can use all the default properties and then customize it for this specific backend. So here, instead of 3 times, let's say only 2 times, and instead of 500 milliseconds, I want to wait for 1 second. So with this customization, if I restart, earlier we have seen 3 times, it is trying for 3 times. Now we should only see 2 times. So let us restart this service. Now it is up. Now let us go ahead and make a call to this API, and here we should be able to see only 2 times. So the first time and second time. We should not see the third time. Instead, we should get the fallback method. So like this, it's now trying only for twice. Now let us see how we can apply circuit breaker pattern. So similar to retry, we are going to add circuit breaker and give the backend name catalog service. So when we apply this one, it is going to apply the default values, but we would like to customize properties for circuit breaker. So let us take a look at what are all the properties we have for circuit breaker. So here you can see the complete list of properties that are supported by circuit breaker. So there are so many properties right now, but a few of them are very interesting, like a sliding window type, count based or time based. So count based in the sense it calculate the failure rate over the last n number of calls. Whereas if you set it to time based, it is like for the last 10 minutes or whatever the time window you mentioned, it is based on the time instead of the count of number of calls made. So accordingly, you need to set the sliding window size, whether it is a time or it is a number of calls, determines based on the sliding window type. Similarly, there are other properties like minimum number of calls to determine whether it should be in a closed state or open state. So you need to set this one. Also wait duration in open state. So once there are enough number of failures occurred and the circuit breaker is opened, it determines how much time it is going to keep it in the open state. Then similarly, there are various properties like that you can customize. So we are going to customize some of the properties, and then we are going to start the application and see how it behaves. So here, in addition to the retry properties, we are going to add these circuit breaker properties. So here for backend's catalog service, this is the backend name that we gave here. Okay, so now we are saying sliding window type is count based, and for the demonstration purpose, I am setting it to very low values. So here sliding window size is 6. That means for the last 6 calls, it is going to determine this failure rates and all. Minimum number of calls 4. So you need to make at least 4 calls to see the difference. And wait duration in open state is 20 seconds only, and how many calls it will allow to pass through the actual service while it is in the half open state. Also we are setting the failure rate threshold to 50%. So with this configuration, let us restart our order service here. And still in our catalog service, we are still having this sleep method, which is sleeping for 6 seconds. So now let us see how it behaves. Now I'm going to open Postman here, and I'm going to try to place an order. And for the first time, it is trying to actually make the call to catalog service, and it is sleeping for 6 seconds, and then finally it is going to retry for a few times. Let us see the logs. Here you can see it tried for 2 times and then failed. but if you try to make a call again, it is still going to try to talk to this catalog service. Still the circuit breaker is closed, so it is still trying to talk to catalog service. So let us make at least 4 calls, then we can see the difference. So now you can see the response is quicker because you can check the state of the circuit breaker here. If you go to Actuator endpoint and if you go to circuit breakers, here you can see the current state is open because the number of calls is the failure rate is hit, and then currently the circuit is open. You can also see the events, what are all the events happened. So here you can see, you may think why we just made 2 calls, but it is already in the open state because we have a retry, which is we just made 2 calls from end user perspective, but behind the scenes it tried for it tried the retry mechanism twice, so it already made 4 calls and they're all failed. That's why it is already in the open state. So now here you can see the circuit breaker events. So the calls were failed, error, and then failure rate exceeded. So start transition, close it to open state. So the circuit is went into open state. So here the calls are not permitted anymore. But after some time, here we configured to keep the circuit open in 20 seconds and then again try to close it. So now if we try to make another call here, and if we go and check the events, so state transition, here you can see open to half open. Okay, now still our service is waiting and then it is going to fail. It may again go back to open state. So error not permitted. Okay, so this way. Now let us see if we remove this sleep method and then restart our catalog service. And if you try to make a call from postman to auto service, now it is succeeded. Now if you take a look at the log, here state transition, open to half open and success. Now let us make a couple of calls and then it should go into closed state. So it is success, and if you check the status, it is in closed state. So that way we can use all these patterns, like right now we applied circuit breaker and retry pattern using resilience for J, but we have configured timeouts using this RestClient request factory. Okay, so this is how we can apply resilience patterns. And one thing to remember here, we are applying the fallback method only to retry, not for the circuit breaker. What happens if we apply a fallback method to circuit breaker also? When we are using circuit breaker and retry, if you try to apply this fallback method to this as well, so we have seen the order of here. If you go to introduction, if you check the Spring Boot aspect order, right here we have seen, so first circuit breaker is going to be applied before retry, right? So now when you apply this fallback method for circuit breaker also, if it fails, the circuit breaker circuit is open, it is going to call the fallback method and then it is going to return some whatever the value that you are returning from your fallback method. Then it assumes it is returning a normal value, not as an error situation, and it is not going to perform retry. So when you are using these two things together based on the order, you should apply a fallback method to only one of it. So in our case, circuit breaker is going to be applied before retry, then you should apply a fallback method only for retry, so that it only retries for a number of times and it doesn't go into fallback method for circuit breaker itself. But if you want to change the order, like here the current order is first circuit breaker and retry, right? But if you want to change the order, you can configure something like that. So you can change it to retry is second, CircuitBreaker is first. So you can change these values to reverse the order. Okay. Now I'm going to clean up this sleep method. So I added this for demonstration purposes only. So I'm going to remove that and this method call as well. Okay, let me close this out. And now the interesting part would be, so earlier we have written in our order service, we have written our tests to verify. So here we have order controller tests. And if you try to run this test, it is going to fail. The reason being, earlier we do not have a call to catalog service, and it just perform reading this payload and then trying to persist the information. So it all worked out fine. But now it will fail. The reason being, we are going to make the call to catalog service. But here, when we are running this test, there is no catalog service running. We should not assume that it is going to run on some pre-configured value. So how do we handle this scenario? So usually while writing your test for your microservices, if there is any microservice interactions with the external services, we usually mock those calls by setting some expectation. If you are making so and so call, it should return some mock response, something like that. So there are few tools like WireMock and mock server. So you can use these tools and then you can set up a mock response for catalog service interaction, and then you can run your test. So next we are going to see how we are going to use WireMock and make our test pass. We are going to use WireMock for mocking our catalog service integration, and specifically we are going to use WireMock test containers for starting the WireMock server within a container, Docker container, and we are going to use that as a catalog service stub. And if you are not familiar with test containers, or if you are trying to learn test containers and how to use WireMock with the test containers, you can go to testcontainers.com and go to guides, and here you can see there is a guide testing REST API integrations using WireMock. So this guide explains how you can use WireMock for testing REST API integrations with a Spring Boot example. So I would recommend you to go through it, but we are going to follow this guide and implement our API tests here. So the first thing is we are going to set the dependencies for WireMock and WireMock test containers Java module. So first let us get the dependencies, and here I am going to add it under test. So here first one is WireMock standalone dependency with the test scope, and this is the latest version. So that is for using the WireMock API, and we are going to add this WireMock test containers module, that is to start the WireMock server in a container. So these two are the dependencies that I have added. Let me reload this. So once I have this, there are two ways that I can start the WireMock server. One approach would be similar to how we are starting our Postgres container and RabbitMQ container. I can also define WireMock container, and then automatically it will start when I run the application locally or run the test. But I don't want to run the mock server while running the application locally. I just want it to run only when I'm running the test. So I'm not adding WireMock container here. Instead, I'm going to add it in the abstract integration test class. So here, what I'm going to do, first I'm going to define a WireMock container like this. So here I am creating a static WireMock container instance, and this is the container image. So here we are using again 3.5.2 Alpine image from the WireMock. So just defining it doesn't automatically start it. So we are going to start it and then configure the WireMock instance. So here we are starting the test WireMock server. This is the container, and we are going to configure. So here WireMock.configure for. So what we are doing is we are setting the default WireMock server with the host name and port name of the container, so that when we are configuring setting up the mocks or anything, it is going to set it on this WireMock server. So okay, this is the configuration. Next thing we need to take care of is, in our application properties, we have set order.catalog service URL equals to localhost 8081. So by default, when we try to interact with the catalog service, it is going to talk to this service. But what we want to do is, instead of talking to this, we want the catalog service integration to talk to the WireMock server. So what we can do, we can override that configuration property orders.catalog service URL to point to WireMock server. So here I am going to use this dynamic property source mechanism from Spring Boot. So I'm going to override the property orders.catalog service URL. So this is the property we have used for setting up the catalog service URL. So here what we are doing, we are pointing it to the WireMock server base URL instead of the actual catalog service URL. So with this, when we are placing an order and while it is trying to validate the order, when it makes a call to the catalog service, it is going to talk to this WireMock server, not to the actual catalog server. So with this setup, we are ready, but we need to set up the stub. Like, okay, we are going to make a call to this WireMock server. Like how it is going to be /API/products/code. That is the API we are going to call. And we need to set the expectation when I make the call that to that API endpoint, what is the response that needs to be written? I need to set the data. So that's what we are going to do. So here in this base class only, I am adding this method. Let me explain. So here what we are doing, we are creating a mock get product by code method, and we are passing some code name and price, and we are setting this WireMock stub here with if the URL is matching with /API/product/ whatever the code we are passing, and we are saying return the response of content type JSON and with the status code 200, with the body code is whatever the value that we are passing, name and price, and we are passing these values here. So basically we are stubbing whenever we make a call to this WireMock server matching this pattern, return this stubbed response. This is what we are saying. So with this created, now we can come to this test should create order successfully, and we should call mock get product by code. So let me pass whatever the item that we are adding, P100, I'm setting that, and name whatever I want to give, product one only, and here instead of this I'm going to return what it is expecting, big decimal. So new big decimal. So what we are doing here, before making the actual API call to the order service, we are setting this stub mock get product by code with the same product code and name and what is the price that we want to return from catalog service, and then we are making the call. So once we make this call, it is going to talk to, first it is going to talk to this controller, order controller, and then it is going to call this order service, and in the order validator it is going to call this. And actually when this client.getProductByCode is called, we are actually trying to call the catalog service /API/products. But because we overridden that path to our own mock server, so here we have overridden that pointing to our own mock server, and then on our mock server we are setting this stub response. Instead of calling the actual catalog service, it is going to come to this, and then it is going to return whatever the response that we are setting. So now with all this configuration in place, now let us run this. So now it is going to run WireMock container also, and then set the stub, and it is going to try to call the order creation API endpoint. So here we can see both the tests passed. So you may wonder why we set it for only this API, because the second API we are passing the invalid payload, and it is going to fail at the payload binding itself, so it doesn't even reach to the catalog service invocation, so we don't need to mark that API call here. So in the similar way, this is the integration test, right? So what about the unit test we have written using at WebMVC test? So again here, if we are not so here we are directly marking the order service itself, so it doesn't even go to order validator or anything like that. Okay, so if you want to simulate the behavior, what you can do, you can mark it like this, like here you can mark with some value and it will throw invalid order exception. Okay, and you can expect it to be bad request. So I will leave that test as an exercise for you. So here you can mark this use case where when you call order service.create order, it is going to return throw some exception, invalid order exception, and you can assert it is a bad request accordingly. So yeah, right now it is going to pass without any issue. So yeah, all the tests passed. Cool. So I think with this we have completed our task for. Let us go to our Kanban board and check this. We have implemented order validator to call catalog service. We have used resilience4j to apply CircuitBreaker and Retry. We have configured timeout with RestClient. We have used WireMock to mock the catalog service integration for testing. So we have done all of this, so we can move it to in review or even done. So next we are going to implement the next part of this create order API, where so far we have just saved the data by validating it, but also we need to send a message to the RabbitMQ saying that a new order is created. Okay, so that is what we are going to look at in the next video. In this video, we are going to work on publishing the order created event to RabbitMQ. But there is an interesting problem while sending this order created event to RabbitMQ immediately as we create a new order. If you take a look at our current implementation, in the order service, we have this create order method in which we are first validating the order creation request and then persisting the information into our database. So ideally, we can publish the order created event to RabbitMQ here. But the problem is this is a transactional method, which means whatever the operations, database operations we are doing is going to be run in a transaction, which means either all of them are going to successfully commit or all of them are going to be rolled back. But if you send a message to RabbitMQ here, and for any reason, if database commit failed and it throws some exception, and all of the changes you made in this method are going to be rolled back, but your message publishing to RabbitMQ is already happened, so somebody is going to consume that message, but the order information itself is not stored in our system. So that is the problem. So what is the solution to this one? So there is a proposed solution called Outbox pattern. So let us take a look at what is the Outbox pattern. So this is the problem right now we have. In a transactional method, we are trying to make some changes to the database, and then we want to push a message to the RabbitMQ here. And if one succeeds and other fails, that's going to put our system into inconsistent state. So instead, what we can do by following this Outbox pattern is, we make the changes, what are the changes required for our operation into the database, and instead of publishing the message, create a events table and persist the message that we want to send to some other system, to Kafka or RabbitMQ, to whatever the messaging system we want. So put that message into the events table in the database itself and run both of these steps in a single transaction. So that way Either both of them will succeed or both of them will fail. So that is what we want. So here, this is only database related operations that are going to run in a transaction. So either all of them will succeed or all of them will fail. Once this is done, we can have a scheduled job where we can read the events from the events table in the database and then publish the message to queue, and then either delete that message from the events table or update some status as published or something like that. So again, we are having the same problem, right? Like again, we are trying to update the database table and then publish the message. What happens if some failure happen? So the advantage with this one is this scheduled job can retry again after the next interval, and then you can read those events that are not yet successfully sent and then replay it again. But there is a chance that suppose you have published a message to this queue but again failed to update, and when the next run it is going to read the same event and then publish it. So that problem is still there with this approach. So that is the reason why our consumers should be implemented in an idempotent way, which means they should be able to handle duplicate messages. That means for every message we are sending, there should be a unique ID that identifies the event, and then the consumers should somehow store that event ID, and then whenever they get a message, they should check whether this is a duplicate message or not, and then process it accordingly. So then you can think about why decoupling this is not solving this problem. So the real advantage is you are decoupling the process into two steps, so that the first business operation, the key business operation, you can handle it in a proper way, and then later while communicating to the other systems by publishing these messages can be retried n number of ways from the scheduled job. But you cannot do that if you try to apply the same logic here itself, because this is a one-time user operation that people are trying to perform, and you can decouple this and then you can retry n number of times from the scheduled job itself. Okay, so this is what we are going to implement. If we take a look at this card, there are many subtasks, and we are going to do one after another and explain the challenges of implementing database operations and sending a message as a single atomic operation. We did this, explain how Outbox pattern tries to solve this problem. It is also done. Now create order events table and an entity for it and a repository for it and a service for it. So first let us start with order events table. So here I have already made those changes, and I will walk you through how each of these changes are implemented. So here I have created a new migration script in the order service, Flyway migration script, create order events table. So here we are creating a sequence for this primary key, and then we are storing the order number, and we are creating a event ID. This is going to be a unique ID that is going to be generated. Usually we are going to use UUID, and we are storing event type, what type of event it is. So there can be order created event, order delivered event, order cancelled event, order processing failed event. So there are different types of order event types. So we are going to store that information here. And the payload is the JSON representation of the actual event information that we want to publish it to RabbitMQ, and created updated columns here. So this is the table that we are going to store our order events. So then we are going to create order event entity. So again, it is a JPA entity, and we have primary key, order number, event ID, and event type. So I have created an enum that represents different types of events: order created, order delivered, order cancelled, order processing failed. So these are different types of events that are possible. And we are storing a payload, which is a JSON payload, and created it, updated it, and setters and getters and all. So we have that entity. And then we have order event repository. Again, it's a simple JPA repository, and we don't have any custom methods so far. And then I have created under models, I have created order created event. So in this event, I have event ID, which is going to be a generated UUID to make a unique identifier for an event. So next we are storing order number, and we are storing all the items information in that order, and what is the customer information and delivery address, and when this event happened. So why we are storing all this information? So because we want to publish this event to other systems through RabbitMQ, and in our case the notification service is going to consume this information and send an email. So in that they may want to address by saying dear customer name, and then you have placed an order with all these items and it is going to be delivered to so and so address. So they may want to put all these details in the email. So we are publishing all the information as part of this event. And as I explained already, order event type, it could be one of these events. So with that, let us see what order event service has. So I have created a new order event service, and we have save order created event method, where it is going to take this event as an input, and then it is creating an order event entity. So we are taking event ID from that and then setting it as a order created event, because this is of type created, and then order number we are storing it and then created it. And for the payload, we receive this order created event, and then we are converting that into JSON by using object mapper from Jackson library, and we are converting the payload entire order created event into JSON and then setting it to order event, and then we are storing that into our order events table. Okay, so this is one method. And so let us go to our order service. So here I have injected that order event service into our order service, and what we are doing, after we successfully persist the order information into our orders table, I am creating an instance of order created event from the order entity. So I have a helper written order event mapper and build order created event. So it is taking this order entity and creating a order created event. So the first one is event ID. So as I mentioned, we are trying to create a unique event ID, and currently we are using UUID, random UUID as an event ID, and then we are extracting other information required from the order entity, and finally we are returning this order created event. So once we have this order created event, we are calling this order event service save. So this we have already seen. We take the order created event and then convert that into order event entity and storing into order events table. So this is the first part of the story, like this one. We are making the changes, persisting the order information itself and then persisting the event information into order events table. So we have done this first part. Next, we are going to create a job, scheduled job, and then we are going to process those messages. So how are we doing this? So Spring Boot provides this scheduled jobs support, where you need to enable that scheduling by adding this enable scheduling annotation to our main entry point class. Once this is done, you can create a job. So here in our orders package, I have created a jobs package under which we have order events publishing job. So here what I am doing, I have injected this order event service, and then I have configured a property to specify the cron job when it should run. So I have configured that value in our application properties, publish order events job cron. So this is to run for every 5 seconds. So you can change depending on the environment you are running. So for now I set it to run for every 5 seconds. So here this method is going to run for every 5 seconds. So what we are doing here, we are just logging, we are going to start publishing the events at so and so time, and then we are calling this order event service dot publish order events. So what this method is doing, so here we created a sort by option, created it because we want to publish the events in the events created at sort. Based on that order, we should publish the events. So then we are querying repository, order event repository, find all by specifying that sort. So again, here because I am running this job for every 5 minutes, I am trying to get all the records at once. But if you are building a high scalable system and there could be hundreds or even thousands of records for every 5 minutes also, I would recommend to read using pagination. But here we are reading all of the events in a single go. And once we get all these order event entities, we are looping through it, and for each entity we are firing this publish event method in which we are actually publishing the event to RabbitMQ, and then we are also deleting that event from the repository. Okay, so what this publish event is doing, so here we take this order event entity and we are extracting what type of event it is. So currently we have only order created event. There will be more event types like cancelled or delivered. We will handle them later, but now we have only order created event. So it is going to read that from the database. So we already have this order event entity, and we are reconstructing this order created event from the JSON payload. So here again we are using Jackson object mapper and then converting the JSON string into whatever the type we are giving. So in this case we are specifying it should be converted to order created event class type. So we have reconstructed our object into our object from the JSON payload, and then we are calling this publish method on the event order event publisher. So we have created a new class called order event publisher. So here if you take a look at in our domain, we have new order event publisher. So this is a new class that is created which has Rabbit template and application properties injected, and we have this method publish of order created event. So here again we are calling a private method send and property start new orders queue. So this is the routing key. If you remember, we have configured the same routing key as same as the queue name itself. So we are sending that as a routing key and event. Okay, and right now instead of using order created event, we are using object because going forward we are going to publish other type of events also, but here it doesn't matter. We are going to simply publish that event to RabbitMQ. So I generically make it as object type. So once we call this, we are actually calling Rabbit template.convert and send. So the first argument is exchange name. Again we have this configured, so we are calling order event exchange, and next one is routing key. So in this case this is going to be same as the new orders queue, and finally the payload. So RabbitMQ Rabbit template is going to take care of converting this payload into JSON and then publish it to RabbitMQ. Okay, so this is the second part of the story. So here we are publishing it, and then we are already we have already seen from the job we are as soon as we publish the event successfully, we are deleting that event. Okay, so imagine if one of the event is failed, in the next job execution it is going to read that and then resend the same message. So that is why we mentioned it should be, the consumer should be idempotent and should be able to handle the duplicate messages. So now we have all the things in place, and we should be able to place an order and see the message in the RabbitMQ GUI. We can get the message and then be able to see it. So before that, let me Earlier, while demonstrating this publishing RabbitMQ, we have created this both RabbitMQ demo controller, and then we have created RabbitMQ listener. So I'm going to delete this. We have already seen how to publish and consume those messages. So I'm going to delete those two. So now we have all the implementation in place. So we are going to run this order service, catalog service, and place an order, and should be able to see the message details in the orders, new orders queue in the RabbitMQ. I have started both the catalog service and order service, and we have already running RabbitMQ catalog database, orders database. And when we started our RabbitMQ, we can access the management portal on port 15672. So here I am into the RabbitMQ management GUI. So here, if I go to queues and streams and go to new orders queue, and here if you scroll down, there is a way to get the current messages. So we are pulling only one message, and right now there are no messages. Queue is empty. So now let us place a message, let us create a new order, and yeah, it is successful. Now as per our implementation, a new message is supposed to be here in this. So now let us pull the message and see. So it seems we got one message, and with the ID, event ID, this is a dynamic UUID, and order number is 4BE76 something. So let us go ahead and see. So 4BE76 something. So the same order created event information came into this RabbitMQ. So from the order service perspective, we are sending the information. You can even see the complete payload here. So we are sending the order created event to RabbitMQ successfully. We have completed all the subtasks of this publish order created event using Outbox pattern card. So I'm going to move this to in review, and I'm going to start on this new card, implement new orders processing job. So far we have the logic where we are creating a new order with the status new, and we are already publishing a message to RabbitMQ with the order created event. But we need to proceed to process the orders. So how we are going to do that? We are going to create a new scheduled job in which we are going to fetch the orders whose status equals to new, and we are just simplifying the order processing logic here such that if the delivery address country equals to one of these, India, USA, Germany, or UK, then we are going to automatically update the status to delivered, and then we are going to publish the message saying that order delivered event happened. Or if the delivery address country is not any one of this, we are going to automatically cancel the order, and then we are going to publish the message order cancelled to RabbitMQ. And during this processing of any of this whole order processing logic, if any exception occur, we are going to mark the status as order status equals to error. So this is what we are going to do now, and all these events are going to be consumed by our notification service, and then they are going to deliver messages to the customer if it is delivered or is it cancelled. So basically it is not to simulate how we actually process the order in a real e-commerce systems, but this is to learn how we can publish the messages from one microservices and then another microservice, how it is to consume. So it is to learn this process. So now let us go ahead and create a new job and then implement this logic. I have created other event models here. Order cancelled event. Again, it is very similar to order created event with all the fields, except that there is a new field called string reason. So we are going to include why we are cancelling this, that information. Similarly, we have order delivered event, again with all the information about the order, and order error event, again including the reason why this is failing. So once we created these other event types, in the order event mapper, I have added these static methods for constructing those event types from the order entity. So earlier we have already created this build order created event method. So similarly we have created for delivered event and cancelled event and error event. Okay, so these are the static methods that we have created. So with this in place, I have created a new job called order processing job. So here what I am doing, I am scheduling this job for every 10 seconds. So here I have created a new property to indicate this cron information, and this is to run for every 10 seconds. So once it triggers for every 10 seconds, it is simply calling this process new orders method. So as part of this, what we are doing, we are first trying to fetch the order entities with the status new. So we have added a new method in this order repository to return the order entities with the status given whatever the status is passed. So here we are saying fetch all the new orders, and then we are looping through all the orders and then processing it. As part of this process, what we are doing, first we are checking whether this order can be delivered or not. So here what we are doing, we have defined a list of strings, delivery allowed countries, list of India, USA, Germany, UK, and in this can be delivered, we are simply checking whether the orders delivery country is one of these list or not. So we are only allowing 4 or 5 countries, and we are just checking whether the order can be delivered to one of these allowed countries or not. So if it is, we are updating the status of that order to delivered. So here again we have added a default method in the interface itself. So first we are fetching the order by order number itself, and if there is no order with that number, we are throwing the exception. Otherwise we are setting the status and then saving it back. So here if we go back, if it is delivered, we are updating the status to deliver, and we are creating this new order delivered event and then saving into order events table. Okay, else if the delivery address country is not one of these allowed countries, we are updating the status to cancelled. So we are automatically cancelling it and then saving the order cancelled event into the order events table. But if there is any exception happened during this processing, we are simply setting the order status to error and also building this order error event and storing into order events table. So nothing complicated, but of course this is not how the order processing happens in the real applications, but here our purpose is to understand how to communicate between two microservices via messaging system. So we are processing it like this. Next, we have updated order event service logic here in publish event. Earlier we have handled only order created event. So we have added other scenarios as well, where we are dealing with order delivered, order cancelled, order processing failed. So all these events. So we are processing in the very similar way. We are taking the event payload and then converting them back into their Java beans, and then we are calling this publish event. And we have added all these other methods also. Earlier we have only order created event. Now we have added order delivered event, order cancelled event, and order error event to handle all of them. And in each of those cases, we are choosing which queue we want to send. So basically this is a queue name as well as the routing key. So we are sending the messages to different queues based on the event type. So, okay. So with the logic in place, I have just started both catalog service and order service. Now let us place a new order and see whether it is able to publish all the relevant events to this RabbitMQ. So here again I am placing a valid order with the country India. So here I am placing this order, and order number is starting with 079. So now if I go to RabbitMQ and queues and streams tab, here first I'll check in the new orders queue. I get the message and 079, it starts with order number. So we got the message into new orders queue, and also it is supposed to be in delivered orders also. So here again I am going to get the message, and it got the message 079. So it is successfully processed and then published the event to this queue delivered orders. Okay, so what if we publish a order with some other invalid value? So this is some unknown country. So if we place the order, it created a new order D7E, but if we go to cancelled order, we should be seeing this. So here in the cancelled orders, D7E, the order is there and end up in cancelled orders. So it is, our logic is working fine. So I think we have implemented the functionality. We have implemented a new job and we have implemented this processing logic. So who is going to consume the message if there is any error? So here most likely we may have to create a listener within the order service itself and send a message to the support system. Obviously error messages, they are not supposed to be sent to customers. So we need to implement a listener and in the order service itself and send a message to the support team saying that one of the order processing is failed and maybe some backend job can be triggered to process those issues. So I will leave that to the viewers. If you want to implement that functionality to consume those error events and then take some action, I will leave it up to you. So with this, we have completed this as well. So next we are going to look at the next card, implementing the distributed locking for our job scheduler. And first we are going to discuss why do we need this, and then we'll take a look at how we can implement this. Next we are going to work on implementing this distributed locking for our job scheduler. So what is the problem we are trying to solve here? So in our application order service, right now we have implemented a couple of jobs to process various tasks, but most likely in production environment we might be running multiple instances of order service. If it is in Kubernetes environment, this can be run in multiple pods, or if it is in other environments, maybe you want to run multiple instances and then use load balancer to spread the load. But the problem here is, because we are using this Spring supporting job schedules, all of those services will be triggered this job processing. So there is no coordination saying that, okay, only it should run on only one node. There is no such a limitation here. So all of those nodes are going to trigger the same jobs and then try to process the same events, which is not what we want. We want at least, at most, only one node should start processing these events, and it should not be duplicated across multiple nodes. So this is where we are going to use a library called ShedLock. So basically what this will do, it will ensure that only one of the instances are processing the jobs at any point of time. So how does it do? So let us take a look at it. So basically it is going to use one of the persistence mechanism to store only one task is running on a particular node by locking that particular task. So if multiple nodes are trying to acquire the lock, it is going to prevent that and only allow only one node to process the jobs. So how we can do that? So first, if we are this ShedLock can be used by multiple frameworks in different ways. We are going to look at how we can integrate with Spring Boot application. So the first thing is we need to add this dependency. So let us go ahead and add this in our pom.xml. So let me add it here. Next, we need to create, we need to enable scheduler lock. So I'm going to add this to our main entry point class, order service application. So here there is a default log at most for. So depending on how long usually our job processing takes, we can configure something. So I'm going to keep it as 10 minutes. Obviously for us it doesn't matter, it doesn't take much time. So but you can customize it based on the application needs. And once we enable that, we need to give a name to this task and use this scheduler log annotation. And within the log, within the scheduler task implementation, here first you need to assert logged. So it is going to first acquire the log and then check it is logged by the current instance or not. So let us go ahead and add this to our two jobs here. So here I will just give the same name here and also copy this to process new orders. Okay, and also we need to check whether we are able to acquire the log or not. Okay. So, but just adding these doesn't do any magic here. If you want to customize at the job task level, you can also specify what is the minimum amount time and what is the maximum amount of time it can hold the log and all. So coming to the main point, how this library is able to hold the log, I mean preventing other nodes from processing the same task. So basically they are going to use a table. If you are going to use database, you can create a table, and also there are other approaches, like if you want to use MongoDB or some other database types, you can use it. But anyway, we are already using PostgreSQL, so we are going to use PostgreSQL table for implementing this log. So we are using Postgres, so we need to create this table. So let us add this table as a new Flyway migration to our project. So here under migrations, let me create one v3 __ add ShedLock table.sql. So here I'm going to create this table. Okay, so when application starts, it is going to run this. So this is also done. Next, we need to we are going to use JDBC template to execute this one. So we are going to add this dependency as well. So depending on the type of storage mechanism you choose, you need to add this one. Because we are using database, SQL database, we are selecting this mechanism. But if you are using MongoDB or some other type of database, you need to add another driver similar to this. So here we have added this JDBC template provider. And finally, we need to configure this log provider bean that look for where you want to use this mechanism to look for where is the logs and all this information. So that information is obviously going to store in this ShedLock table. So here we are going to configure this log provider, and let me copy this, and under config package I'm going to configure this with the name scheduler config. I'm creating a new configuration file here, and in that I'm going to use this. Okay, so with this configured, our services, even though if we start multiple instances of order service, it is going to ensure that only one instance is processing one of the jobs. So even if you have multiple instances, only one node is going to process this at any point of time. Okay, so this is all we need to configure. To actually demonstrate this, we need to run multiple instances and then see jobs are getting triggered only on one node. Okay, so let us try to do that. Within the order service, I have run the maven clean package command, which executed all the tests and then finally built the order service jar file within the target folder. So now what I will do, I will run two instances of order service on different ports from two terminal instances. Here I have terminal 1 window and second window here, and I am inside this order service. So in the first window, I am starting the order service application on 8082 port. So we can customize the port by passing this VM argument using -d server.port equals to 8082. And similarly, on the second window, I am customizing it to start the server on port 8083. So here, let me start this both the instances. So here you can see both the applications are started running on two different ports. One is on 8082, another one is on 8083. Now here we can observe the jobs are going to be executed only on one instance at a time. For example, here if you see found 0, so last one is found 0 new orders to process, but here that is not executed now. So here you can check found 0 order events to be published. So the other job got triggered here. So each task execution happening only on one instance of the service. It is not happening on both the service. So as you can see, at any point of time, one task is being executed only on one instance, not on the both instances. So we are done with this card as well. Finally, I think we have completed all the aspects of creating a new order API. So next we are going to start working on implementing the other API endpoints, like getting orders for a customer or getting a particular order for the given order number. So we are going to work on this in the next video. In this video, we are going to implement two API endpoints in the order service. One is to fetch all the orders created by a user, and another one is to return one particular order details for the given order number. And we are going to write integration tests for it. And also we are going to Dockerize this order service by writing necessary Docker Compose configuration files. So let's get started. Let us start with our first requirement, implement get orders API. Here we can see the expected response is a list of orders, and each order contains only the information about order number and status only. We are not including all other details about the order. So if you think of from the user experience point of view, usually in a list page we only see very few details about the entity, and then when a user selects a particular order, we will show more details about that particular order, right? So this is the list API endpoint, which only contains fewer fields. We don't need to include all the information about the order. So now we are going to implement that in our order service. So currently we have order controller, which has one API handler to create the order, and we are going to implement the new API endpoint like this. So we have get orders with a get mapping. So at the class level we have request mapping /API/order. So we don't need to specify anything at this annotation level. So now coming to the implementation, we are returning list of order summary. Here, if you take a look at the order summary, I have created a new model under domain models package, which contains only order number and status only. So now with this, let us see how we are implementing this. So first, we need to return only the orders of the current logged in user only. So here, if I go to this method, currently we are hard coding this. Even while creating the order also, we are using the same method. So currently, whenever a new order is created, it is going to create with the same username. So while fetching also, we are getting the same username. Once we have implemented OAuth based security, we will actually implement to figure out who is the actual logged in user, and then we are going to fetch orders for that particular user only. So now let us go and check how the implementation for order service.find orders is. So here we have created a new method in order repository called findByUsername. So this is called Spring Data JPA derived query method name. So what it does, Spring Data JPA will remove this findBy prefix and then construct the where class based on the remaining method name. So here we have only one field, so it is going to be like select star from orders where username equals to whatever the value we are passing here, and it is returning the list of order entities. And in our service we are looping through all the orders, and then we are constructing order summary by taking order number and status from the order and returning the list. So now this is going to work, but it is a very bad implementation. Why? We are fetching the entire order information from the database, from the repository, and then dropping all the information except order number and status. So unnecessarily we are loading all the order information only to use order number and status only. So we should not do this. So instead what we can do, from the findByUsername itself, instead of using the derived query, we will provide our own query implementation using the JPQL. Okay, so here it is giving some auto completion. So let me see, from order entity giving the alias O where username equals to whatever the value we are passing. So this is fine. But instead of returning the order entity O itself, we are using this constructor expression new and giving the complete fully qualified name for order summary, and then passing the O dot order number, O dot status. So we are constructing a new order summary instance for every record that is matched with the username. So here, instead of returning order entity, we can return order summary itself. So it is not going to load all the information about the order. It is going to only read order number and status only, and then return list of orders summary directly. So from here, we can straight away return from this method itself. We don't need all this. So this way you are reading only the data that is required for your API endpoint. You are not loading the unnecessary data only to discard all that information. Okay, so this is how we can implement this get orders API endpoint. Okay, now let us look at the second API endpoint. Here we want to get one single order information for given order number. So we are going to include most of the information about the order as part of the response. So now let us take a look at how we are going to implement this API endpoint. So in the order controller, I have added the next API handler method here using get mapping, and we are going to add this /API/orders/order number, and we are binding that value to this path variable order number here. So now again we are getting the username, and in order to fetch the order number, we should not be exposing this API endpoint so that anybody can simply pass the order number and get the order information. It should be, the order number should be owned by the current logged in user. So we are fetching the username and then taking the order number and then trying to find the order based on these two factors. So here we are calling order service dot find user order. So if somebody, if they want to exploit this API and they are logged in as a different user but trying to give the other user's order number, still it is not going to get the specific order information. So here we are trying to find the order for this order number, and it should be created by the current logged in user. So what we are doing in the find user order, so here we have created a method in the order repository which is going to return order entity. So here if you go to this find by username and order number, and we are passing this username and order number. So with this we are returning this order entity optional, because with these two combinations there may or may not be the order. So we are returning optional of order entity. But here, as we have already discussed, how Spring Data JPA is going to execute this, it is going to remove this find by prefix and then trying to construct the where class where username is one column, order number is another column, and is going to be used in the pair clause. So it is going to be like select star from orders where username equals to this value and order number equals to this value. So it is going to do like this. And once we got the order entity, we are mapping it to using a order mapping. So we are taking the order entity and then mapping the order items and then mapping it to DTO. So we have created a new order DTO. The reason being, earlier also we might have discussed, we should not be directly exposing our entities as a response to the API endpoints, because if we want to change any logic, it is going to affect both the places. So instead we are returning a DTO with only the necessary information. Here we are not including the order ID, which is the primary key in the table, which is not required for the response. We are not including that. And then also we are not including updated it, which is not required. So here we are including only the fields that is required for this. And then we are also including a derived property to return the total amount. So it is going to loop through all the items and then multiply quantity and then returning it. So we are returning order DTO instead of directly exposing the entity itself. So that's what we are converting here, and then we are returning this optional of order DTO. And at the controller level, we are taking that, and then if there is no order found with this combination, we are throwing this order not found exception. Okay, but here there is a catch and we will talk about it. But first I have started both the databases and then RabbitMQ, and then I am going to start both catalog service and order service and then demonstrate what we can do better in this process. So here let us go to order service and then restart. Also I am going to enable showing the SQL that is generated, so that we will see what kind of a SQLs it is getting generated. So I am restarting the order service again. Okay, so now let me go to Postman, and here first let us try to fetch API orders. And here, so these are some of the orders that earlier we have placed, and now if we check the console, it is going to run this query. So all the other queries are from batch jobs. So this query, it is selecting only order number and status. It is not selecting all other details. So that is what we have done in our repository by returning this order summary itself using this constructor expression. So it is not selecting any unnecessary data. It is only selecting order number and status only. Okay, that is fine. But now let us take a look at another one. So here I am taking this order number and then going to fetch that particular one. So API/order/order number, and if I'm fetching it, yes, I am getting the data. But now let us take a look at here. First it issued a first query to fetch from the orders, and then it issued a second query. Where is this? Let me clear the logs and then try it once. So here we can see there is a second query fired to fetch its associated ordered items. So it is firing two separate queries because we are not specifying. If you take a look at order items, here it is going to by default load lazily. So it is triggering another query to fetch the associated order items. So that is not a optimized way. So instead what we can do, we can write a custom query again. Okay, so here now we are returning O itself. So here with the custom query, select order entity O left join fetch order items. So it could be items itself. So here what we are doing with the custom query, we are selecting order entity O and left join fetch order items. So with this it is going to join order items table and then fetch all the data in a single query. So here we can say distinct O and put in the where class username and order number. Okay, so now let us see how many queries it is going to generate. Let me restart this. Okay, so now if I go to this and then run this, now you can see it is triggering only one select. And here we can see it is left join fetch order items. So both order details and its associated order items are fetched directly in a single query. So that way, so it is very important when using Spring Data API. It is very convenient. You simply write one query using the method name and then it is magically going to fetch the data. But it is always important to check the logs and see what kind of a queries it is being generated. And then you need to tune it so that it is not going to run multiple queries, or there is a common problem known as n+1 select. So you need to be careful and always check the SQL queries that are being generated and then try to fine tune it. Okay, so now we have seen both the API implementations here, and we have manually tested using Postman also. Okay, so now let us write integration test for it and then see how we can test this. Earlier we have created order controller tests for writing integration tests, and then we have created a nested class to put all the create order related tests inside this class. So though we have currently couple of tests in this nested class, so similarly you can group all the API endpoint tests for a specific API endpoint and you can test various scenarios. So similarly we are going to create another class for get orders tests and also get order by order number tests. So though we have currently only one test is there, but you can add more scenarios and follow the similar pattern here. So what we are doing, we have created under src test resources, I have created a SQL script called test orders.sql file. So in this what I'm doing, I'm truncating orders and putting cascade, which means it is also going to delete the entries from order items table, and then I am altering the sequence with 100 to start with 100 so that I can set up some sample data, and when there is any other API that is trying to insert a new entry into orders, it is not going to clash with this IDs. It is going to start with 101 or something like that. Okay, so here I am trying to insert a couple of rows into orders table and then inserted a couple of records into order items, associated order items. So here we have two orders and then for order 1 there are two order items and for order 2 there is one item here. So I have created some sample data so that we can run our tests against this data here. So once I created the script, I am using @SQL and specify the path of the file, the SQL file. So by default, if you don't specify anything, it checks for class path also. So it is there in our class path, src test resources. Okay. So now for every test method, it is going to run this SQL script so that even if you make any changes like placing order or updating anything, it is going to remove all that orders and then reinsert this sample data so that every test runs in a known database state. So here under get orders test, I have only one test, and then I am issuing this /API orders endpoint, and then I am asserting it should be status OK 200, and I am extracting that response into list of order summaries, and then I am asserting it should contain two orders. Okay, so basically here I am inserting two orders, so I should get 2 orders only. This is the /API/orders, the first API endpoint that returns all the orders information. And second, here I am taking one order number from the sample data here. So order -123, and I am trying to get the details here. So I am trying to pass that order number here and then trying to fetch that particular order details, and I'm expecting the status code to be 200 and order number is this. And here, because I know for the order number 1 there are 2 entries, I am just asserting items size is to be 2. So if you want to add more assertions to compare other fields of the information, you can write those asserts as well. So now we have 2 other tests added. So now let us run and then see. So the important thing is we should some way make sure that all the tests are running in a known state. That means here we are making sure that we are removing all the existing data and then inserting some sample data, and we are running that script for every test method so that we always know what is the data that is already there in the database. That's why we are able to specify that it should contain 2 orders, and we are also saying for this particular order there are 2 items. So this is based on the sample data that we have. Okay, so now here you can see all the tests are passed. Okay, so we have already seen how to write unit tests using @WebMVC test and all. So I am not going to repeat the same thing again. You need to simply mock the response from order service, and then you can write other tests as well. So I'll leave it up to the viewers to try it out, and you can let me know if there is any challenges. Finally, let us complete the Dockerization of order service. So first, let us take a look at our task file. Earlier, we had under build commands, we had only building the Docker image for catalog service. I have added this second command to build the Docker image for order service as well. So the rest of the commands are, everything is fine. There is nothing to be changed. And if you go to order service, let us check the properties. So here, there are few things that we need to change when you are running inside Docker. Okay, so first of all, orders catalog service URL, when you are running both the services locally, we are pointing it to localhost 8081. But when we are running both the services inside Docker, this host name should be whatever the host name container name that we are giving to catalog service. So this should be catalog-service.:8081. But we can override this property through environment variables in the Docker Compose file. So apart from it, we also need to configure DB URL and everything, and then RabbitMQ configuration we can override through these environment variables. So that is all we need. So if I open up this infra.yml file, we have already seen we have catalog DB, orders DB, and BookStore RabbitMQ that we have already configured, and we have been using this for some time. And the new thing is in apps.yml file, earlier we had only configured catalog service. Now I have added this order service as well, and I have defined this image name and gave the container name as order-service, and then under environment I have configured profile to activate Docker. Right now it doesn't have any impact, but just to know we are running inside Docker, I just enabled this profile. And how do we override this catalog service URL? So basically you can take this property and capitalize all the letters and replace dots or hyphens with underscores and provide it as an environment variable. So this is how we can simply override that. And similarly, we have configured database URL, password, username and all. For RabbitMQ also we have configured. So this is the host name, which is nothing but our infra container name here. Okay. So that is how we have configured, and also specified it depends on both orders DB and BookStore RabbitMQ, and they should be healthy. Okay, so this is all we need for Docker Compose configuration for order service. So now let us verify whether everything is fine or not. So now I'm going to run the command task restart, which is going to stop if there are any containers running, and then start all the containers: catalog DB, orders DB, RabbitMQ, catalog service, and order service. All of them should be running in Docker only. So right now nothing is running, only Portainer is running. So let us wait for this. So here it is going to use cloud native Buildpacks and then build the Docker images and then run all of the services in Docker. So all the services are successfully started. Now let us go and check. As you can see, we have bind this port 8082 to host 8082. Similarly 8081 on host 8081. So we can use these ports and then interact with the catalog service and order service. So now what I'm going to do, I go to Postman and try to place an order. So here now I try to place an order with all the valid information, and it is able to successfully create an order, which means it is also be able to talk to catalog service. Otherwise the validation will be failed and then I get to see some error here. So now both the services are up and running. Okay, so we have successfully configured everything, and already we have created order service pipeline here for GitHub Actions, and it is also very similar to catalog service. We are building this by running the tests and then logging into Docker Hub and then building the image and pushing it to Docker Hub. So Dockerizing order service is all set. So this is all for order service for now, and in the next video we are going to start building our notification service. We have completed our implementation for order service APIs and everything except security. So in this video, we are going to start building our notification service. From the order service perspective, we have implemented all the logic to take a request and then persist the information into DB and then publish an event to RabbitMQ. So now in our notification service, we are going to consume those events and then send email notification to the users. So let's get started. Let's go to start.spring.io and create our notification service. So here in start.spring.io, I have provided the project metadata, the artifact name as notification-service, and then package name as com.sivalabs.bookstore.notifications. I have selected the Java version as 21, packaging type as jar, and then here I need to select what are all the features I want to use in my application. So based on that, I need to select the dependencies. Though we are not going to implement any web API endpoints, but still we are going to expose our metrics and all in the future videos. So I have selected Spring Web, and Spring Boot DevTools and configuration processor is for development time purpose. And we are going to use again Spring Data JPA, Flyway migration, PostgreSQL. Here, if you remember, we have used Outbox pattern in our order service, where we are going to keep publishing the events, order events to RabbitMQ. And for any reason, if it fails in the next job run, we are going to again read all those messages in the order events table and then publishing it. So there is going to be a chance that you may receive, notification service is going to receive duplicate events. So what we are going to do, we are going to maintain a table here in the order notification service and keep storing all the event IDs, so that if we receive any new event, first we'll check whether we have already processed this or not. If our table contains that event ID already, then we are going to simply log it and then discard processing it. So for that we are using Spring Data JPA with PostgreSQL. And the main key point is we need to consume the events from RabbitMQ, and we're going to apply some validations. And once we receive those events, we need to send the emails to the users, and we are going to use this Java mail sender for that, and Actuator and Testcontainers. So once you select all these dependencies, then click on generate, and it is going to download the notification service project. And now you can copy this folder notification service and then go to our project and paste the folder here. So it is going to add this notification service. So this is going to contain the bare minimum project with the basic set of project code. So here you can see this is containing the bare minimum application, and it has all the selected dependencies and everything. And we can add this module into our parent root project. Okay. Now we have the basic project here. We are going to change it like the way we build our application like other services, order service. So let us go ahead and update the notification service initial code to change it to similar to our other services. In some ways, notification service infrastructure is very similar to our order service. Like it has integration with RabbitMQ, it has integration with PostgreSQL database. So we can reuse the same configuration which we have in order service for our notification service as well. So let us start with our pom.xml. So here is our pom.xml of order service. So let me copy this configuration, spotless-maven-plugin and Docker image name, and I'm going to paste it into the properties. Then we are going to copy all the customizations for Spring Boot Maven plugin. We have configured the Docker image name and a different builder and build info. So git commit ID plugin and spotless Maven plugin. So we are going to copy all these three plugin configurations. So here I'm going to replace this with three plugin configurations. And what else we need? Okay, so I think we can leave it for now like this. And now let us go to order service properties configuration. So here let me just take everything from here and then go to application properties of notification service. So I'm going to remove this, and our notification service is going to run on port 8083, and here instead of orders it is going to be notifications. So let me change it here, because we are going to listen to messages from all these queues. So we are going to configure same exchange and same queue definitions here, and we don't have any jobs in this. And here we are going to create a new database for notification service, and we are going to expose that on a different port 35432, and that is it. And RabbitMQ configuration is fine, and we are not going to use any resilience for J in this notification service. So this is fine. And now let us copy our order service application properties here. So I'm going to paste it here. Here it is supposed to be notifications, and we don't need catalog service URL here, so I'm removing that. And also here I will say configuration properties scan, enable that. Okay, we have this configuration in place, and we need to have our RabbitMQ configuration as well. So it is almost same, it is exactly same. So I'm going to just copy this config package itself and then paste it under notifications. but we don't need this scheduler configuration, so I'm going to delete that. And RabbitMQ configuration, so it is not others, it is notifications. Yeah, so RabbitMQ configuration is good, and we don't need these static and templates in our notification service. And when it comes to test infrastructure, we have some common abstract integration tests and all that. So let us copy this containers configuration. This is common here as well, abstract integration. We don't need WireMock, so let me delete that. And we are also not going to test any API endpoints, so we don't need rest assured as well, so I'm going to delete that. Here we don't need this as well, so basically we don't need anything in this abstract IT. Okay, we have bare minimum configuration. In our containers configuration, we have both PostgreSQL and RabbitMQ configuration. This is fine. And here we need to remove this and extend from abstract IT. This is also fine. And here, if you remember, we are not defining all these containers in this class itself. Instead, we moved them to containers configuration. So I'm going to change here to containers configuration. Okay, so we are good here as well. I think we have core configuration ready. Just let us start and let us configure our dependency for another database in infra. So we can take this other DB configuration and we can configure it to notifications DB and update this here as well and expose this on host 35432. Other DB is on 25432, catalog DB is on 15432, so we are exposing on 35432. So this is also fine. Now what we can do, now we should be able to simply restart the infrastructure and start our notification service. We should be good enough to start the application. Okay, let's do that. Now let me go and see. So there are no containers running our infrastructure services. So let me go to console and we have task restart infra task, which will start all the infra components here. So now we should be able to see all the catalog service database, order service database, and notification service database and RabbitMQ all should be started in this. So it is going to take some time, and meanwhile what we can do, we can implement a listener that are going to consume events from the RabbitMQ. So if you remember, we have implemented earlier for demonstration purposes in the order service itself to consume those events. So let us do one thing. First, let us check what information we are publishing from order service. So from here, if we take a look at jobs, events publishing job. So here we are publishing various events. So like this order created event. So we have various order created event, order delivered event, order cancel event, order error event. So these are the payloads that we are publishing from our order service. So we need similar components in our consumer side also, like on the notification service. So I'm going to create this domain models package and copy some of those which are required to consume. So here in our notifications package, I'm going to create a sub package called domain.models, and here I'm going to copy those event records: one created event, delivered event, order error event. And in addition to them, I think we also need customer address, order item as well. So let me copy them to models. So here this is fine, these are all fine, no errors, so everything is all right. So now here in our notification package, let us create a class. Let's call them as events dot order event handler. Okay, so this is going to be a Spring component, and here it is, we are going to write void handle order created event. Okay, and we are going to use rabbit listener, and queues is we are going to use the spell expression, Spring expression language. So here we are going to use the key that is defined here. We don't need this, and we are going to take this key and place it here. So this is going to listen to this queue, and it receives the payload. It is going to call this method, and we are going to simply log it here. Okay, so simple, there is nothing complex logic. First we are going to check whether we are able to publish the event from order service, and we are able to see it or not in the notification service. So let us check whether all these services are up and running. Now cool, now let us start all these services. So here first let us start with catalog service, and let us start order service, and finally let us start notification service as well. And let us go to localhost 15672. so this is the RabbitMQ GUI and guest. So exchange is created and all the queues are defined, so seems everything is fine. Now let us go ahead and place a valid order. So here we are creating a new order by placing an order on order service. So it is created successfully. Now we should be able to see the log statement in the notification service. So here order created event, and we can see it received with event ID and order number. So 4F2F, so 4F2F. So the same message is consumed from the notification service. So all the components are configured fine. Now let us go ahead and implement the actual logic. Next, let us create our notification service class in the domain package, which actually contains sending the email notifications to the users. So here I'm going to create a notification service, and it's going to be a service, and here I'm going to copy the code because I don't want to keep typing it all over the place. So here what we are doing in the notification service, we are injecting application properties and Java mail sender. If you remember, while generating the project, we have added Java mail support here, Spring Boot starter mail. So we are going to use Java mail sender to send the emails to the users. So we are going to inject it, and we need to configure which email service we want to use. But in this demo, we are not going to use the actual any email service provider. Instead, we are going to use a tool called MailHog, which we can use for demonstration purposes. So we have this mail sender, and there are multiple methods created to handle each notification type. So first one is when we have a order created event, we have this send order created notification. So here I am just in plain text, I am preparing this email content, but If you prefer, you can use Thymeleaf templates and then dynamically replace those values and all. But to keep it simple, I have created this message as a simple text itself. So here we have some placeholders to replace with the dynamic values. So when a new order is placed, we are going to send the mail notification to the user. So we have this placeholder. This is supposed to be the event.customer name, and your order with order number, some placeholder which is nothing but event.order number has been created successfully, thanks BookStore team. And then we are simply logging to the console, and then we are also calling this send mail method, and we are passing to whom we need to send and what is the subject line and the actual content, which is nothing but message. So similarly, we have for order delivered notification, again we have same simple text here, and we are replacing with the actual values for these placeholders. Similarly, there is order cancellation, and it also includes why it is cancelled. So there is a placeholder that and for all these we are sending the emails to customer. But when it comes to order error, this is not something we should be sending to customer. Instead, we should be sending it to our support team. So here, what we are going to do, we are going to add a new field called support email in our application properties. So here I'm going to create a new property called support email, and I'm going to configure that here. Notifications.support email, I'll configure just for the demonstration, siva@gmail.com or sivalabs.com. Okay, so now we have this configuration in place, and let me close it. Okay, so here we are sending, we are calling send email, and here if you remember hi %s, here instead of customer email we are sending this. Ideally this is also not right. Here maybe we can hard code saying that hi BookStore team here, and yeah, we need to send this to this email. Okay, so here we don't need to send this, instead hi team, we can do like that. But here we are calling send email method, which takes who is the recipient and subject and content. Okay, so here we are using Java Mail API to create a my message, and then we are setting to whom we need to send. The from is always the support email, to is the recipient and subject and text, and then we are calling sending. So if there is any exception in sending, we are also throwing the exception again back. Okay, so nothing complex, simple sending the email stuff, but we have not yet configured to where we need to send email and all this configuration. So as I said, we are not going to use the actual service providers like Gmail or Yahoo Mail, something like that. Instead, we are going to use a utility called MailHog. So it is a very nice utility for local development and testing perspective. So here we can use as a Docker image, and then we can configure our application to send emails to this service. So I'm going to configure MailHog in our infra.yaml file. So let me go to open this infra. So here after this I'm going to configure MailHog, and this is the latest version of the image, and then I'm configuring this, and 1025 is the actual mail port, and this is the GUI port. 8025 is the GUI port. So we can check what the emails we have sent and received, so we can check here. Okay, now I'm going to restart this infra. Okay, so let me go and restart the infrastructure. So it is going to start our MailHog also. Meanwhile, I'll go ahead and add, we have all the methods here, and we also need to configure mail properties. Okay, so what I'm going to do, I'll configure all the properties with the defaults. So here we are configuring the email properties, like we are taking mail host as the environment variable. If it is not there, we are going to use localhost, and then default port is 1025, and we can pass the placeholder values, otherwise it's going to take this default value. So this is the configuration. But if you are actually talking to any service like Gmail or any other third-party provider, you need to configure these things accordingly. But these values are going to work just fine with our mail hog. So let us go ahead, and we have configured this. And what else we need to do? Right now we have handled only this one. Let us inject the notification service here, private final notification service. And once we receive this, let us go ahead and send the notification. And also let us configure for other events. So we have basic implementation in place. Now let us restart all these services. And order service and notification service. I hope all the containers have started successfully. Here, yes, Mailhog also is running. Cool. Now let us wait for all the services to be up. Yes, all of them are up, it seems. Cool. Now let us go ahead and open the Mailhog UI, localhost 8025. So this is the GUI for Mailhog, and right now there are no emails here. Now if we go to Postman and try to place an order, so order is created successfully. Now we should be getting, the first one is order created notification. Here you can see order created notification, and here so and so your order is placed with so and so order number. So we got the first email, and immediately we also got the delivered notification also. So our mail notifications is working fine. So let us place an order which is going to be cancelled, maybe giving a invalid country name. So I'm going to give India 123, and it is going to be cancelled. So first it is going to create a created notification event, and then it is going to give a order cancel notification also. So let us wait. So order cancel notification also received. So can't deliver to the location. This is the reason. So this way we can we are sure that our application is working fine. We are able to consume the events, and it is sending the emails to the user. So maybe we need to simulate some way to simulate an order error event, but you get the point. This is how you can consume the messages from RabbitMQ, and you are able to send email notifications to your customers as well. Cool. But again, as I mentioned, we are using Outbox pattern, and there is a chance that we are going to get duplicate emails. So what we are going to implement is we are going to create a new table that stores for every event that we received. It is going to contain each event is going to contain event ID that is supposed to be unique. So we are going to create a table, and then every time we receive an event, we are going to check whether this event ID is already present in our table. If it is, we are going to skip processing this event. Otherwise, we are going to continue processing that. So let's implement that logic. I am going to create a new Flyway migration script here with this v1 create order events table. So here we are simply storing the event ID. We are not storing any other information, but for any business reason, if you want to store other fields also, like payload or order number, anything, you can store that information also. But here we are storing only event ID. We are just interested to check if this is a duplicate event or not. And each event ID should be a unique one. So we are storing it as a unique column. So with this, let us go ahead and create a JPA entity and then repository as well. So here I'm going to create these two classes. One is for order entity, order event entity. So this, again, you are all familiar with this. We have event ID, which is unique, and then created it, updated it, so setters and getters, nothing fancy. And we have order event repository, again simple JPA repository for order entity, event entity. And this is something probably we haven't talked about. So earlier you might have seen find by with some things, find by username, find by order number, things like that. But Spring Data JPA also provides this exist by feature, where if you want to check the existence of some record based on some criteria, you can prefix with exist by and your criteria, which is going to return Boolean. So here we want to check whether the given event ID already exists or not. So we created a Boolean return method exist by event ID. So by simply we can check by calling this method whether this event ID exists or not. Okay, so now with this in place, what we are going to do, let me inject this into private final order event repository and add this here. Now if you notice clearly, I am violating some of the things that I mentioned in the previous videos. I mentioned do not expose your entities to the outside of domain package, but here we are making both our order event entity and repository public, and we are using them from an events package. Why? So this is the thing you need to remember. There are rules and guidelines, and all of them are created with a certain purpose and context. We should not take everything as a blind rule and then blindly follow it. We should think about, is it make sense, or is it fine to violate this? What is the cost of violating this? So here I don't see any reason to create a DTO again and then map entity to DTO and then sharing it, because we are not publishing this information to any web response, or we are not, there is no purpose creating another entity DTO and then copying and back and forth. So it is the same entity and there is no good reason to create a DTO for this. So I decided to use this entity itself and expose the interface repository also and then use it. So you always need to evaluate, should I follow this best practice or pattern, or is it relevant, or what is the cost of violating this best practice. So here I don't see any danger in violating by exposing this interface outside of this domain package. On the other hand, simply creating the DTOs and then copying to and fro from entity to DTO is unnecessary overhead. I don't see any benefit doing that. So that's why I'm directly injecting the repository itself into the handler. So now what I can do, once I receive the event, I can call order event repository dot exist by ID, and we can take this, and instead of that we can check, and okay, not log dot warning. Okay, we haven't created logger, so let's create logger. Okay, so what we are doing, let us put this also as a log statement. So here I am checking whether this event exists or not. If it is, simply logging this receive duplicate order created event with event ID, so and so, and returning it. We are not proceeding to process this one. So let us go ahead and use this for other handlers as well, but it is going to be a different event. Okay, cool. So here let us change it to log.info. All right, so we have all the logic in place. So even if order service publishes duplicate events, we are going to check that, and then we are going to return if it is already in place. But once we process this, we should be persisting that information, right? Otherwise, every time it is going to check and there is no record. Once we process this event, we should store that event into the table. So let us go ahead and create other event entity, and create this with event ID. So here we have a constructor which takes just event ID and initializing it. So we are going to use that, and where is this? So we are going to save this. So we need to do this for all the handlers. So that way, when an event came into our system for the first time, first we are going to check it doesn't exist, and then it sends the email notification and then save that event information into our database. Next time, if that same duplicate event occurs, it checks and this is true, and it is not going to proceed further. It is going to return from here itself. So we have all the functionality in place, and now let us go ahead and restart our notification service. So in order to check this, we some way need to publish a duplicate event. Okay, so let us go ahead and try to publish a duplicate event. We can publish an event to this RabbitMQ from the administration GUI itself. So here, if you go to exchanges and then click on orders exchange, here there is a section called publish message. So here you can define what is the routing key, and if you want to set some headers, you can set it, and then you can specify the payload. So the routing key is new orders. If you remember, our configuration is like we have configured the name of the queue for new orders as new orders, and we are also using this as our routing key. So we are going to use that in our routing key, and we are going to publish the payload as application/JSON type content type. So we are setting content underscore type equals to application/JSON. And now the payload is, if you remember, we are almost sending the same payload that we received the order. In addition to that, we are processing and then we are creating a new order number and event ID before publishing the event. So we ourselves are going to include those two fields. So here I am including order number and specifying it can be ORD111. Okay, again event ID. So if our application is processing these events end to end, this is how the application is going to send the event. So it is again event -111. Okay, so application sends event. This is how it is going to send. So I am sending this for the first message. So now if I go and check in the logs of notification service, so here I am in notification service. Here I can see this order number 111 has been successfully created successfully, and then I sent that message to the end user. But now here you can also see that is information stored into order events table as well. Now if I send the same payload one more time, here I send it again with the same event ID. Then it is going to log here that received duplicate order created event with so and so event ID. Okay. So this way we are ensuring that we are not processing the duplicate messages, and I think that is all the functionality that we would like to implement in our notification service. So right now the only thing that remains is updating our Taskfile and Dockerizing the service, and also creating the GitHub action for notification service. So let's go ahead and do that. First, I'm going to update the Taskfile to build this notification service as well. So this is all we need to update in our Taskfile. This is fine, and let us create notification service pipeline also. So here I'm going to change it to notification service. So here let me update it. And here as well. So these are the places we need to update. Rest of the setup is fine, nothing to change. And infra, we have already defined Mailhog and notification database, and RabbitMQ is common, so nothing to change there. In apps, as I mentioned, our notification service has almost similar configuration as order service, so let us change this. Let me update it here and here. So we don't need this property, and it is notifications DB. Let me check it. It is going to be notifications DB. Fine. And what else we need to change? We also need to provide mail configuration. So if we check in our notification service properties here, we are assuming mail host is 127.0.0 localhost, right? But it is supposed to be what are the name that we gave to our mail hog. So here, if we go to under mail service, we are changing it to mail hog. This is the host name, and you can specify mail port also 1025. Okay, so this is all we need to support. For Mailhog, it doesn't matter what you pass username and password, they are going to be ignored. So these are the two things that we need to, in fact, we don't even need to provide this one. It is same default also, but for the clarity, I'm just specifying it here. So now configuration of Docker, again here, it is not orders DB, it is notifications DB. So we need to specify that. And also we have Mailhog and condition service ready, service started. So we did not implement any health checks, so I'm specifying it just needs to be started. Okay, so this is all we need to configure for notification service. So now what we'll do, we'll build the entire project and then run all the services in Docker Compose and then place an order and see everything is working fine or not. Okay, so let's go ahead and do that. I have just started all the services in Docker Compose by simply running task restart. It built all the Docker images for 3 services and then started all the containers in the Docker Compose. So from my IDE itself, I'm not running any services. So everything is running in our Docker Compose. Here, if you go ahead and check, we can see all the services, both the infrastructure and the services, microservices itself are all running in Docker now. So now let us go ahead and check. Yeah, RabbitMQ is configured and everything is fine. By now, let us check. First check, are there any emails? So now there are no emails here. And now let us place an order with valid data. Now it is going to create a new order, and then now we should, if everything works fine end to end, we should see, yeah, so here it is got created notification and delivered notification. So we can see it is our order service is taking the order, and then it talked to catalog service to verify whether this product is running fine or not, and then it is sending the message to RabbitMQ, and notification service received that message and then sent the email. So by simply placing the order, we are verifying that it is communicating with all the services and it is working fine. Okay, so this is how we can build this notification service, and we have already Dockerized everything also. Okay, so I think this is done. And if we go and check our task list, we have done all of this. We have implemented a basic skeleton, RabbitMQ configuration, implemented event listeners and send emails, Dockerized the notification service. So we are done with this also. So in the next video, we are going to create our API gateway, and it is going to take all the API requests and then delegate to catalog service or order service depending on the URL pattern. So that's what we are going to work on next. We have completed implementation of catalog service, order service and notification service without security, and we are going to implement API gateway by using Spring Cloud Gateway in this video. So the clients are going to talk to API gateway, which delegates the calls to one of the microservice based on some pattern. So let's get started. First, let us understand why do we need API gateway in the first place. So for example, let us take an example of we have a bunch of microservices and then there is an API gateway and there can be one or more clients, and they are going to talk to only API gateway, not directly to microservices. Why is that? Why can't client 1 can directly talk to microservice 1, 2, 3, 4? What is the purpose of having API gateway? So let us try to understand that. Let's say we are an organization and we are trying to build a product and we are using microservices architecture. And whether we want to build this whole product using microservices architecture or monolithic architecture, it's all a technical concern. And from the client perspective, it should always be a single product. They should not be worried about whether it is using microservices architecture or a monolithic architecture, what kind of programming languages the company is using. That shouldn't be the client's concern. So one way to hide all these technical architecture details is by using API gateway. So with the API gateway, for the client perspective, it is always like they are talking to one system. They are not even going to be aware of how many microservices are there behind the scenes. They are always talking to one API. So we are hiding all these complexities from the clients. And second, let's imagine if there is no API gateway and then client is directly using different URLs talking to different services. Okay, so now let's say initially you build one microservice with too many responsibilities, and later you start feeling that it is doing too much and we should ideally split this into multiple microservices. Then if you divide that, it is going to affect all the clients that are using this one. Now when you divide this microservice into two, all the clients who are using some of these API endpoints need to refactor that. But with API gateway in place, you can still split this one microservice into multiple, and you can provide that configuration at the API gateway level. Still clients can continue to use those API endpoints with the same URL, but you can configure at the API gateway level to forward that specific URLs to one microservice and then separated URLs to a different microservice. And your client even need not be aware of what is happening behind the scenes. They are completely unaware of any refactoring you can do with the backend architecture. So that is another advantage using API gateway. And third one is dynamic routing to different API versions. Let's say you are building a product and then all the clients may not be on to latest version. Sometimes some clients adopt to newer versions a little late. So maybe in that case you need to run same microservice version 1 and version 2, and depending on the client you may want to forward the request to either version 1 instance or version 2 instance. So you can put all that logic at the API gateway level so that you can transparently forward the calls to respective API versions. And also there is usually you want to apply some resiliency patterns like security, applying security, rate limiting, timeout and all. So we have seen how we can apply that at a one API call for our order service. But another alternative would be you can implement all that rate limiting, timeouts and all these things at the API gateway level. So if you have some common infrastructure setups like okay, all our API should be implemented with so and so SLAs, or we can restrict the APIs for based on certain security standards. So all that logic can be centralized at the API gateway level instead of implementing for each microservice. So that is another advantage you can have with API gateway. So these are all the benefits of having API gateway, and it is very common for big companies exposing multiple API, microservices to use API gateway. So in this application, we are going to build, even though it is a very small application, let us follow that pattern, and we are going to implement this API gateway and forward the calls to catalog service or order service. From the BookStore web app point of view, it is just talking to one service. It is not even aware of there are multiple services behind the scenes. We can create our API gateway service from Spring Initializer. Here I have provided the project metadata, and I am selecting reactive gateway and actuator. These are sufficient. Again, for implementing API gateway, we have two options. One is reactive gateway or servlet based gateway implementation also. But this is introduced recently, and I would like to go with reactive gateway itself. And also behind the scenes, it is going to use Webflux infrastructure. Okay, so now I am generating this application, and I'm going to copy the code into our repository. I have copied the code into our repository here, API gateway, and I have added API gateway as a module to this root pom.xml here. And also I have added some of the common POM configurations we are doing for other services, like I have added this Spring Doc OpenAPI dependency. And if you remember, for other modules we have added Web MVC UI. But for this we are using Webflux UI because we are using Spring Cloud Gateway, which behind the scenes uses Spring Webflux. So that is why we are using Webflux UI. And that is the only additional dependency that we are adding here. And we have added usual customizations for Spring Boot Maven plugin using the Docker image name and a different builder, Git commit ID plugin, and spotless-maven plugin. So the usual configuration we have added. And in this service there isn't much code. So if you take a look at it, our main application class doesn't have any other logic. And so usually so far in our applications we are using application.properties file based configuration. But here there will be a lot of nested configuration. We can still do that configuration in the properties file itself, but that configuration looks simpler by using YAML based configuration. Personally, I don't like YAML based configuration, but API gateway configuration looks much simpler when with the YAML based configuration. So I have already created another application.properties.bag file just to show you, if you still prefer to use properties based configuration, you can configure the same YAML based configuration here in the application properties file like this. So I make it as .bag so that Spring won't read it. So if you prefer, you can use that by removing this .bag file and deleting this YAML file. So I am going to explain through application.yaml file. So here these are usual server port. So here it is supposed to be something different, like we can put it as 8080 or we can put it as 8989. Okay. And we have enabled all the actuator endpoints access, and we have given the application name as API gateway, and we are enabling global cars configuration for all the origins, all the methods. We are accepting all the headers like that. So what exactly is this cars configuration? So basically browsers doesn't allow to issue Ajax requests for different domains. So we need to configure which other domains are allowed to access our API endpoints. So here at the API gateway level, we are configuring that for all the API endpoints, we are allowing the request from any domain. Star means any domain, and also we are saying star means any method, HTTP get, post, delete, all the methods, and we are allowing any headers to pass and use. So that way we are enabling cars for all the domains here, and this is the key part of the API gateway. So here, this is where we are going to configure the rules and how we are going to forward to a different service. So here for our first route, we are giving a ID saying that catalogs-service, and we are going to forward this request based on this matching criteria. We are going to forward this request to catalog service URL. If you configure some environment variables, it is going to take that. Otherwise, we are going to forward catalog service related request to localhost 8081, which is where our actual catalog service is going to run. But based on what criteria it is going to forward to that URL. So this is where first predicates means this is where it is matching the incoming request. If the incoming request starts with /catalog/anything, then it is going to apply this filter, which is rewrite path. This is one of the filter that is provided out of the box with the Spring Cloud Gateway. So what it is going to do? So if the incoming path is like this, that means /catalog/ and some segment, and in that case it is going to take that segment and then forward the request to /segment, which means let's say you are forwarding, you are making a request to API gateway like /catalog/API/products. So here this is the segment. Here /catalog is matching with that, and this is considered as the segment, and it is going to forward the request to API/products. But to which service? This is the base URI we are configuring. So that means if somebody is making a call to HTTP and localhost :8989, this is the port of API gateway, and if somebody is making a call to API gateway /catalog/API/products, it is going to forward that request to this API endpoint. So 8081/API/products. This is the segment part, and that is where our request is going to be forwarded on this particular service. Okay, so this is how the configuration works. So in the similar way, we have another service, order service, and again we have configured some environment variable and providing a default value, which is 8082. And again, if the path prefix starts with /orders, we are going to take the second segment and then forward that request to this segment on this particular service. And finally, we also need to get the aggregated API documentation. So for that, we are configuring this OpenAPI JSON request here. So again, if there is a request for v3/API docs, it is going to forward to any of these paths and then trying to forward this. We will understand this when we see our API documentation. It will become very clear then. Okay, so the rest of the configuration is MVC problem details is a new feature for exception handling, that is we are enabling here. And there is this is how we can customize to aggregate all the information. Like here we can configure under URLs. Okay, we are giving a name like catalog, and then we are configuring this to v3/API docs/catalog. So like this we can configure, but this is a static configuration. and by simply using this we will be able to see these as groups in the Swagger documentation, and we can see the respective API endpoints in that. But this is going to be static. There is another way to figure out dynamically. Let's say this is all the configuration to simply read dynamically what are all the services we have defined in our YAML file, and then figure out these paths and creating these URLs dynamically. So first I am going to comment this out whole thing, and then I am going to uncomment this, and based on this configuration first we will see how the Swagger documentation looks like. Then we can see how we can make this dynamically by using this configuration. Okay, for now let us comment that out, and I hope this is clear. Now what I'm going to do, I'll see if all the services are already running, and here all the services are running including API gateway. I'm going to remove this. So all the rest of the services like order service and notification service, catalog service, everything is running in Docker. So now I'm going to run this service API gateway only from local. Okay, so let me run it, and I have configured this to be running on 8989. So let me go to so here when I accessed 8989/Swagger UI HTML, it redirected to this path, and here you can see it provided a drop down for all the groups. So where did we configure that? Here. So we gave the catalog, and then it went and fetched the API specification document from this path, and for orders it is going to fetch from this path. So that's how when we select catalog we can see the API endpoints available in the catalog service, and here if you select orders it is going to fetch order API, and we can see all these paths here. So we can see the aggregated entire our microservices Swagger documentation at API gateway level. We don't have to go to different paths like this. And here if you see the path of this API documentation, this is the Swagger API documentation in the JSON format, and its path is v3/API/API-docs/orders. So that is the path we have configured here. And this is where it is going to get the JSON specification for catalog. This is where it is going to get the specification from orders. So that is what we have configured, and it is showing up in the Swagger documentation as different groups. Okay, but as I mentioned, the thing is this is going to be static. Right now we know that we have all these services and we have configured like this. But if we don't want to configure like this statically, we can configure using programmatically. Let me explain what happens here. So Swagger config is a Spring configuration class, and then we are injecting route definition locator and Swagger UI configuration properties. So this is coming from Swagger UI library that we have added here. Okay, Swagger OpenAPI starter, and there are various properties that you can customize, and all those properties are already there. And if you go to this super class here, there is a URLs property. So here you can see set of URL properties. This is what we have configured in our application YAML file. But we don't want to configure like this. Instead, we want to provide this configuration dynamically. So here in the post construct, there is a method, and we are adding this at post construct. That means when the application is loaded, it is going to invoke this method. And here what we are doing, we are trying to get all the route definitions here. So they are nothing but this. These are all the route definitions. And what we are doing, once we fetch all the definitions, we have created this URLs hash set, and then while streaming all these route definitions, we are filtering if the ID matches with something. Dot star means any text hyphen service. If our service ID is matching with this pattern, like here we have catalog hyphen service, orders hyphen service, but this is not matching with that pattern, so it is going to read only these two definitions. And what we are doing with those, so first we are filtering to take only the routes which are matching with this pattern of ID, and then for each route definition it is trying to replace this hyphen service with empty. That means it is going to take only catalog orders. Okay, so that is what name is going to be. And then we are going to configure the Swagger URL like this. So here we are giving Swagger some group name here, and this is the default value API URL, which is /v3/API docs and / whatever the name we are fetching, like catalog or orders. Okay, so essentially we are configuring the same values that we are configuring statically here, but this time whenever you add a new service, let us say we are adding another service here with this same pattern, some service name hyphen service, it is going to automatically become part of this Swagger documentation. You don't have to come here and then add one more configuration here. As soon as you add another service, it is, and if it is of the pattern something hyphen service, it is going to automatically show up in this documentation. So if this feels simpler, you can simply follow this, or if you want to have that dynamic configuration, you can use this configuration. API gateway, as I mentioned, can be used for several purposes. Like earlier we mentioned, if you want to specify the timeouts, rate limiting and all, you still can do that. But in our application, we are just using the API gateway as a gateway which delegates a call to downstream services only. We are not implementing any other functionality at API gateway level. It is strictly using it as a dispatcher to downstream services. So this is all the functionality that we have at the API gateway level, and we have Dockerized that. So I have added this in Taskfile to build the API gateway application also, and then I have added the deployment or Docker Compose configuration. There is no infrastructure component required for this, so I have added this apps.yml. Here I have just added API gateway, and this is going to be the name and API gateway, and a port is 8989. And here is another interesting thing. Here we need to provide, so here if you remember, we have used this environment variables, catalog service URL, order service URL. So when you are running locally directly from your IDE, these values is going to take, but while running all the services in Docker, you need to provide these values different, right? So that's what we are doing in our configuration. So catalog service URL is going to be catalog-service, which is the service name of the Docker service. So similarly like this. And one more configuration change we need to do is, we are talking from order service to catalog service, right? So earlier we have this as catalog. If you take a diff, you can see earlier it was like http catalog-service:8081. But now we are not going to directly talk to any service. Any calls will be go through API gateway. So here we have configured the base URL is going to be API-gateway:8989/catalog. So anything that starts with /catalog is going to be forwarded to catalog service from API gateway. So from order service, we have configured this to API gateway path. Okay. Now I have started all the services, services in Docker. Now let me start all the applications from my IDE. So now I'm starting catalog service and order service and I'm going to start the API gateway. All services are running directly on my host machine. Okay, so I have started all the 3 services. Now if I go and try to open the 8989 Swagger UI, now I can see the API endpoint for catalog and orders as well. So now if I go to catalog service and then try to execute one of the API endpoint, right now let us try to fetch all the products. Now if I click on it, here you see this error, failed to fetch, possible reasons, CARS, network failure, usage of schema, HTTP or HTTPS for CARS requests. So we are getting CARS issue. So most of the times when people building REST APIs and trying to integrate with front ends, like building applications using React, Angular or so, most of the people face one time or other this CARS issue. So before fixing this, let us understand what is the CARS issue in the first place. Okay, let's say you have an application running on some server and assume it's a myapp.com. Okay, so you opened a browser window and you opened myapp.com on this browser window and you are making calls to this same domain myapp.com. So everything works fine because you are on this same origin myapp.com and you are continue making the calls to the same domain which is allowed by default. But if you are currently on this myapp.com on the browser window, but from this application, if you are trying to make API calls to a different domain, let's say here there is another service running otherservice.com. So by default, browser is going to deny that. It is not going to accept making calls to other different domain. So when it is on the same origin, so there is a policy called same origin policy which allows you can make calls to the same domain, but by default it is going to deny making the calls to other services, other domains. So how to make it work? So this is where CARS, cross origin resource sharing, comes into picture. In order to be able to make calls to other domains, so this service, otherservice.com, whatever the application we are running on this server, we need to explicitly configure it in such a way that applications from other domains like myapp.com is allowed to make calls to this service from the browser window. So they need to explicitly, the service, not the browser, the service should be configured in such a way that, okay, I am accepting calls from myapp.com browser window. So it is going to serve the request fine. So once it is configured on this server, then you are allowed to make the calls to other domains as well. Okay, and this restriction is for only browser windows, because when a REST API is opened, you are able to directly call it from REST API, RestClient like Postman or any other tools. But from the browser window, that too from a other domain application, you are not able to call other domain services. Okay, so this is the problem. So now what is happening here? We started this Swagger UI documentation and right now it is running on localhost 8989. So this is a different domain. But now within this, we are trying to call another domain like localhost 8081. Even if the port is different, it is considered as a different domain. So we are trying to make this call to a different domain. So this is not being allowed. So what we need to do it here. So this is the service, nothing but catalog service. We need to configure catalog service to accept any calls from localhost 8989, or we may even configure it saying that anybody can call our services. So we need to configure catalog service or even order service. We need to configure to accept the calls from other domains. Okay, and this is one thing. Second thing is that is even more interesting. So here, if you take a look at our application, so this is how it is, right? Like catalog service, order service, and these calls are going to be forwarded from API gateway. now, and assume this is our web application, maybe React application, or even our current application it is going to be. So here we are going to make calls to Ajax calls to API gateway. So we need to enable this cars to be able to call from this application, but from here we are going to make a call to catalog service or auto service, right? But these are not coming from browser. These are coming from the API gateway application. So for this communication between API gateway and catalog service, you don't need to configure catalog service or auto service with the cars enablement, because these calls are not coming from browser window. These calls are coming from API gateway backend application. Okay. So now we are going to configure catalog service and auto service to enable these cars, but that is only for being able to call this from the Swagger documentation. But to actually call these services from API gateway, we don't need to add that configuration. Okay. Now let's go ahead and add this service from catalog, add this cars configuration to catalog service and auto service. In the catalog service under catalog package, I'm going to create a new package called config, and in the config I'm creating this web config which implements this web MVC configurer. So there are so many methods that we can override here. So we are overriding this add cars mappings, and here I am adding this mapping to any API endpoint that starts with API/anything. So for all of these URLs, I am allowing all the methods, and I am allowing all the headers, and I am allowing all origin patterns by specifying this special value star, which means all. So here, if you really want to restrict it, maybe for few methods like HTTP get, HTTP post, only to these two, you can specify that. Similarly, what are all the headers that are only allowed to pass, you can specify if there is any such restriction you want to impose. Similarly, if you are trying to only restrict from certain domains, you can specify, okay, localhost 8989, or if it is fine, you just want to enable calling this API from any other domain, you can specify it as a star, and this represents whether you want to share the cookies or not. So with this configuration, let us go ahead and run this. With this configuration, restart catalog service and see whether we are able to make this API call from Swagger documentation or not. So here I am going to restart catalog service. And go to Swagger documentation here and try it out. So this time now we are getting the products data. Okay, actual products data. So we are getting this. But as I mentioned, we don't need to configure that if we are trying to establish the communication from API gateway to catalog service. But here what we are doing, from browser window, we are trying to call when we are running an application on localhost 8989, we are trying to make a call directly to a different domain. That's why we need to configure that. So let me, again, to demonstrate, we don't need this for actually running the application. Okay, let me comment this out and restart it. And from here, I'm going to make the call http localhost 8989/catalog/API/products. So here what I'm doing, I'm making the call to API gateway, but I want to get all the products which are there in the catalog service. We have configured every API that starts with catalog/ is going to be forwarded to the catalog service with the rest of the segment. So now we are expecting this to show the products. So it is working fine. So though we did not configure any cars, but here directly from browser window, we are not making the call to catalog service. We are only making the call to API gateway, and behind the scenes API gateway is calling this catalog service. So there is no CARS apply because the communication is not from browser window to catalog service. It is from backend service to service. So there is no CARS in place. Okay, so we are able to call this one. I hope this CARS configuration makes sense to you now. Okay, let's go ahead and in your application, if you need this Swagger documentation to enable this access, then you can configure this. But if you don't want to have Swagger documentation, you don't need to enable this. So similarly, I am going to copy this web MVC config and put it in order service. So right now I am simply hard coding these values, but maybe you can configure these from the application properties and then specify these values. Okay, so it's up to you. Now let me restart the order service and then see be able to call order service without getting the CARS error or not. So from here I'm going to switch to orders and I'm going to get all the orders. I'm going to try it. So currently there are no orders, so it is giving empty array as a response. So there is no CARS issue right now. And one more interesting thing is right now if you see the server URL, it is showing as localhost 8082. Why? Because we are running all these services. We are running only infra services in Docker, but all the main services, microservices, we are running on direct local host, which are directly accessible here. But if you run all of the services, including the microservices in the Docker environment, then it is going to show it as order-service, catalog-service. So in that case, we will not be able to make the call because our host doesn't know what is catalog-service, right? So let's say, let's go ahead and restart all our services in Docker instead of running them in local. Okay, so I'm going to go here and I'm going to restart. So restart is going to start all the infra services as well as microservices, everything in the Docker environment. Okay, now we stopped everything from our IDE. So let us wait, and once the all the services are running, so right now it is still building. So once all the services are running, we'll try and see what is the problem we are facing. So now all the services are running in Docker only. Now let us go ahead and open our Swagger documentation. But here you can see when you open catalog service, it is not localhost anymore. It is catalog-service 8081. Similarly, if you go to orders, it is going to show it as order-service 8082. But now the problem is if you try to execute, let's say we want to get all the API orders, and here it is going to give the same error because not because CARS issue, but because it is not able to make this API call. There is no host saying order-service. So that is why it is giving this error. But what I did, I have configured cat/etc/host file, cat. So here in my host file, I added an entry here, localhost 127.0.0.1 catalog-service. So I added this so that when I access catalog-service, it points back to my localhost environment only. So now if I go to catalog service and try to execute this, so I get the data. So if you are trying to access the services when running in Docker, you need to add this into host file to get it working from the from the Swagger UI documentation. Now API gateway is ready, and let us quickly check the Dockerization part. So here in the task file, I have already added this entry to build the API gateway service as well. And in the deployment, there is no infra dependencies, so there is nothing to add. In the apps.yaml file, I have configured the API gateway service, so this is also done. And pipeline for GitHub Actions pipeline, I have already created this API gateway pipeline, so this is also configured. It is very similar to other services, just we need to change this name, and this is also done. So I think we are good with API gateway implementation, and in the next video we are going to build our front-end web application. We have implemented all the catalog service, auto service, notification service, and then API gateway. So now we are going to start building our BookStore web application. So before starting the development of this module, let us first understand various types of web applications that people are building. So traditionally in the old days, it was like a traditional server rendered applications. In the context of Java, it used to be like servlets and JSP based application where you send a request from browser and then the server process the request and then send back the HTML response. And sometimes, most of the times, it is a full page refresh. If you have a form and you filled all the details in the form and then you submit the entire form, and then it will be processed by the server and then send a complete different page back to the browser. So that is how it used to be, exchanging the HTML. And then later, single page applications concepts came in where all these frameworks like React, Angular, Vue.js, all these frameworks follow this particular style. The whole process is initially when you send a request to the server, it is going to return host page, which is an index, usually it is an index.html or something like that, and that only loads the initial JS bundle, and then everything that happens on this page is going to happen through API calls. For example, when you want to load a set of products from the backend, from your JS, you are going to make an API call and then server is going to return JSON response. And then user performs some action like clicking on add to cart button, anything, user interactions and everything happens through API calls only. Not only that, page transitions also. Let us say you want to show a different page like a cart page or product page. So when user click on a link or a button, those actions are also handled through JavaScript and then use typically some router libraries and then show a different page. So all this process happens on the client side itself. So the advantages are like you don't refetch all the page data every time again. Initially you only get once the HTML layout and everything, and then only the data changes through API calls. So the data transmission between the client browser and server is minimal. But these single page applications come up with its own challenges, like implementing SEO is a little bit difficult, and sometimes when people are viewing your web application from low power devices like mobiles and all, maybe heavy processing is happening on the client side, so it may not be as performant as server side rendering. So that is the reason in the recent times people are slowly preferring again server rendered technologies like using Next.js or something like that. Okay, but before people going from this model to this model, there is another concept called multi-page applications. So here, initially, let's say you are requesting the home page of a website. So first it sends a request and then server returns the page response as HTML. But then onwards, everything that happens, user perform any actions that are going to perform based on the API calls and then through AJAX requests. So here, when a user clicks on a button or something like that, you trigger a AJAX call and then perform the necessary actions here. And then let's say user want to view a completely different page. Again, maybe user click on a link or something like that, and you go and make a second page request which returns the completely different HTML page, and you render that. And again, in the second page, if there are any actions, those will be performed through Ajax actions. So like that, there can be multi-page applications, though it is not as popular as single page applications. But in my view, this is a really interesting approach to follow, because when you try to build single page applications, though it looks very attractive in the recent times, it brings all the complexity of building single page applications with all the Node.js ecosystem and NPM and everything. But if we can still build applications with Ajaxified interactivity using server-side rendering technologies like Thymeleaf and technologies like Alpine.js or HTMX, without bringing in all the Node.js things into our applications. As I mentioned in the initial video, the goal of this course is to teach you how to build microservices using Spring Boot. The core focus of this entire course is on the backend building the microservices and everything. But for the completeness, I'm going to build the UI also, the web application. And the reason I want to go with this approach is, while building this, I want to use Thymeleaf, and I want to demonstrate some techniques like how you can make calls to other services like API gateway, and by using declarative HTTP interfaces. So I want to demonstrate some more features of Spring Boot. So that is the reason I am not using any single page application. Instead, I am going to build our web application using Thymeleaf. And for the API calls, I'm going to use Alpine.js, and we are going to build our application as a multi-page application. I have created the BookStore web application module from Spring Initializer here. I provided the project metadata, and then I chose Spring Web and Thymeleaf for Thymeleaf templates. And then I'm using Actuator and DevTools and configuration processor for development purpose. And then I'm using validation. So we don't have anything for backend databases, things like that, because we are going to call backend APIs for all the backend functionality. So these are all the starters we need for now. And I have generated the application using this configuration, and I have copied the generated code into our repository here. So here we have BookStore web app, which contains the starters that we selected: web, validation, Thymeleaf, and Actuator. And also I have configured our usual stuff like spotless-maven-plugin and Docker configuration here, and Git commit ID plugin and Spotless plugin, and customized for creating the Docker image. So you know this. So our initial project is ready, and if we take a look at our application name here, even though it is implicit, let us make it explicit. Here we are using server port 8080. Okay, so we have our initial application in place, and now if we take a look at what are all the services running in our Docker, we have all the backend services like order service, catalog service, and databases, RabbitMQ, and API gateway are already running on our Docker. So during the development, we are going to start only a BookStore application, and then we are going to talk to the API gateway, so that you can simply keep changing the code and then restart instead of running building the Docker image and then again deploying. Okay. First, let us create a controller to render the home page which displays the products. So here under web app, I am going to create in web package controllers, I am going to create product controller. Okay, so this is going to be a controller, not REST controller, because we are going to render the Thymeleaf templates, not returning the JSON response. So here first I'm going to create a get mapping, and so here initially when we are asked for the root page, I would like to redirect it with a products page. So I am going to mark it as like this. So what this will do, when I access localhost 8080, it is going to handle by this, and it is going to redirect me to /products page. So I don't need it to be public. And now again I am going to create another controller that renders products. So here the path is /products. Okay, so here I would like to render the template products.html. So by default, when you are using Thymeleaf, it is going to expect you to have this template under src main resources templates folder. So let us go ahead and create a Thymeleaf template products.html here. So here I am going to put this basic Thymeleaf template. So right now we are not using any Thymeleaf directives, but this is the basic template you can render. So first let us run our application and then try to see whether we can render this or not. So the application is started. Now I go to localhost 8080. So you can see that is redirected to /products page, and it is rendered this template here. So it is now working in its initial form. Now what we are going to do, we are going to add more features, like we are going to use Bootstrap for styling. So what we can do, we can go to get Bootstrap page, and here if you take a look at read the docs, so here you can see this is the initial page where you can copy some of the text here under head element, and let us copy the script for Bootstrap.js. So before body, I'm going to add this. So this way you can include Bootstrap styling and JS support here. And just to ensure our Bootstrap is loaded correctly, let us display a simple button here. Click, and then let us apply class btn primary. So if this Bootstrap styling is loaded properly, this should display in a blue color. So let's restart this and go ahead and refresh it. So it is rendering in blue color. So that means Bootstrap is loading correctly. This is fine. This is one way you can include your scripts like this, which is directly loading from CDNs. But if you do not have internet connection, it is not going to work. So I would prefer, again, it depends on your production deployment consideration. In production, most likely you have an internet connection working, and using CDN might actually be better for loading the scripts in a more performant way. But for our development purpose, I am going to use a library called WebJars. So here there is a WebJars library which packages all these front-end related CSS or JavaScript kind of libraries as Java jar files, and we can include them and we can reference them in our Thymeleaf templates. So we are going to use WebJar support instead of directly including CDN links. So let us go ahead and add Bootstrap WebJar here in our pom.xml. So I'm going to add. So this is the dependency for loading Bootstrap. The latest version is 5.3.3. So this is how we can load it. So once we load that, how we can include the Bootstrap which is there inside that jar file. Let me replace this entire file here. So this is how I can reference the here you can see this is how I am including the Bootstrap CSS file. So if you take a look at our dependencies here, you can see under external jars, if you go to all the way down, you can see web jars bootstrap directory, bootstrap jar here, inside which you can see under meta inf there is resources, under which there is web jar bootstrap 5.3.3, and then there is JS and CSS folders. So in servlet specification, you can serve the static resources or even JSPs and everything under meta inf resources folder. So that is the technology that we are leveraging here. So we are able to directly reference this path under meta inf under resources. So we are giving web jars bootstrap 5.3.3 CSS and bootstrap.css. Similarly, we are loading bootstrap bundle.js also. So now let us go ahead and restart and see whether it is still working fine or not. Okay, now there is no button because I have replaced this entire thing. Now if I again put it back, click and class btn primary. So if I restart now, it should pick up this. So it is loading fine. So this way we can load any JavaScript libraries or anything like that. If they are available as web jars, we can use that. So in the similar way, I am going to use a few other libraries as well. Like we are going to use jQuery for making call to backend APIs, and FontAwesome for including some icons, and Alpine.js to actually load the data and render the UI. So I'm going to add all those dependencies as well in our pom.xml. So here we have jQuery, FontAwesome, and Alpine.js added as a web jars. Okay, let me restart. So I'm going to update the template here to include all those. So I'm going to replace the entire thing. So here what I did, just like the way we have included a bootstrap, I also included FontAwesome CSS here. There is no file yet. We have to create this one. And in the JavaScript section, I am loading jQuery first and then bootstrap, and finally I am loading this Alpine.js. So let us go ahead and create this file under our static directory. So we are going to use this styling for our menu bar, top nav bar here. So here we are adding some padding top. We'll talk about it when we are building top navigation. So right now, this is how we can create a simple Thymeleaf page. But going forward, we will have different pages, and we are going to have top nav bar, but we don't want to keep copy pasting the same nav bar or any other common elements for every page. So this is where we want to use some kind of a layout mechanism. So Thymeleaf supports a layout dialect, which you can use and create the layout files and include that as a layout in other pages. So let us go ahead and add the dependency here, Thymeleaf layout dialect. So this is going to give us Thymeleaf layout support. So once we have that, let us go ahead and create a layout file under templates. Layout.html. So our layout.html is going to contain a few placeholders here. Let us take a look at. So what we are doing, in addition to right now we don't have security in place, so here I am including this layout support here, and I am using I'm including all these bootstrap and CSS, FontAwesome CSS, and our own custom CSS. And in the main body I am including a top nav bar here to display the navigation bar and the links. So right now we have cart link and then orders link, and we have the main part where I have given the ID app and a class container. So this is, again, we are saying layout fragment equals to content. So this is where the remaining pages are going to include their own page specific content. So the rest of the content is going to be common for all the pages which are going to use this layout. Okay, and again we are including all these scripts like jQuery, Bootstrap and Alpine.js. And one more thing, here we have included layout colon fragments, fragment page scripts. So in any specific page, if you want to include additional JavaScript files, you can include this here. I mean in whichever page you are going to use. So right now we put it as a empty placeholder here. We'll get to know how we are going to use this feature. Okay, so basically this is the common layout we have here, and each page specific content is going to come here. Okay, so now let us refactor our products.html file to use the layout. Okay, now what we are going to do, we are going to change this to this. So here we are saying layout decorate equals to layout. So we are referencing the layout HTML page, so that we don't need to again include all those CSS files, JS files in every page. So here I am specifying this is the layout I am going to use, and only I need to include the dynamic fragments here. So here this is one fragment, layout fragment content, and also there is another. If I don't want to include any one of the specific segment, I can ignore that. But here in products.html, I am currently including layout fragment content equals to display products here. So it is going to render everything in layout.html, but in this it is going to display this content. Okay, so now let us restart and then see whether it is working or not. Okay, the application started. Now, yeah, now I can see the top navigation bar is displayed, and the products content is being displayed. So it is rendering the page with the layout support. So that is working fine. So here in our layout page, we are including some image. Maybe we don't need this. Let us remove this, and so now we have a basic template ready. Now we are going to see how we can use Alpine.js to make an API call to API gateway and then fetch the product details and then render them. Okay, let's take a quick look at what is Alpine.js and how we can use them. So simply you can include this Alpine.js as a script, and then this is the scope of this X data. So here you can initialize with some data and you can reference that in your markup. So here if you take a look at this span, here there are some custom attributes provided by Alpine.js like X show, and equals to open means if it is open is false, it is not going to show up. If it is true, it's going to show up. So like this, there are some attributes provided by Alpine.js, and based on the data, you can provide this dynamic behavior. So again here, it is providing this click handler where you are simply assigning open equals to true upon clicking on this button. So like that, you can scope your markup, and then you can provide this dynamic data and then act upon that data based on various activities that you are going to perform on these various elements. So it is as simple as that. It just provides very few attributes only, like you can see only there are a handful of elements that you can use. And let us take a quick look at how we can use this Alpine.js in our application. So right now we have our application and we have already included Alpine.js in our layout file itself. So it is available for our application. So now let us go ahead and create a JS file here. I'm going to create a file called js/products.js. So in this file, let's imagine we are going to implement the logic related to the products page. So here what we can do, we can write a event listener here. Let's go ahead and take a look at in the documentation itself. So here this is one way. I mean, here earlier we have seen this is one way to initialize the data, but obviously we are not going to have some static data. We want to load some dynamic data, right? So how we can load dynamic data? If you go ahead and see this globals Alpine data, here you can see this is another way to initialize the data for that specific page. So here we are adding a event listener Alpine:init, and we are providing a function here to execute, and within this we are giving this name dropdown and again providing a function here. So here we are initializing open equals to false and then toggle creating a function to change the state of this open flag. And once we initialize this data, here in the markup we are calling this x data equals to dropdown. This dropdown is nothing but the name we are given here, alpine.data, and this is the name of the function here. So when we add this, it is going to invoke this one and then initialize the data, and these functions are available for us to call here. So we are using this approach here in our products page. What we are going to do here, earlier in the layout file, we specified this layout page level scripts. So we want to include this products.js in our products page. So what I'm going to do, I'm going to include this, and then I'm going to include script src equal to js/products.js. So here we are giving the name as init data. So we need to call it somewhere from here. So let us see how we can call that data. So within this fragment, let us say we are having a div that has x data equals to, we are calling that function init data, which is nothing but the function name here. Okay. So what happens now when you load the page, it is going to include this script here, and then we are it is going to call this init data to initialize this Alpine.js data function, and initially it is going to set count value to 0, and if you want to initialize any data, you can set it in this init function here. So as soon as this page is loaded, a count equal to initially 0, but init function gets executed and count value becomes 25. Now in our function here in our template, we can use that to render some values based on the data that we have initialized. Let's say we want to display there are some number of products. So here initially I put it as a 0 within this span, but I am using this x-text directive and specifying the variable name here, which is available in this scope. So I'm trying to print whatever the value assigned to here in this h1. Okay, so let us run this and see what we are going to see in this page. Now if I go and redisplay it, here you can see there are 25 products. So we are going to follow the similar pattern where we have created a controller and then we are rendering a template, and within this template we are calling some init data function, and we are initializing whatever is required to render that page. Right now there are no additional functions here, but if there are any additional functions, for example here we may render all the products information and provide add to cart button, and when we click on it, maybe we will write a function here to handle that event. So like, but what about if we want to pass some initial data to it? For now, let us say we want to load the products, right? But we also want to implement some pagination also. For that, our page controller would be like, it is going to receive a request parameter called name equals to page and default value is 1. Okay, int page number. Okay, I want to I want to include this page number so that I will load that specific page products here. So how can I do that? So here we can pass the model. So if you have used Thymeleaf, you might be familiar with this. If you want to pass any data from your controller to your view template, you can set them as model attributes. So here I am going to set add attribute and specify page number equals page number, this page number value. Okay, so now how I can use this one? Okay, so if you go to template, here you can specify that value here, like you can include $page number. So it is going to render this with the dynamic value that we put in the model, and this is going to be passed as a input parameter to init data function in this one. So here you can specify page number, and let us say we are going to maintain this page number, and we are going to just print here console.log page number, this dot page number. We just want to load for this specific page of products. So now if we go ahead and change it here, so let me update this as load page 0 or whatever products. Okay, now let me restart this. So basically what we are doing, we are capturing if there are any request parameters or anything like that, and we are putting them as a model attributes, which we can render in Thymeleaf like this, and we are rendering it as an input parameter to this init data function itself. So that is going to be passed as a input to the callback function. Okay, and this we can initialize it to some private variables or directly use it here. So you can do whatever makes sense for your business logic. So right now we are just initializing it to this local variable page number, and then in the init function we are calling, basically this is where we are going to make a backend API call to load the products. So now if we go ahead and reload this, now it is showing load page 1 products. So now if I pass this page equals to 3, it is going to page load page 3 products. Like that you can capture any dynamic values and then pass it to our Alpine.js loading function. I have added the logic to fetch the products information and then rendering in our products.html page. So instead of keep typing, I have just added all the logic that is required to display this products information. So I'll walk you through what this logic is going to do. So here again, we are going to take this page number from our controller as an attribute that is getting passed from here as we discussed. And then within this products.js file, we are initializing this local variable page number, and also we are initializing this products object which contains data with an empty array. And in the init function, we are calling this dot load products information, passing this page number. So if we are calling the default page, it is going to be 1. If it is page number equals to 2, it is going to contain 2. So we are calling this function here. So here we are directly making a call to our API gateway catalog/API/products and page number equals to whatever the value we are passing. And once we receive the response, we can see what kind of response we are getting, and then we are assigning that to our products. So ideally this is going to contain, let us see what kind of response we are getting from this API call. So here data will contain all the products information. In addition to that, you will contain total elements, page number, total pages, all this pagination related information, and data is the one which contains the actual data. So we are assigning this response to our products variable. Now once we have these variables defined, now we are using that information to render this products information. So we have the pagination here. We will talk about it in a bit. But now here we are rendering 3 or 4 rows as columns, and then we are looping through X for is a Alpine.js directive here attribute, and X for the products.data. So this is the actual data that contains the products information, right? So we are looping over this data, and in each product information we are rendering as a product card. Okay, so here we are using :src, means we are using again Alpine.js reference here. We can assign dynamic value like this. So within this products there is a property called image URL, and this is a shortcut way to specify x-src like that, and we are displaying the product image, and then as part of the card body we are displaying product name. So here we set some static name, but that value is going to be replaced by this X text, and we are referencing product.name. Similarly, we are displaying product price like this, and at the footer we are having a button called add to cart, and we are assigning this click handler add to product, which we have not yet implemented. So now with this, now let us take a look at this pagination. So here we have created a folder called fragments, and we have a pagination.html. So this contains the pagination rendering logic here. So this is the pagination one, and we are checking if products.total pages is more than 1, then only we are going to render this pagination bar, otherwise we are not going to render this. And this is nothing but bootstrap pagination markup here, and we are using this dynamic value. If pagination is at the first page, we are assigning disabled class for this one, because if the user is already on the first page, there is no need to enable this button, this hyperlink. So like that we are applying conditionally if it has a previous page or not, and then comparing, and then assigning the URL like /products/ page equals to, so the current page +1 or -1 based on the next page or previous page, we are rendering that one. And this class is to whether to enable that button or not. If you are already in the last page, there is no need to enable that, so we are disabling like this. So it is a simple pagination rendering here, and we are including that in our products.html page like this. So this is the root path. From templates, there is a fragments folder under which there is a file called pagination, in which we are referencing this fragment name pagination. So that is what we are specifying it here. With all this, now if we restart our application and try to render, it will pose a problem. Let us see what is the problem. So now when I try to render, it is giving me this error, access to XML HTTP request at 8989 products page from origin localhost 8080 has been blocked by CORS policy. The access allow origin header contains multiple values *, HTTP localhost 8080, but only one is allowed. So this problem is occurring for two reasons. For one reason, one is we have already configured our API gateway to enable the CORS for this value *. But in addition to that, we also configured in our catalog service CORS configuration. Here, right? So due to this, it is adding one more endpoint like localhost 8080 and *, and only one value is allowed. So we can do in two ways we can fix this problem. One is remove this configuration from catalog service. That is one approach. If you do that, you will not be able to make these calls from your Swagger documentation. Another approach is in your application.yaml file, you can configure one more property under cloud gateway default filters. So here you can specify a filter called dedupe response header, and you can specify all the headers that you want to deduplicate. So if there are multiple values, what you want to do, you can specify. So here you can specify all the headers, and then you can specify what action you want to take if there are multiple values. So there are some possible values like retain unique, retain first, like that. So I'm going to use retain first. So that means whatever the value that comes first is going to be retained. In our case, it is going to be star. So it should fix the problem. So now what I'm going to do, I am going to restart all the services, backend service here, and then retry this. Now let's go ahead and reload this page. Now we should be able to see the page with the images and products information here. So you can also see the pagination here. Now we only have 2 pages of data. Now you can see. So it is working fine. But currently the functionality of adding to cart is not yet implemented, but we are able to fetch the data and then render it. So again, I am going to quickly iterate through what we have done here. And so the flow starts at when you access products page from your application browser. It is going to redirect to these products, and here we are taking page as the default value 1, and if you pass anything specific, it is going to take that value and put it in the model and render this products page. In this products page, we are rendering this dollar of page number. It is going to render by Thymeleaf as whatever the value. Right now it is going to be 1, and this value is going to be passed to this Alpine.js init data function in our products.js. So now page number is going to be assigned to this local page number, and then products we are initializing with some empty data within this data array. And in the init function, we are calling this load products by passing this page number. And in the load products, we are directly making a call to API gateway, catalog/API/products, which is going to strip off this catalog prefix and then forward to actual catalog service and get the products information. And if you take a look at the response here, you can see product response contains all this has next, has previous, is first, all this product pagination information and the actual data. So in our page, we are returning 10 elements. Okay, so we are rendering all this information. We are assigned this products data to this variable products. And once we have these values, we can use that in our template to render the actual HTML markup. And here we are using X for, which is a Alpine.js custom attribute, and we are looping through products.data, and we are rendering each product information by specifying the image URL and title, product name, product price, and we are rendering this add to button. Okay, so also we have this pagination information. We are rendering this. So this is how we are rendering this products page. Next, we are going to implement add to cart button functionality, and how we are going to implement it. There are different ways. In real applications, most likely that data is going to be stored in, let's say, in database or somewhere in the server side. But to keep things simple, I'm going to store that information in the local storage of a browser. So let's see how we can implement that functionality. As I mentioned, we are going to store the current cart information, what are the products that we added, in our browser's local storage. I have created a cartstore.js file in our JS folder. So here it has a bunch of utility function to add a product to the cart or to remove or update the quantity like that. So let us quickly go through what it contains. So we are having a key based on which key we want to store this cart information, and here there is a function called getCart. What we are doing, from the local storage we are getting this based on this key value, and if it doesn't exist, we are going to create a new empty array with items as an empty array and total amount as 0, and we are stringifying that, and then we are putting that cart value as a item in this local storage with the same key, BookStore state key, which is nothing but BookStore state, and then returning that value as a response to getCart function. And then there is add product to cart function, which takes a product information, and then we are first we are trying to get cart, which is going to determine if there is any cart already there in the local storage. If not existing, it is going to set one and then return that. So now that we have cart, we are going to find if there is any product that is already exist with the given same product code. So we are filtering out based on the product code, and if such an item already exists, we are going to simply increment the quantity. So we are taking the current quantity and doing +1. Otherwise, we are going to push the current object into items. So this is going to set this quantity as 1 and put the product as the value and push it to the cart items. And then again setting that by stringifying that value, setting it as the BookStore key in the local storage. But again, once we do that, we also call another function to update the cart item quantity. Right now, if you take a look at our UI here, initially we are rendering that as a 0. If you take a look at our layout file, initially we are showing it as 0. But we gave this ID cart item count. So in our function, when we are calling this update cart item, what we are doing, first we are taking that cart value and initializing with count as 0, and then looping through all the items within this cart, and then calculating the total count value, and using jQuery we are setting the text as this parenthesis and count. So whenever we are adding a product, or in fact we are updating any product quantity and all, we are calling this function, reusable function, which is going to recalculate how many products are there and then accordingly update that text, how many count is there. So similarly, we have update product quantity. Again, we are going to send the code, product code, and how much quantity we want to buy. So this is going to be used in the upcoming screen, where we are going to show cart with all the products. There you can directly update any quantity of any product that you are already added to the cart. So that's where we are going to use it. Similarly, you can delete a cart and then by simply removing that from local storage. So these are all various utility functions in order to add, remove, delete all the items from the cart. Now, this is the common functionality for all the pages. So what we are doing in the layout.html page, we are adding that directly, not inside the fragment page scripts above that. So it is commonly available for all the pages. Once we add this, and within our products.js file, we have added a function add to cart, which is taking the product information. And we are calling this add product to cart, which is available in cart store. So now if you take a look at one more time, this is going to include in all the pages, and in that there are top level functions available, and we are calling one of that function from our Alpine.js by passing this product information. Okay, so now let us see how we are calling this add to cart. In our products screen, here at the footer, card footer, we have a button with @click. This is a shortcut for click handler, and we are calling this add to cart, and we are passing this direct entire product information. Okay, so like that we have implemented this add to cart functionality. Now let me restart this, and let me restart this as well. So initially it doesn't have any products. Now if you take a look at local storage, localhost 8080, there is no data also. Now first let us click on add to cart for this. So immediately you can see here BookStore state, it added this items and then added this current product to the cart, and this also got updated. Now if you add another product, it is going to contain one more product information. Here you can see 2 products, but if you add one more product existing type, it is going to simply increment the counter quantity. So here we have 2. So like that we are simply adding that and then showing this in the cart header here, how many products that you have added. Let me add one more and it will change to cart 4. So like that you can simply add the products to the cart. Next, let us implement the screen of showing the cart information and being able to place an order. So here when user click on this link, it is going to take us to the /cart page. So let us start with implementing the controller to handle that. So here I have created another controller next to the product controller. I have created order controller, and it is going to take this get mapping of /cart and trying to simply render this cart page. So again, that cart page is there in the templates, and here if we take a look at cart, it is going to follow in the similar fashion here, where we have this init data. We don't need to pass anything here, but what is going to happen in the init data, let us here if you take a look at it, at the end we are including this cart.js file. So this is specific to this cart page. So I have created a cart.js file here, and again similarly we are loading this init data function to initialize the data, and initially we are going to set this cart to an object containing empty items and total amount as 0, and order form, and I am initializing with some sample data so that I don't have to type this, but usually this is going to be all the empty values here. And in the init function, so we are first calling this update cart item count, because whenever user clicks on this one, we need to still show how many items are there. So we are calling this function, which is going to read from the local storage and calculate the count of items and then display it there. Next we are calling this load cart. So load cart is another function here, which is going to simply call get cart, and this get cart function is coming from cart store. Okay, so now what else we are doing, and initially we are also calling this get cart total. Again, this is another utility function in the cart store to simply calculate the total amount from each of the items and then summing it up. Okay, so these are all the utility functions here, and we have load cart is just loading that cart, and then here we have update item quantity, where we can take the code and then specify a different quantity. So we are going to call this update product quantity, and this one, it is going to update product quantity. Again, we take the code, product code and quantity. If the quantity is less than 1, that means we are trying to remove it. So we are going to filter out which is not equals to the code and assign the remaining items to cart items. Otherwise, we are going to update with the new quantity value. Okay, so that is that, and we are going to reload if we are updating the quantity, and then we are going to reload it and then recalculate the total items. And remove cart is once the order is placed, we want to just delete the cart. And create order is where we are going to take the order form details, where we have all this information, and then we are going to populate the items values also. And finally we are going to pass that as a payload to this API endpoint, order service API endpoint. We are posting this and then creating a new order here, and if it is successful, we are removing the cart, and then if there is any error, we are displaying order creation failed. Once we successfully place the order, we are supposed to redirect it to display the placed order details. So right now we have not yet implemented, so I am simply showing this alert as order placed successfully. So it looks like there are many things going on, but basically we are simply updating the item cart and then loading as it is required. So let us go ahead and add some products. So I'm going to add some products and then click on it. So now it is displaying this page, and all this information is pre-populated because I have set some sample data. Now if you want, you can update it to a different value. Okay, so once you update it, and then here these are the ways you can update the quantity. For example, I want to change the quantity to 2. So now it automatically calculates this subtotal and then display it total amount also. So how it is happening, when I change this quantity, it is calling this update item quantity. Now here if you go to, let me close some of these. So in the cart page, when we are displaying products information, we are calling on the input. So we are basically displaying the current quantity and also registering change event listener here, update item quantity, and passing item code and the current value entered in the input box. And we are calling this update item quantity. And update item quantity is the function defined in this cart.js, which is going to again call some other functions to update the actual quantity and then set it in the local storage. So that is how it works. And now finally let us go ahead and place the order. So now order placed successfully. So now we are able to place the order, and also if you take a look at it, order is the cart is removed, because once we successfully place the order, here we are calling this remove cart, and remove cart is calling delete cart. Delete cart is a generic function in this cart store. And delete cart, what it is doing, we are simply removing this bookstore state here. Okay, so that's that. Now next, what we are going to do, once we successfully place the order, we want to redirect to the new order created order page, where we want to show details about that particular order. Okay, let's work on that. Currently, once the order is successfully placed, we are simply showing this alert as order placed successfully. But right now, let us comment this out and then redirect the browser to /orders/ whatever the order number that is we got from the response, so that we want to show complete details about that particular order. So here the assumption is we are going to get this order number as part of this create order response. Okay, so now in order to implement this, we need to handle this URL in our controller. So I have added that in our order controller, another get mapping which takes order/ this dynamic value, and we are populating that value here, and then we are simply setting that as an attribute and rendering this order details page. And here in order details, I have created a new template order_details.html. And again, like the way we did for products page, we are passing this order number to the Alpine.js init function. So let us go ahead, and I have created order details.js also for this screen. And again, I have this init data and then passing this in order number here. And I'm initializing it to order number and then setting all these to empty values for this order details. In the init function, again, this is to update the current count, and then this is the actual call to this function to load the order information. We are passing this order number, and here we are making API call to order service through API gateway by specifying this order/order number. Once we receive the order details, we are setting it to order details. So we have all the order information in order details. So now we are using that information. So here we are simply placing your order is placed successfully, and then we are showing order number, order status, and we are also showing looping through all the items. We are showing all the quantity and subtotal and everything. Okay, so we are we are also displaying this customer information, okay, delivery information, all these values we are fetching it from model. Okay, So this is how we are using the information loaded from Alpine.js into our templates. So this is kind of a very similar to Vue.js. If you are using Vue.js, plain Vue.js, the functionality looks very similar. Okay, so now with this setup, let us go ahead and one more thing, like we need to include the page specific script here using page scripts fragment. Okay, now with this, let me restart. And let us go to page, reload this and add a couple of products and go to cart.js. Now let us update some quantity here and place order. So now order is placed successfully, and then we are taken to 8080/orders/ this order number, and we are able to see the order status as new and the quantity and everything, and also customer details and the delivery address. So in the background, I think by now it should be changed to delivery order status to delivered. So let us reload. Now the status is displayed as delivered. So this is the URL that you want to display more details about a particular order. Okay, so now this is also working fine. Now next, what we are going to implement, we want to display all the orders information. When we click on orders, we want to show all the list of orders that is placed by the current logged in user, but right now there is no login information. In the backend also there is no login functionality, and statically we are going to fetch all the data anyway. So let us implement this screen. In our layout.html file, in the top navbar, there is a link called orders. Here the link is going to /orders. The URL is going to be /orders. So first let us go ahead and implement the handler for get mapping /orders, and we are going to simply render this template orders. So here in the orders template, again we are doing the same thing, first trying to initialize the data from Alpine.js by calling this init data. So where is that? Again we have included this orders.js file and included that. So now let us take a look at this orders.js. Again same, we are initializing the data here. Initially we set orders to a empty array, and then we are loading the orders and also updating the item count in the cart. So here in the load orders, we are making the calls to fetch all the orders, and we are getting all the orders information and then assigning to this array. So once we have loaded this orders information in our orders.html, we are looping through all the orders, and then we are linking this as a hyperlink to view more details, but currently showing this order number and also order status. We are just showing these two and included this order.js file. So now let me restart, and when we go to BookStore, and now if we click orders, we can see all the orders details with just order number and status only. Now if you click on any of this link, you can see more details about that particular order. So simply we can do like this. So this is the whole functionality without authentication, but there are few things that we have not implemented properly. For example, in each of the JS files, while making backend API calls, we are directly hard-coded these values, localhost 8989 and orders. So we have hard-coded this one. So one thing we could do is make it as a configurable application property in from the backend, and while rendering this page, we can load it and then use that value instead of hard coding like this. So first let us try that one. As we don't want to hard code this API gateway URL for in most of the JS files, we want to centralize it in one place and then use it. So what we have done, we have created a application properties class with the API gateway URL, and prefix is BookStore, and we have configured that value in our application properties file. So here we have bookstore.api gateway URL configured to this whatever value, so that when we are running the application entirely in Docker containers, we can provide Docker container host name here instead of the local host or anything like that. So now how do we get this property value into our JavaScript? So one approach that Thymeleaf provides is, if we take a look at our layout.html file, here you can get the values from the environment variables by using this expression. So it is going to inline the value of this expression into this Thymeleaf template. So here API gateway URL value is going to be whatever the value that we have set for this property. Okay, so once we have initialized API gateway URL as a, if you notice here, it is included as a top level variable in the page. So any script that is going to be included afterwards can use this variable. So we are going to use that and replace everywhere. First let us start with this cart, and here I'm going to use like this. Okay, so that is that, and in order details again we are going to include this plus. Okay, next in the orders again we are going to use that variable, and like this. In the products also we can use this like this. Okay, now let us go ahead and restart our application and see how it actually works. Now let us refresh, and if we take a look at generated HTML view page source, here at the end you can see it is replaced with the value. It is though escaped, but the value is localhost 8989. Okay, so now when we click on add to cart and then go to cart page, place order, it is working fine, and you can also go to orders, and so it is using this configured value just fine. Okay, so this is working fine. But again, in the most of the pages in this application, it is calling only one API endpoint and then rendering the page. Let us say what happens in our products page. We want to display products by first fetching the products information from catalog service or assume product service, and then you may also have another service like promotions or something like that, recommendations or something like that, and you may want to show some recommendations also. Then again you may want to include it here to make another call. But instead of making these calls here, we may take a design choice where you want to make a call to one API. Maybe in the product controller you want to make a call to one API endpoint, and here you make those external calls, multiple calls, one to catalog service, another to promotion service, and then aggregate all that data and then send it back. Then instead of directly making the calls to catalog service, you only make the call to one of your local API endpoint, and from there you can talk to other services, be it catalog service and all. So we are going to see how we can implement that behavior. So why we are doing that? The whole purpose of doing that is to demonstrate how we can use declarative HTTP clients to make calls to catalog service or order service and communicate without writing REST client based logic. Okay, let's go ahead and see how we can implement that. We have talked about the new REST client support added in Spring Framework 6, REST client and HTTP interface as well, but we have used REST client while communicating from order service to catalog service. This is one approach. Another approach is HTTP interface. So if you are familiar with Fian clients, it is kind of a similar. You create an interface and then you use various get exchange, post exchange kind of a methods on these method definitions. and you configure to which service it needs to talk to, and Spring is going to generate the proxy and provide the implementation to actually make the call and then return the response. We don't have to actually write the logic to do all that. We just need to create the interface and then write this method call definitions here. So we are going to try this option here because we just want to know how we can follow this approach as well. If you remember in our order service, if you take a look at our order service, we have used in our clients, we have used catalog service, and here we have used RestClient, and then we are making call to get URI so and so. So we are implementing it like this. But now we are going to see how we can use that HTTP, declarative HTTP interface for talking to other services. So let us go to our BookStore web app, and I have already prepared that code. Here in our web app package, I have created a clients package, and let us take a look at our catalog. And here we have this product record which contains all this information, and we have page results also. This, if you remember, this is nothing but the page result, the response we are going to get from API/products API endpoint. And here we have catalog service client, which is simply an interface, and then we are using this at get exchange, post exchange. If you have any post methods like that, you can use methods like this, and we don't need to actually implement this. We can configure our Spring in such a way that it is going to generate the dynamic proxies for it. Okay, so here the first one is to fetch all the products from our API gateway. So here we are excluding the base URL of our API gateway, and then we are adding rest of the URL segment. So here for getting one product, we are adding this API endpoint. So if we go to clients config, this is a Spring configuration class here, and then we injected this application properties, and this is how we need to configure our catalog service client. So here we are creating a new RestClient instance by taking the base URL from our properties, and then we are creating a HTTP service proxy factory, and we are specifying this RestClient, and then we are calling create client and passing this interface. So it is going to dynamically generate the proxy and then return it. So similarly, we also have all the models, and then we have this order service client, which has all these methods for creating an order, get order, and get orders. So all this we can just define like this: post exchange, get exchange. And if you are familiar with this OpenFin or something like that, it is very similar. So we just don't need to again use an external library like OpenFin or something like that, because that functionality is right now available in Spring Framework 6 itself. So we have configured both catalog service client and order service client. Now what we can do, we can inject these clients into our, let's say, product controller. So earlier we do not have this injection here. Now we have injected product in the product controller. We have injected catalog service, and we have added a couple of one new endpoint, and here we are saying get mapping /API/products, and here we are also adding this at response body because this is a normal controller and we are trying to return JSON here. So we added this at response body, and from here we are again taking this same page number, and then we are trying to get products information from catalog service. Okay, so earlier what we did, we directly called from our templates here. If you go to JS, from products, we directly called the API gateway from JS itself. But now with this API endpoint created, we can simply call our local BookStore REST API endpoint, and which internally going to talk to API gateway. So here simply we can take away this and also this. So this API now is going to call in the product controller this API endpoint, not the API gateway directly. From here, we are going to make a call to API gateway. Okay, this is going to be talking to API gateway base URL /catalog/API/products, like that. Okay, and again, as I said, in this case, it doesn't make much sense or benefit because we are making simple one API call. Why can't we directly make that call from here itself? But as I said, just imagine if you are in a scenario where you need to make multiple calls and then get the aggregated data in order to render a page. In that case, maybe you can provide a local API endpoint, and here you make multiple calls and then aggregate that information and then give it the response. But the actual reason why I'm doing this is to demonstrate how we can, from one service, if you want to make a call to another service, using HTTP declarative interfaces, this is how you can do it. Okay, you can simply create an interface and then configure it like this, and you will be able to consume the data from there. So right now we just updated in our products.js to make the local call to product controller to this API endpoint, and then we are going to get data. So let us restart and then verify this is going to actually work or not. Now let us go ahead and see whether it is working fine or not. I am reloading this and still I am able to see the products, so it is working fine. Now let's go ahead and do the same thing for order controller as well. So here, if I go to order controller, I have made that change where I have injected this order service client, and so this is the API. Earlier we already have it, we simply render a cart. But here, while creating a new order, instead of directly calling the API gateway, we have created a local API endpoint. And here we are taking that order and then we are calling this API, order service client API. And similarly, while fetching the, while getting the order details, again we have a local method that first get from the order service and then provide the response. So similarly for all orders, we are first fetching from order service and then returning it. So now respectively we need to make changes in our other places as well. So here now we don't need to make it direct call to our API gateway. Instead you can make it to a local call. So this API/orders, this is for creating the order, right? So that is going to be handled by this API endpoint within the BookStore web app application itself. So now this is done, and if you go to order details, again you don't need this, and then you can remove this part as well. Okay, and also for orders you don't need to make call directly. Okay, and this is already done. So now let us restart and then verify. Okay, I think it started. Now let us see end to end. So now the home page with products is displayed properly, and we are able to add the items, and then we are able to place the order. And if you go to orders, we can see orders as well. So everything is working fine. So this might look a little bit confusing because we have gone through a lot of code snippet and all, but as I said, it is fairly simple doing the same process for different screens. So we have a layout file where we are including all the common scripts like jQuery, Bootstrap and Alpine.js, and for each page we are including a specific JS file which performs make a call to backend API and then get the details and store it in the local variables here, and we are using these values in our templates. So it is as simple as that. There is nothing complicated. Just if you are not familiar with Alpine.js, you just need to take a look at it and it is easy to understand. And one more thing I wanted to demonstrate is how you can use HTTP client interface for implementing this REST client. Okay, and this is how you can configure your beans, okay, which Spring is going to dynamically generate the implementation. So without security, our front-end application is now working fine, and I think we don't need this in our layout file. If you go to see in the layout file, we have initialized this. We don't need it anymore, but for reference I'll leave it here. If you ever wanted to get any environment variable, you can use this expression to get that value in the JS itself. The last thing that is remained is Dockerizing this BookStore web app application. So here I'm going to add in the task file, we also need to build BookStore web app. Okay, so this is all we need here, and in our pipeline configuration, again we are going to add a new file, BookStore web app. So I'm going to paste it here and here and here. Okay, and also it is going to be BookStore web app. Okay, and one more thing we need to configure is in our apps.yml, we also need to configure that. So let me configure store web app. And here what configuration properties we have, I guess we only have for now only one. Let me quickly check it. So here this is the one we need to configure and pointing to the API gateway. So here if I let me take it and capitalize this underscore underscore and underscore, and it is going to be API hyphen gateway, and it is 8989. Okay, so that is all we need to pass, and here it is 8080. Let us map it to 8080. Okay, so this is fine now, and that's all we need. And finally, let us see whether we can run everything from the Docker itself or not. So I have stopped all the applications from IDE, and let us go to our terminal here, and I'm going to restart everything. So this is supposed to build all the services including BookStore web app and then start our application, and we should be able to access the web app also on localhost 8080. Now all the services are started. Let's go ahead and run this, and here we see the response, and we can navigate across products, and then we can add items to cart, and we can place the order here. So now let us go to orders, and here we can see it is delivered. So everything is working fine end to end when running all the services in the Docker Compose itself. So everything is working fine. So that's all for this video, and thanks for watching. And in the next video we are going to start adding OAuth based security for our application. In this video we are going to finally talk about how we can apply security using OAuth 2. So here as you have seen, we have implemented all these microservices, and then we have implemented API gateway and also implemented this BookStore web application. But so far we have not implemented any security. So this is where we are going to actually set up OAuth based security and then implement security for some of these services. So why some of these services? So here notification service is not going to be called directly from anywhere else. Only it is going to consume the messages from RabbitMQ and then process it. So we are not going to secure notification service. And catalog service is not providing any sensitive information or anything like that. It is only giving the API to return the catalog of products and all. So I don't see any benefit of applying security here. But if there are other services which needs to be protected, maybe we can apply the security as well. So here the only two things that we need to protect here is order service. Only authenticated users should be able to place an order and try to see their all the orders they placed, or they want to see their own order details. So almost every API in the order service should be protected. Every API in the sense anything related to orders. And similarly, from the BookStore web application point of view, again, we should be able to see the products without even logging into the application. We should be able to see products page and then navigate across multiple pages and all. We can do that. But if the user is trying to, we can even allow the users to add the products to their cart. And when they click on cart link to see their cart, or if they want to see the list of orders they placed, so then we would like to redirect the user to login page, and then only after logging in successfully, they should be able to either place the order or see their orders list or view a particular order details. So basically we are going to secure BookStore web application and order service. So these are the two things we are going to secure in our application. Before getting into the OAuth security implementation, first let us understand how different types of applications are usually secured. So let's talk about the first type of application. Traditionally, you have built a web application using things like Spring MVC and Thymeleaf, which is server rendered web application. So for securing that type of application, maybe you can simply implement all this authentication logic, like you have some users table in your database, and then when the user tries to log in, you compare the credentials with the stored information, and then you authenticate them. So it is a very simple and straightforward approach here. And once the user logged in, there are again different ways how you can store that this particular user is already authenticated. So traditionally, you can put the authentication status in the HTTP session itself, or you may the problem with putting this authenticated status in HTTP session, when you want to scale your application horizontally, like if you want to run multiple instances of this application, then you may have a load balancer and each request might go to a different server. So in that case, you may again go for HTTP session replication or some other techniques like always routing the same client to the same server node. So again, that there are some complications like that. Another approach, some time ago I see in some of the projects, how they implemented is like once the user is authenticated, and if the user is trying to put anything related to that user specific session, they store all that information in the database itself, and only the JSession ID or some GUID is created to associate with that session, and that is sent back to the client. So for every request, that is also going to be sent like a cookie or a header, and then it is going to identify that session information from the database itself. And it is a widely common practice, and there is a project called Spring Session. Okay, so here Spring Session is kind of trying to do the similar thing, where you can configure your where you want to store your HTTP session data. Like you can use Redis, you can use even SQL databases. So once you authenticate, HTTP this Spring Session helps you to automatically, whatever the data that you are trying to put in the session, that is going to be stored in the database itself. So the advantage is, even if you scale up your system horizontally, whenever somebody tries to look up a session data, that is going to check in the database itself, no matter which node the request is processing your request. So that is going to work just fine. You don't need to have this session replication or sticky session. So we don't need to handle all that things. So that is how you can implement security at the server rendered application level. It's a simple web application. And in the recent times, the trend is more like you have a separate single page application at the front end, and then your application backend is providing REST APIs, and your single page application is talking to this REST API. And this is how many applications built in the recent times. So here, how do we do that? Again, your server is going to handle most of the authentication things, like when the user tries to first log in, obviously you will show a login form or something in the single page application, and user provide their credentials and send a request to the server, and that compares the data with the existing user's information, and if it is successful, it will create a JWT token and send back it as a response. And on the client side, we usually store that either in a cookie or in a local storage somewhere. And from then onwards, for every request, API request you are making, you are going to include that as a authorization header or something like that. And each time it is going to take that authorization header and then extract the JWT token value, and then try to parse it and then verify whether this is a valid token or not. And then if it is successful, it will proceed to process the request. So this is if you are building a single page application having a backend REST API, this approach is sufficient. I mean, you don't need to go for OAuth. This itself is sufficient, but there is nothing preventing you. Even in this scenario, you can go ahead and implement OAuth based security, but this is sufficient. Like in Spring based application, you can use Spring security to create this JWT token, and then you can implement all this as I just described. But when it comes to microservices, things got a little bit more complex. Like you have a bunch of microservices, and you have an API gateway, and you might have more than one type of client. You might have some administration website built using a Spring MVC web application, and you might have client application, public facing client application, which you talk to these microservices through API gateway. So in this case, there is no one place which you can put your authentication logic, because there are so many microservices. So in this case, how typically authentication is handled is security. So we are going to use OAuth 2. In OAuth 2, there are multiple roles, like there is an authorization server, there is a client, and there is a resource server. So typically these are all considered as resource servers, our microservices, where the user's data actually resides. So these are all the resource servers. And this is a OAuth authorization server, which handles the authentication and validating the tokens and all is handled by this authorization server. And these are the client applications. So again, there are multiple types of client applications. This is like a Spring MVC server rendered application, where you can configure some secured keys and all in a secure way. So this is called a confidential client. But if you are building a single page application where everything, your HTML, your JavaScript, your styling, everything is available on the client side, and you cannot securely store your anything, keys or passwords or anything like that. So this is called a public client. So how do you secure your client applications is different based on the type of client. Okay, so typically the process is, when any of these client tries to log in, it is going to redirect to the login page provided by auth server, and once the authentication is successful, it is going to return two kinds of tokens, access token and ID token. Usually access token contains the token that is represents you are authenticated, and ID token contains the authenticated user's information, maybe what kind of a role they have, and their authorizations, and even the personal information, maybe email or any other details that you want to share. So ID token contains the authenticated user related information. Access token contains the token that is used for your authentication purposes. Okay. So once you send those details, access token and ID token, in some way they store in their client side in the sense, if it is web application Spring MVC based, as I mentioned, you can store it in HTTP session or in database somewhere. If it is a React or Angular type application, public client application, maybe you can store those tokens as cookies, secure cookies or something like that. So once you have this access token and ID token, from then onwards, whenever you make a backend API call, you also send that access token for each request as authorization header. And this OAuth security can be implemented in a very different ways. Like you can centralize all these authentication checks at the API gateway level. That is one approach. Or you can simply delegate that to microservices itself. So it can be handled at different ways. And here let's assume you are handling at API gateway. So in this way, what happens whenever you send a request, it is going to validate that authorization header token value by checking with auth server. But it can be like, you may think, so for every API call, it is going to make another call to authorization server and then first validate the token. That may be a performance hit, right? But it can be in a slightly different way. Instead of every time trying to call auth server for validating the token, they can get this public keys from the auth server, and then whenever you send a auth token, using those keys they can check and then see whether the token is valid or not, so that it doesn't have to make this REST API call to auth server for every API call. So it can be more performant. So that way you can validate this request and then forward the request to this downstream microservices. Or maybe you can simply forward the request to microservices, and the same thing can be happen here between microservice and auth server. Whenever it wants to check whether the given token is valid or not, it can download once the keys and then cache them and then use those keys to decrypt this token and then validate this. So that can be done at the microservice level also. So in our case, we are not going to implement this auth checks at the API gateway level. Instead, our microservices is going to validate that. Okay, and again, this is all in theory, but when you are using frameworks, many of these things automatically happens based on some configuration. You don't implement all these features like downloading the public keys and all. You don't explicitly implement that. The framework like Spring Security provides automatically. We just need to configure them in the proper way. That's all we need to do. Okay, so having talked about different ways, obviously we are going with this approach, and let us see how we can implement our API security into our BookStore application. Okay, security is itself a complex topic. On top of it, OAuth based security is even more complex topic. And this OAuth based security, it itself can be a completely different series in itself. So I'm not going to go in depth of how everything works together. Instead, I would recommend you to take a look at my blog post series. Like if you go to SivaLabs.in and if you click on this tutorials and Spring Boot tutorials, here there is a 10-part series on Spring Security OAuth 2. So here I have described how you can get started with OAuth security, first understanding different types of flows, and then finally we have implemented a sample application also by applying various things that we learned. So here there are multiple resource servers, there is an authorization server, there is a web client, and then we implement different flows. How do you authenticate, and then how do you make a call to one of the resource server, from one resource server to another resource server, how do you make a call. So in this series I have covered so many common use cases and how do you apply OAuth to base security. And I have used Spring Security OAuth support in Spring Security 6. So it is a relatively recent version we have used. And also I have used Keycloak as the OAuth 2 server. So I highly recommend you to, if you are new and you want to properly understand how OAuth 2 works, I strongly recommend you to first go through this series, because in our application it is relatively much simpler than what I covered in this series. Especially in this sample application, I have covered more use cases than what we have to implement in our application. So I highly recommend you to go through this series, and in each article I have explained with plenty of code examples how do you achieve certain things in a progressive manner. So you will find it very useful to not only just implement by simply configuring here and there. You will understand why we are doing certain thing, and progressively first do this step and then you achieve this, and then how do you achieve something else. So like that it is implemented in a very progressive manner. So I highly recommend you to go through this article series, and then if you continue with this video you will be able to easily follow along. Otherwise it's gonna kind of a bit looks complex. But again, as I said, OAuth 2 base security it itself is a little bit complex topic, and covering all that into this series is not the intention. So as there is a decent material here itself, I highly recommend you to go through it. But we are going to implement all the necessary things for securing our web application, and I am going to explain each step how we are doing that. But again, I am highly recommend you to go through this series. OAuth 2 is a standard security protocol, and there are many implementation of OAuth servers. Like Keycloak is a complete open source identity and access management solution which implements OAuth 2 protocol, and also there are other alternatives like Okta, Auth0. So there are many others. Similarly, you can also use same OAuth 2 and you can implement login with social accounts like sign in with Google, sign in with GitHub or Facebook. You can also follow in the same way, and you can leverage these public OAuth 2 providers also. So in our application we are going to use Keycloak, and though in theory you can switch from one provider to a different provider, like you can use Keycloak, and then if you want to switch to Okta, it should be doable. But again, as we are sticking with the OAuth 2 protocol, it shouldn't be like a big bang rewrite, but there will be minimal changes. How do you process some roles or things like that? But it is sticking with the protocols and standards. You will be able to switch to a different provider. Maybe during the development you want to use Keycloak, or for production you may want to go for Okta or Auth0, things like that. So I see in some of the companies this is a common pattern where they want to use Keycloak. And I mean, I am not saying Keycloak is not a production ready product. It is definitely being used in production in many companies, but for whatever reason this is very easy to use Keycloak for during development and testing and everything. And if you want to switch, you can switch. Okay, so in our application we are going to use Keycloak not only for testing, we are going to use this for our deployment purpose as well. So let's get started with Keycloak. So here in our infra.yaml I have configured the Keycloak. Here by the time I record this video, Keycloak newest version is 24.02, and we are starting the server in a dev mode, and we are customizing the port 9191. By default it's going to be 8080. I'm changing it to run on 9191, and also I'm exposing the same port on the host as well. And here we are configuring the default admin credentials as admin and admin1234. Okay, so now I have started this infrastructure. Here I ran task restart and all these containers are started. So here if I go to and see Keycloak is already started and it is running on port 9191. So let me go ahead and open this admin console, localhost 9191. I am logging in with admin and admin1234, and once I logged in, here you need to create, instead of creating whatever the services or clients, you should create your own realm first and then configure everything in that realm. So we are going to create a new realm called BookStore. So here, and I am enabling it and created this BookStore realm, and it is already selected here. So everything, what are the clients or users that we are going to create, everything will go into this BookStore realm. So now we are going to create our first client. I mean only the BookStore we are going to register, but here if you go to create client, and you need to more or less, most of the applications these days use OpenID Connect instead of SAML, and I am giving client ID as BookStore web application, BookStore-web app, and I am giving the name as BookStore. Next, and here let us I am assuming that you have gone through these tutorials, because most of the terminology that I am going to talk about here is based on the things that I already explained in this series. So please go through that series to get a good understanding of this. So here, client authentication. So what does this actually means? This defines the type of OIDC client. When it is on, the OIDC type is set to confidential access type. When it is off, it is set to public access type. So if we are building a single page application client, then we should leave it as off. But ours is a Spring MVC based server rendered application where you can configure the secrets. We should enable this one. So our BookStore web app is a confidential access type. And authorization is whether you want to enable our fine-grained authorization support, we can, but we don't need that. And authentication flow, this is the authorization code flow that we are going to use, so we need to enable this. And direct access grants is nothing but a resource owner password credentials grant. We are not going to use this, and this is actually kind of a deprecated, not recommended to anymore. And next, and here we need to configure these URLs, and our application is running, our BookStore web application is running on localhost 8080. So it is going to be localhost 8080. Home URL is also same, and valid redirect URL. So this is one thing maybe specific to your application framework that you are using. We are using Spring Security OAuth 2, and the default redirect URL is this one, your base URL /login/OAuth2/code/ and the client ID. Okay, this is the client ID. So this is what we are configuring as the redirect URL. And valid post logout redirect URL. So when you are logging out, to which URL you want to redirect the user to. So this is what we want to redirect to. And web origins, this is again for cars, and we are setting, this is where the request will come from. And make sure not even include an extra slash or something like that. Just having one extra slash or not having it also causes a lot of trouble. Okay, it is going to complain that it is invalid redirect URL and all those kind of things. So make sure you provide these values exactly the way I am explaining it here. Okay, and now save it. So now it is created, but if you go to credentials tab, you can see this is the client secret, and we can copy this somewhere, and we can configure the client ID and client secret, and then we should be able to log in using this Keycloak in our application once we configure. And before that, let us also go ahead and create a couple of users. I am creating a new user here, and I am enabling this email verified. If not, it is going to try to send email and you need to verify that. So I am just enabling this, and username is Siva and email is siva@gmail.com. I am simply giving some dummy values here, and siva. So I'm creating first user, and but you need to go into these credentials and specifically set the password. I'm going to give siva1234. Okay, and okay, and by default it is temporary on. If you leave it, once you log in with these credentials, you should be you need to change the credentials, but I don't want to do that, so I'm turning off this temporary and saving it. Okay, now we have our first user. Let me go ahead and create another user. So with the name Prasad, prasad@gmail.com. First name Prasad, last name Sen. Okay, and create. Again, go into credentials and set a password as Prasad1234. Turning off the temporary flag and set. So now I have a client, BookStore web app client configured, and I have a couple of users created. So why it is okay, it is not verified. It says let me change it. So it is verified now. So now we have this configuration. But the problem is, let's say we configured our Keycloak server with the default settings, and then once we log in, we set up this client and users and everything manually. What happens if by mistake I delete Keycloak container? When I restart, I need to again go ahead and configure everything one more time. So instead, there is a mechanism where you can export this realm configuration and include this realm configuration file while bootstrapping your Keycloak container itself, so that even if you delete this, and then you should be able to simply restart with that realm export configuration file, and these will be automatically configured. Okay, so here in this blog post, in the part 6 microservices sample project setup, I have these steps how you can export your current realm configuration into a JSON file. So how we can do this? First, I am going to run this docker ps to check the Keycloak container ID. So I am going to go here, and here I am running docker ps. So here this is the Keycloak container ID, and next I need to run docker exec it and run the bash shell within this container. So I am going to do that, docker exec it. So this is the container. Now I am inside the container now. Okay, now what I need to execute, there is a script called kc.sh inside the Keycloak container, and I am exporting this into this directory, and I am specifying what is the realm I want to export. So in this article I mentioned SivaLabs, but ours is BookStore, and here I am saying include the users configuration also and create the realm file. So I'm going to copy this and go into here, and here I need to change, instead of SivaLabs it should be BookStore, the realm name. Okay, so now when I run that, it is going to export the configuration, like we have our BookStore web app client, and then we have created a couple of users. So all that configuration is already there in this exported file. So now we need to exit from the container, and from the host machine we need to run this one. So here I am going to run, this is not SivaLabs realm, this is going to be BookStore realm. And also when we created inside the container, it is BookStore realm JSON, and also here I need to specify the container ID. So here I need to give this ID. Now when I run that, docker cp command not found. No, I am still inside this container. So first I am going to exit this, and then I am going to run this command here. No, let me copy this command. So I ran that while I was inside the container itself. So now I am on the host. So it is successfully copied this into BookStore realm JSON file. Okay, now I am going to copy that file and put it in our repository. So here I have copied that BookStore realm JSON file that we exported and put it in the inside the Docker compose. I have created realm config, and inside that I have this JSON file. And in the Keycloak configuration, I have also enabled this flag as realm import, which is going to automatically import all the JSON files that are there inside this directory. And we are mapping our realm config folder to be this directory inside the container. So when we start the Keycloak container, it is going to run all the import all the realm configurations from this location. Okay, so now let us go ahead and delete all these containers. So I'm going to delete all of them, and now I'm going to restart the infrastructure now. Okay, now with this, next time when I log in into our Keycloak administration website, it should already contain the BookStore realm and also be there BookStore WebApp client and then our users as well. Okay, let's go ahead and see whether these services are up or not. So most of the services are running. Now I go ahead and open localhost 9191. And here I am going to log in with admin1234, and here I can see BookStore realm already, and if I go to clients I can see BookStore WebApp. Okay, and if I go to users, yes, there are 2 users. So with this configuration, even if you delete or even for testing purpose, you have the infrastructure in place to automatically spin up with all the pre-configured setup. Okay, so next we are going to configure our BookStore web application and talk to this Keycloak service as a authentication provider and implement authentication. Okay, I have already made the changes to secure our BookStore web application. I will walk you through what are all the changes that I have done. So first, let us start with the pom.xml dependency updates. So we are adding this Thymeleaf Spring security extras. So we can use some Thymeleaf security tag leaves to secure some parts of the information only to display when the user is authenticated, things like that. So we have this, and we have added Spring Boot Starter security, and also we have added Spring Boot Starter OAuth to client. So our BookStore web application is a client, so we have added this starter, and also I have added this Spring security test. So this is for providing some testing capabilities to automate. Okay, so these are the dependencies we just need to add for securing our web application based on our Spring Boot MVC based application. If it is a single page application, you have to follow obviously a different approach, but this is how we can secure our web application. Once I have added this, I need to configure our application, what is the OAuth server and what is the realm and everything. Okay, so here, in order to avoid repeating some common things, I have created a couple of variables here. OAuth to server URL. So our Keycloak server is running on port 9191. So first I created this variable, and then we are going to reference our realm URL in some places. So again, I created a variable where it is going to be this base URL / realms / bookstore. So our realm name is bookstore. So that is the variable we have configured here. Next, here we are registering the client and we are giving a name. This is the made up name. It can be anything. It can be simple bookstore or it can be bookstore web application. So it can be anything. But the client ID is what we have given while creating this client. Here we created bookstore web app, right? So this is the client ID. Okay, this is the client ID. So we need to give same here. And so for all this specific client, we are giving the same logical name here, registration name. So we are using the same bookstore web app, and we are also specifying the client secret. So remember when we configure, we set this is a secured confidential access type, right? So this is why we can configure our secrets without exposing it to public, right? That's why we created it as a confidential client. So here, if you go to credentials, you can take this value, copy it, and you can paste it here. Okay. Now authorization code grant type, there are a list of possible values, authorization code, client credentials, things like that. So ours is authorization code, and the scopes is OpenID and profile. And redirect URI, again what we configured in here. If you go to settings, redirect URL, we configured it to be localhost 8080/login OAuth to code bookstore web app, right? So I am giving the same here. So we don't need to give actual localhost 8080 based on port we are giving. Instead, you can replace that with this placeholder, and our application Spring is going to take care of replacing this with actual host name and the port number this application is running. This, in the sense, bookstore web application. So the rest of the thing we have entered just the way we provided this URL. Okay, and this is where we are configuring provider. We can configure multiple providers, but in our case we are only configuring Keycloak server. But here you can specify provider.google and then provide Google configuration parameters, GitHub and GitHub parameters, and you will be able to choose which one you want to log in with. But here in our application we are only using Keycloak issuer. So this issuer is nothing but the realm URL. So this is the realm URL, localhost 9191/realms/bookstores. That is what. Usually we need to configure a few more things also, authorization URI, token URI, JWT, set URI, user info URI. So if we want to provide values, we can do that like this, we can configure. But if you go to our this realm URL, right, localhost 9191 realms/bookstore, if you go to here, if you click on this realm settings, and there is a endpoints section under which we have OpenID endpoint configuration. So if you click on this, if you take a look at localhost 9191 realms/bookstore, after that there is a well-known OpenID configuration. So this is a standard API endpoint available for all the OAuth supported servers, and our server is going to make a call to this and then try to figure out if you don't provide any of these configuration parameters, any of these authorization URI, token URI, JWT, set URI, all this, it is going to make a call to this API endpoint, and here it can get all the details: authorization endpoint, token endpoint, user info endpoint. So whatever the missing details it needs, it can get from this API endpoint. So that is why we don't need to configure rest of these things. We just need to set issuer URI. Okay, that is enough. So with this, our application is secured, which means with simple these changes alone, if you try to start your application and try to access localhost 8080, it is going to redirect you to the login page. By default, when you add Spring Security, it is going to lock down all the URLs and secure all the API endpoints and URLs. But we don't want to lock down everything. We want to allow users to browse through the catalog and be able to see the products without having to log in first. So we are configuring that customization. So under BookStore web app, I have created a config package under which I have security configuration. So here I am adding this enable web security, and it's a Spring configuration class. And for now, let us keep it this. We'll talk about it later. And we are going to customize our security filter chain. In Spring Security 6 onwards, this is the way you can customize the security configuration. Earlier, you might have seen extending some Spring Security adapter or something like that. But now you need to register this security filter chain pin, and you can customize various aspects of it. So here what we are doing, we are authorize HTTP request and then customizing all these URL patterns like any JS files, any CSS images, and any error page request, WebJar request, or Actuator endpoints, and mainly /products and /API products endpoint. They are supposed to be available public. They don't need authentication. So we listed all these public URLs and then specifying permit all. You don't need security in order to access these API URL patterns, and then any other request should be authenticated. Okay, and that is it. And for now we are simply disabling CARs and CSRF. Again, these are very important things to keep in mind. Simply disabling is not a good thing for production, but again these things are itself some complex topics that takes a lot of time to describe. As I mentioned, OAuth 2 or even security it itself is a big concept if you want to go in depth. But right now I am going to simply disable this, but this is not a good pattern for production grade. Maybe in some other series we may talk about CARs and CSRF in depth. Okay, so next, OAuth 2 login. We are just going with the defaults, and then logout. Here we are customizing how logout should happen. So here what we are doing, we are saying clear the authentication. So once the user is authenticated, the security context is stored with the authentication information, and it might use HTTP session. So here we are cleaning all that state, login state, and also we are customizing how to handle the logout success handler. So when you click on the logout URL, it is going to clear all this HTTP session and authentication, and also handle what to do next. So here we are customizing how to handle this. Here again we are implementing a customized logout success handler, and we are saying to redirect to the base URL. Again, do you remember we have the same base URL used in here also, which is going to take the current URL base URL like HTTP localhost 8080, right? So it is going to take that. Where it should match? It should match what we have configured in our Keycloak. Here, if you go to clients and BookStore web app, we specified valid post logout redirect URIs. So here we mentioned HTTP localhost 8080, and this is what it is going to represent. This is where many people do a small mistake and then struggle. If you simply put a slash here, and then if you don't include slash here, it is going to say invalid redirect URI, and then it causes a lot of problems. So make sure that what you are entered here is exactly same what you are providing here. Okay, so with this configuration we are good to go. And what additional changes we have done, if we go to our templates, especially layout template, here we have included this security related tag handler here. Okay, so here we can use, earlier we have simply displayed orders link directly, even without users logging in. They should be able to see the orders link and then click on it. Now we use this security : authorize and specify is authenticated. So only users who already logged in can only see this one. I mean, this tag is not going to be rendered if the current user is not already logged in. Okay, so similarly I have created a couple of links. One is for security : authorize not is authenticated. If it is not authenticated, we are showing this login link, and again it is going into OAuth to authorization BookStore. This is the login link for our provider. So here we have configured this, right? BookStore web app. So we are giving that. And then logout is at the default URL is /logout, and we are going to show this only if user is authenticated. So these are the customizations we have done. Okay, so with this, now let us go ahead and let me check once again. Here we have all the backend infra services running fine. Now I am going to first start catalog service. Then I am going to start API gateway and maybe start order service as well. Okay, so all these three are running. Now I am going to start web application as well. So once all the 4 services are up and running, we can go ahead and check localhost 8080. Now we are able to see the products and everything, and I can even add products to the cart. And here if you see, as I have not yet logged in, it is showing the login page, but I have not protected this cart page. If you see our security configuration, I have not protected cart page. That means I should log in order to see the cart page. So now here if I click on cart, it is redirecting me to the Keycloak's login page. Here I need to use my user credentials, Siva1234, and I am logging in. Okay, so now I am able to navigate. Now after I log in, I can see the orders link as well. Earlier I was not able to see, and also login link is gone, and now it is showing logout. So now if I go to cart and I place an order, it is creating successfully. Now I can see the orders as well, and I can see the details as well. So everything is fine. Now if I take cart link and then I log out, and even if I try to directly go to cart page, it is going to redirect to login page. And again this time let me log in with Prasad, the second user, Prasad1234, and cart is empty. Now I can continue shopping, add a couple of products, and go to cart and place order here. Okay, now if I go to orders, now I am seeing 2. The first one, I think this is placed by user Siva, but this is placed by Prasad user. But still I have not implemented the logic to actually take who is the current logged in user and use that to create the order, right? So currently we are still seeing all the orders placed by all the users. So but we have protected our web application with the login successfully. Okay, so this is a good start. Next we are going to see how we can get the current login username, and then we can use that while placing the order and pass that order information. Pass that the current logged in user information. From the BookStore web app point of view, the next thing we need to tackle is while creating the orders, we need to take the current user's access token and then send it as a authorization header to our downstream services like order service. Okay, so how do we get the current logged in user's access token? So here inside services package, I have created a class called security helper. And here what I'm doing, so when we add OAuth to security, it is automatically configure this OAuth to authorized client service. So we are injecting that, and we have a method called get access token. So in that, what we are doing, so if you are familiar with Spring Security, we have this security context holder .get context and get authentication. So usually if you are implementing a simple JWT based authentication or even a plain server rendered typical web application security, you might know this is a kind of a represents username and password authentication token. But here we are using OAuth based security, right? So this, once we successfully authenticate with the OAuth 2 provider, the implementation of this object is not username and password authentication token. Instead, it is OAuth 2 authentication token. So when first we get the authentication, and then we are checking is it an instance of OAuth 2 authentication token, and we are giving a alias name here. And if it is not true, we are simply returning null. But if it is a OAuth 2 based authentication token, what we are doing, we are loading the current authenticated client information from authorized client service and specify, so current OAuth 2 token, who is the registration ID, and this is nothing but BookStore web app, and we are giving the OAuth 2 token name. So based on these two, it is going to return the current authorized client information. So here it contains all the information like access token, ID token, and all other details. So here we are first taking access token and get token value. So this is how you can obtain the current logged in user's access token. Okay, so we have this method here which is going to return the current logged in user's access token. Now how we are going to use this? So earlier we have created these clients, and under orders package we have this order service client. Earlier we have not specified any of the headers. Earlier we have simply create order and then take create order request object as the request body. Now for all the API endpoints for order service client, we have added this request header annotation and pass a map of string comma anything as the headers. So you can pass one or more headers to this API endpoints, and they are going to be sent as the headers because we have added this at request header. Okay, so this is going to be request body, and whatever the map that you are passing will be passed down as a header. Okay, we have added these headers for all the methods in this order service client. Fine, but how are we passing those? So here I have injected this in the order controller. I have injected this security helper, and then let's take the scenario of create order. So here, while creating this order, first I am getting the token value from this security helper, and I am creating the headers map of authorization is the name, header name, and we are using this bearer JWT token, so we need to prefix it with bearer space and then add the token and then pass those headers for each method. So this is what we are doing whenever we are calling any method on this order service client. So here also same thing, we are getting the headers and then we are passing them. So we are doing the same thing. So what happens from our BookStore web app point of view, we are authenticating the user, and we are getting the current user's token, access token, and for calling any secured downstream service endpoints, we are passing this header, authorization header. Now it is the responsibility of the order service to also have the security configured and then validate the incoming authorization header and everything. From the BookStore web app point of view, we have done all the changes that are required. Okay, now let us go ahead and see what we need to do to secure our order service using OAuth 2 security. Now let us go ahead and see how we can secure our order service using OAuth 2 security. So first let us start with our pom.xml configuration. So here I have added this security starter and OAuth 2 resource server starter, because our order service is a resource server and we are going to protect this using JWT token based authentication. So we have added OAuth 2 resource server starter here and also security. Okay, so having these two dependencies added, and we also want to customize the default security. As I already mentioned, when you simply add security, it is going to lock down all the API endpoints, but we want to customize some of the API endpoints to be allowed, some of them to be permitted. So here again, in the similar way, we are configuring all the Actuator endpoints are allowed. Here we are calling permit all, and also the Swagger documentation, OpenAPI documentation URLs are also configured to permit by everyone. So in order to call any of these API endpoints, you don't need to be authenticated, and any other request should be authenticated. That means you can only call any of the order related create order or get order details. So those API endpoints can be invoked only by authenticated users only. And then we are configuring, because this is going to be a stateless REST API, we are configuring this session policy as stateless. And again, we are disabling this CORS and CSRF, not a good thing, but as I said, we may discuss this in more detail in some other video. And finally, we are configuring, this is a OAuth 2 resource server, and then we are enabling the JWT token based authentication with the default customizations. Okay, so this is the security configuration we have. But again, next, the thing that is remained is, when somebody is calling these API endpoints, we have implemented API endpoints to get the current logged in user information and then use that while creating the order details. So we have that class in security service, right? So earlier in this get login username, we used to simply return a static variable user, a static string user. But now we are going to update this with the actual logic of who is the actual logged in user. So here the Spring security and OAuth security is going to take care of performing all the authentication. And if how do we verify the authentication? It is going to check the authorization header and take that bearer token, and also going to verify with the authorization server whether this is a valid token or not. And then if it is a valid token, it is going to let the controller flow goes through the controller. Otherwise, it is going to reject with 401. So assuming you have provided a valid authorization header, and then it come down to this logic. And here earlier again we have talked about security context, get authentication. Normally it is going to return username and password token authentication or something. But in the web application, we have seen that is going to be OAuth 2 user token or something. But here it is a resource server, and this is going to be of type JWT authentication token. So we have cast that into this, and then we are taking the current principal is nothing but the JWT. And from the JWT, we can extract many details like what are the preferred username, email, and what is the name, and even you can get the current access token value and what are the authorities are there. So all this information you can fetch from this JWT. But we are simply using the preferred username, and we are going to use that name to store all the wherever we are calling this get login username while creating a new order or while fetching the order details. Everywhere we are going to use that current logged in username. Okay, so these are all the changes that are required for order service also. So now with this Okay, so we have forgot the key configuration in our application properties. So we have configured all that, but how does order service know that it needs to validate the authentication bearer token that is getting as the header to validate against, right? So this is where we configured OAuth 2 configuration. Again, we take some variables to predefine what is the root URL of the OAuth server, Keycloak server, and what is the realm URL. And here we simply need to specify who is the JWT issuer URL. So this is nothing but the realm URL. So here you don't need to again register who is the client and all these details, because it is a resource server and all it has to do is take the incoming authorization token and then check with the issuer, whoever is issuing the token. It just need to verify with that one. It is not going to create a new token, right? So it doesn't need all other configuration parameters. Here you just need to configure the issuer information. This is sufficient. Okay, so with this configuration, now we are good to start. Let us restart. What are the applications we need to restart? First, let us restart the order service, and then let us restart our BookStore web application as well. Okay, so these are the two things I think we need to restart. Now let us go ahead and let's log out first, and then now let me add a couple of products. Now I want to log in here, so I will log in with Prasad. 1 2 3 4, and I am placing the order. Okay, one order is created. Now if I click on orders, I am going to see only one order, because earlier also we have created a few orders, but they were stored. Let us go ahead and see if we have this database. Okay, not there. Let us connect to PostgreSQL orders DB. So here orders DB, and it is going to be 25432, and it is Postgres. So I am trying to connect to the orders PostgreSQL database here, and I have connected. Now if I go to orders, here I can see earlier without applying this security we have created couple of orders. So for them username is stored as user. Now we have logged in with the user credentials of Prasad, and we can see this order is placed by username Prasad. So that's why when we see orders, when we try to see the orders, it is going to get all the orders where username equals to Prasad. Now let's log out and log in again using Siva this time. Siva user, Siva 1234, and I can place an order. Okay, now if I go to check in the database, let me refresh. So a new order is placed. This time username is Siva. So this is how we are able to store who placed the order by taking the current login username from this security service. Here we get the current authentication token from the context, and then we extract the JWT, and from JWT we extracted preferred username, something like that. Maybe if you want to store email, you can store that. So basically you can extract various pieces of information from this JWT and use it, whatever is unique. Okay, so this is how we can secure our application. But now that our application is secure and we are able to place orders only after we log in, and then when we log in we can only see the orders that we placed. We cannot see somebody else's orders. Okay, so we are secured, we are securing this web store, fine. But now with this security applied, many other things might have got broken. For example, our tests. So our tests were written assuming there is no authentication in place. So now if we try to run this test, it is going to fail. Okay, so here you can see it is going to throw 401 or something like that. So all the things are failed. Here you can see it is giving 401 error, right? So now we need to fix tests, and also we need to fix our Swagger documentation, right? If you go to localhost 8989, which is our API gateway, and now catalog is working fine, but if you try to see here, and here if you try to place an order, you can't, right? Because you need to pass the authentication token. Without that, it is going to fail anyway. Okay, so we need to configure some way to enable login inside this Swagger documentation and still be able to use this API endpoints. So that's what we are going to look at next. The integration tests are failing because our order service APIs are expecting valid JWT token as authorization header. But right now we do not have a provision to create a valid authorization header with a valid JWT token. So how do we solve this problem? So there are two different approaches where which one is better or which one you want to go with depends on which trade-offs you want to make. Okay, so one approach would be to be able to spin up a Keycloak in a Docker container and configure it in an automated way and hit a API endpoint and get the token, valid token, and use that to make the auto service API call. That is one approach. Another approach is there is a Spring security test support where you can customize it to generate mock OAuth 2 token and use that while making the API call using mock MVC. These are two different approaches. Let us start with the Keycloak container approach. So here there is a project called Testcontainers Keycloak. We have already been using test containers for tests and running application locally. So we can use Keycloak test container to spin up a Keycloak container. We already exported one Keycloak realm file. We can use that, and then we can spin up this instance and make an API call and get the token. But for our actual application, we have enabled only standard flow. Right? While creating this BookStore web app client, we have enabled only standard flow. But in order to make a call and get the token, instead of going through the standard authorization code flow, I have enabled this direct access grant, which is nothing but a resource owner password credentials grant. And I have enabled that and then saved it. And using the same steps we have done, I have followed the same steps and created test realm file. With this enabled, with direct access grants enabled, and I took that realm file and under src test resources I have copied this test bookstore realm JSON file. Now what I am doing here in our containers configuration file, I have put some constants here like what is the Keycloak image and what is the realm file path and what is the realm name. And here I have created a container bean because Spring Boot out of the box supports service connection support for Postgres and RabbitMQ. We can directly add this at service connection, but it doesn't have out of the box service connection support for Keycloak container. When you want to use any container which doesn't have out of the box service connection support, still you can use any of the container like this. You create a method which returns a container and mark it as a bean and provide this dynamic property registry as a argument to this method, and you can start the Keycloak container and then you can register the properties whichever you want to provide and return the container. So it is going to start this container and register these properties, customized properties. So what we are doing here, we are creating a container using this image, and we are also specifying to import this realm file, and we are adding this Spring Security OAuth Resource Server Issuer URI to this one. We are dynamically getting the authorization server URL realms/bookstore what we have configured. So we are dynamically changing this path which we have configured in our application properties file. So here we have configured this one, right? So we need to change dynamically to the container URL that we are starting with this one. So that's what we are doing here. So now that when we run our integration test, this is going to start this container and this property is configured to this dynamic container. Then how are we going to get a valid token? Now let us go to this abstract IT, which is the base class for all the integration tests, right? So here I have configured a few standard properties that we have used in our BookStore web app client registration. I have client ID, client secret, and username and password. Okay. So, and then I have this OAuth to resource server properties auto-void in this. Now at the end, I have added a method called getToken. So here what I am doing, I am using REST template, and then I am submitting a form, and I have put all these properties in a map, multi-value map. So what is the grant type I am using? I am using password grant type. That is why I have enabled this direct access grants, which is nothing but resource owner password credentials grant. Okay, so I am using that grant type, and I specify client ID, client secret, and username and password. Okay, and finally I am getting the token URL. To get the token, this is the URL I need to post the request to, and I am using header with all these headers and map. Finally making a call to using REST template to this authorization server URL by passing this request, and I am expecting the response to be in this Keycloak token format. That is nothing but a simple record here which contains access token. Okay, so it is going to make a request to the Keycloak container and then return this Keycloak token as a response which contains the access token. Okay, so this way I am making a request to the Keycloak container and getting the token, valid token. So I have this as a protected method. Now if I go to order controller test, before making any requests, so here I am adding a header with authorization as the header name, and adding this bearer space as a prefix, and then calling this get token. So for every API call that I am making, I am including this header like this, so that before making any API call, it is going to get a token and then include that as a authorization header. Okay, so that is how I am able to make the calls. So now if I run this, it is going to run fine, because it is able to get a valid token and then pass it as authorization header. So that is working fine. Then what is the problem with this approach? The problem with this approach is, in the production we are using standard flow, but for testing we are using this password credentials grant. It is a shortcut that we are taking to get the valid token, but we are assuming that it is going to work fine. But the benefit is we are actually making a call to Keycloak server, and we are validating our configuration if there is any security configuration and everything. It is making all that into consideration, and then we are making the calls. But only thing is, instead of standard flow, we are using password grant and then getting the token. That is the downside. And what is the alternative? So the alternative is, before that, let me show you the POM configuration here. I have added this Spring security test because we are adding this OAuth support, right? So I have added this one. For Keycloak support, I have added this Testcontainers Keycloak dependency. Okay, so I got the details from this. Okay, so you can use this container like this. So the other alternative is, you might have seen using with mock test or something like that. Let's say if you are running any tests, you might have seen using it with mock user, something like that, right? So what it will do, it will create a security context authentication object based on some mock values. But this works fine if you are using typical username and password based authentication. But we are not using username and password based authentication. Instead, we are using OAuth based authentication, right? So this is not going to work. So for that, what we have done, I have created a annotation called with mock OAuth to user, and I provide some customization properties here using a default role and default username and value like that. And here I have mentioned with security context factory equals to this class. So mock OAuth to user context factory. So this is the class I have created here, which implements this with security context factory, and this is the annotation that we have created. So in order to implement this, we need to implement this create security context and with the same annotation as the input here. And here we are extracting various data from this annotation attributes, like we are extracting username, and if it is not there, we are throwing exception. We are also taking the authorities from the annotation roles, and then we are adding them as authorities. And also we are preparing some predefined claims like a preferred username equals to the configured username, and we are adding some static user ID and realm access as authorities. So things like that. And then finally we are creating a JWT object with some mock token value, and then created time, like issued time, something like that, expired time, all this, and headers and claims. So basically we are all preparing a JWT authentication token, mock token value, and then setting that inside this security context folder. That's what we are doing in this. So once we have created this annotation and this security context factory, how we can do? So instead of using rest assured, here I have created another class getOrderTest, which is still extending abstract ID. But I made some changes to this abstract ID where I enabled this mock MVC auto configuration by adding this annotation here, and also I have auto-wired this mock MVC. Okay, so once I did this, I have created a test by adding with mock OAuth to user and giving any username here, and I am making a call to this get all the orders. Okay, so here if I run this, it is going to put the OAuth user, mock user that we are creating in the factory into the security context, and then proceeding to this API endpoint. Okay, so the test is successful. But for this, we don't need to run the Keycloak container and all that, get token method and all that. But we are simply using mock MVC instead of making a real API call using rest assured. But why we can go with this approach? The reason being, actually for testing that order placing and all after logging in, this looks more like a end-to-end test, which you can automate using Cypress or Selenium, something like that. So if you want to delegate this instead of mocking or something like that, maybe you can go ahead and use end-to-end test for this, for testing these flows, and only use mock MVC to mock the OAuth and then test API level logic. Okay, so these are two different approaches where you can use mock MVC and then set this context, security context with a mock OAuth token. Or you can spin up Keycloak container by enabling that password token, password grant, and then making an API call to get the token and use the token. So these are the two approaches. I'm going to leave the code with the two approaches. Whichever you want to go with, you can go with that approach. In addition to this integration test, there is also one unit test that we have written here, and this is a WebMVC slice test. And what earlier we have not added this with mock user. Now we need to add this with mock user, and also we need to add this dot with CSRF, because we are making a post request. We want to get through the CSRF process, so we can add this with CSRF to enable CSRF support with mock MVC, and we are setting a mock user in the context. So now we can run this unit test as well. Okay, so it's working fine. So these are two ways you can unit test and integration test your APIs that are secured with OAuth 2. Things seems to be working fine, but there is a surprise, like if you are trying to run all the services within the Docker containers, then there will be some issues. So let's see what happens if you run all the services in the Docker containers itself. Earlier we have run infrastructure only in the Docker containers, and all the services, microservices, we have started from our IDE on the host machine itself. So now I am going to configure based on this OAuth security implementation. We need to add some properties, like in the order service we need to add OAuth 2 server URL. So I am giving it. So here in the OAuth server, we need to configure this value. Right now in the local, we have configured it to localhost 9191. But when you are running inside Docker containers, this should be the host name of the Keycloak, which is host Keycloak. So we are configuring this way, and similarly we need to add that property for our web application as well. So here we also add this here. So with this configuration, I have started all the services in the Docker containers. Now if I go to localhost 8080, and this is working fine here. Now I'm able to see the products, but let's say I want to go to login page. So now it is going to redirect to Keycloak 9191, but my host doesn't know what is the host Keycloak means, right? Because we have configured that Keycloak 9191 as the authorization server, and it is going to redirect to this Keycloak. And we can think, what if we can just give the name localhost? But localhost again means from our host it is going to resolve properly, because we have mapped the 9191 to Keycloak server. But again the hosts are different, and it is going to fail in the down the line. So one thing what we can do, we can configure our host file. Like here, if you go to cat etc hosts, earlier we have configured catalog service, right? Similarly, we can configure Keycloak also, mapping to the local host. So let us do that. So here I am going to map Keycloak host name to the localhost 127.0.0.1. Okay, so with this, now let us go back to our application, and here let us try to log in. Now it is going to Keycloak server. Okay, so this is working fine. And similarly, you may also have to map the other services when we are trying to use Swagger documentation, like we have seen already. Okay, so this is how you can configure. Now what is remaining is we need to adjust the Swagger documentation to be able to authenticate ourselves, and then we should be able to call order service API endpoints. So let us take a look at how we can do that. So far, our Swagger API documentation is generated with the default settings. We have not customized anything. But for our orders Swagger documentation, now that we have implemented API security using OAuth 2, we need to customize it so that users can authenticate themselves and then invoke the API endpoints. For that, we can provide a customized open API bin, and then we can provide the security requirements and then add the security schema as OAuth 2. So users can be able to log in from the Swagger documentation itself. So what we are doing here, so we are injecting this issuer URI, which is already configured in our application properties. So here, this is the property we are trying to obtain. So this value is nothing but realm URL. Okay, so once we have that one, we are also configuring API gateway URL. Instead of directly invoking the order service, we are invoking through Swagger documentation. So here what we are doing, we are providing some basic information about our API, and then as a server, we are adding this API gateway URL instead of directly using order service itself. So we'll see where this is going to affect in the Swagger documentation. And the most important part is adding this security item, and we are adding it as a authorization requirement here. And the component is here we are adding the security schemes with the name security_auth. And here we are adding that this is of type OAuth 2, and we are specifying which flows we want to use. And here we are saying we want to use authorization code grant type. And for that we are specifying where is the authorization URL, what is the token URL and all. And again, this is the base URI we already got. And this is the part we are appending, which is used as the authorization URL. Similarly, token URL also. And we are specifying scopes as OpenID and OpenID scope. So with this customization, and what is the API gateway URL we are configuring? So if we go to Swagger documentation, so this is what we are going to use as API gateway for order service, right? API gateway is running on 8989, and whatever starts with orders is going to be forwarded to order service. So we are configuring this URL here, and we are using this key and bind this value to this variable and added these servers like this. Once we have added this OpenAPI bean configuration with this security scheme, we also need to specify on which controller API endpoints we need to enable this so that we can pass this token along with the request. So here in all the for all the methods that are defined in this controller, I want to include that. So I have added this add security requirement name equals to security auth. So that name is nothing but what is the key we configured here. So here for all the endpoints, I want to use this JWT token. That's why I mentioned at the class level. But if you want to only apply that for a specific endpoints, you can put that on the handler methods itself instead of on the class level. Okay. So with this configuration, when I restart all the services, both infra services and our microservices in Docker, now I am seeing this documentation like this. Now if I go to orders, and now this is the button that is appearing with our customization. Now also if you take a look at our catalog, it is showing it as a generated URL like HTTP catalog service. So this is the default service name we have, that is why it is showing like this. And if you take a look at orders, we have explicitly added this API gateway URL, so that is why it is showing it like this. Now how I can authorize myself? Now if I click on it, I want to provide this client ID BookStore WebApp and client secret, which is already we have configured in our order service. In our BookStore service, BookStore WebApp, we have our client secret, right? So we want to use that and select this, authorize it. Now we are getting this invalid parameter. Why? If we take a look at this request here, it is mentioned redirect URI equals to http localhost 8989/webjars/swagger UI like that. So basically if we take a look at our WebApp configuration, we have configured valid redirect URL equals to only this one. If we try to pass any other URL, it is going to fail like this. So we are going to add this another URL that is requested here as additional valid redirect URL. Okay, so this is the one that is being requested through this URL. http localhost 8989 webjars swagger UI /OAuth to redirect.html. That is the URL that is being requested here. So I am adding this and saving it. Okay, now with this, if I restart, now it is properly rendering this sign in form. Now I am going to use my credentials and login. But still it is going to throw this error. The reason being, if I open the dev tools, here you can see access to this Keycloak URL from localhost 8989 is blocked because of the CORS policy. So if you go to Keycloak again and if you check the web origins, so right now we only configured the request to Keycloak will be coming from only 8080, localhost 8080, but we are making calls from localhost 8989 as well. Okay, so that's why I am adding this 8989 also and saving it. Now if I go and try to close it, restart, refresh it and try to authenticate myself again using client ID and client secret, this time it is successful and it got the access code. Now if you go and try to check here, execute, here you can see it is making the request to through API gateway, and here you can also see it is already including this access token. So here if you notice, now we are getting this CORS error. Why? Because from our host, API gateway is not a valid host. So let us change that. So here I am going to add so here I am going to enable this 127.0.0.1 for API gateway host name. Okay. Now let me refresh it once and authorize myself again. Okay. Now if I try this, so I got the empty response because it is authenticated successfully and I am passing this JWT token as a authorization header. I am getting the response, but there are no orders yet. Okay, so finally we have applied OAuth 2 based security for our microservices based application. We have secured order service and BookStore web application, and also we have customized Swagger documentation so that users can authenticate themselves and then invoke the secured API endpoints. And we have also seen how to write integration tests and unit tests for secured API endpoints also. We have built our BookStore application by following microservices architecture, and all the things are working together just fine. But in order to run the application in production environment, we need to take more things into consideration. For example, if some things are going wrong, how quickly the dev team or the support team get notified, how quickly they can take a look at it and then figure out what is going wrong, and how quickly they can fix the issue. So these are the very important things in order to run the application in production, because your customers will be using your system, and if things are going wrong frequently or you are not able to understand what is going wrong, it will be a nightmare to support this system. So we are going to take a look at what are the things that we need to look into it in order to make the system more observable and maintainable. Spring Boot provides a lot of capabilities to support this observability. For example, when we talk about observability, some of the primary things that we need to look into is how do we log our application flows, and how do we capture the metrics, and how do we capture the traces. So all this information we need to capture and then be able to observe the system, how it is functioning, or is there any abnormal behaviors, and all these things we should be able to observe it. So in this video we are going to use various technologies like Grafana, Prometheus, Loki and Tempo to capture all this observable data and then see how we can monitor our application in a easier to manage way. Okay, let's get started. Spring Boot already provides various monitoring capabilities via its Actuator. So Spring Boot Actuator provides various API endpoints that you can use to observe what your application consists of. Like you can see what are all the beans that are already configured in your application. You can see what are all the loggers that are currently initialized for your application. And there are a lot of Actuator API endpoints that you can use to know more about the application that is currently running. So behind the scenes, Spring Boot Actuator uses a library called Micrometer. This Micrometer, you can think of it as a facade for various backend systems like SLFRJ for loggers. So once you capture various metrics from your application, you can use Actuator and then you can plug it to various backend systems. If you go to this metrics section, here you can see once you capture the metrics, you can publish those metrics to various backend systems here. Like one of the most popular one is Prometheus, and there are others like InfluxDB or Elasticsearch. So you can use various backend systems to publish them. The good thing is, as we are using Micrometer, which is like a facade, it doesn't tightly coupled with the backend system that you are using. So you can use it in a backend neutral way to capture the metrics, and then you can publish it to various data stores that can store this metrics information. So let us go ahead and quickly take a look at how Actuator features looks like. Let us take a look at our catalog service and try to take a glance what kinds of information, management information Actuator can provide. So right now I'm taking a look at catalog service of pom.xml. Here we have this Actuator starter added, and also we have added this Micrometer registry Prometheus. So with these dependencies added, now let me start the catalog service by running this. So I do not have a database and all running, but just to start the catalog service, I am using this Testcontainers based local development setup, and I am running this test catalog service application, which is going to start the catalog DB, which is Postgres, and then starts the application. So here the application is started. Now if I go to localhost 8081, this is the port catalog service is running, and if I access /actuator, you can see there are a number of API endpoints available for accessing various pieces of information about the application catalog service. So how we are getting all this information? So once we add this Actuator dependency, and if you notice, we have configured to expose all the Actuator endpoint. Here we mention management endpoints web exposure include equals to star. Star means we are exposing all the API endpoints. But by default only health and info are enabled, I guess. But if you want to enable only specific things, you can name them, or you can specify star, which expose all of things like this. So here you can take a look at, okay, if you want to know what are all the beans that are registered in your Spring Boot application, you can go to this beans API, Actuator beans API endpoint, and this shows all the beans that you explicitly registered, and also all the beans that are auto configured by Spring Boot itself. So you can get to know all the information, what type of a bean scope it is, what is the class name, what are its dependencies. So you can get to know all the beans that are registered in our application by looking at this API endpoint result. Similarly, there are other various API endpoints like health. So if you go to health, it will show whether system everything is up or not, but you can configure it to show what are all the components that are healthy or not. Like in our catalog service, we are using database also. We can configure it to show more details about whether the database is working fine or not. For our order service, we are also using RabbitMQ. So it will also check the connectivity between RabbitMQ and our application. So you can configure all the details to show up whether our system is running healthy or not. So like that, there are a lot of data that you can capture by looking into various these API actuator endpoints. So one thing that is more interesting for us right now is metrics. So here, if you go to actuator metrics endpoint, you can see there are a lot of metric names. And if you want to get to know more information about any of this, you can go to any of this specific metric / metric name, and you can get to know more data about this one. Okay. So this is how we can get the metrics of many different aspects. Again, in our catalog service pom.xml, we have already added this micrometer registry Prometheus, which will give us one more API endpoint here, Prometheus. So if you go to Prometheus actuator endpoint, you can see the metrics information in a Prometheus format. Okay, this is the format that Prometheus expects. Like it is a metric name, and you will have a set of labels associated as dimensions. Okay, so this is how we can expose the data that can be consumed by a Prometheus agent. Okay. In the deployment Docker compose directory, I have created a new file called monitoring.yaml file. So in this file, I have declared this Prometheus service here, and by default it is going to run on 9090 port. I mapped it to the same port on the host as well. And we need to pass a configuration parameters to this Prometheus so that it will start monitoring all those services. So here, in the Prometheus directory, I have a Prometheus.yaml, which is the configuration for Prometheus. And here we define what are all the services that we want to monitor and where to scrape the metrics and all that we define in this file. So here in this file, we have some global configuration. Right now we have configured only scrape interval. By default, the global setting is for 15 seconds. For every, so the default is 1 minute, but we have customized it to 15 seconds. And we have set up various jobs here for under scrape configs, and each job is going to define what system we want to monitor and where is the target and what is the API endpoint that we want to call to get this metrics information. So here the first one is the Prometheus itself. So this is going to scrape the metrics of Prometheus server itself. And the second one is we are defining catalog service, and we are specifying what is the target here. So this is where the server is running catalog service, because we are going to run both catalog service and Prometheus in the same Docker network. We are referencing this host name as catalog-service, and it is running on port 8081. On this host, we are going to call this API endpoint /actuator/Prometheus to get the Prometheus metrics. Okay, and scrape interval is specified as 5 seconds. So for every 5 seconds, it's going to make a call to catalog-service:8081/actuator/Prometheus API endpoint, which is going to return the metrics information in Prometheus format. Okay, so similarly we have defined jobs for all other services as well, like we have order service, we have notification service, we have API gateway, and finally we have BookStore web app. And we configured different host names and then the port numbers they are running on, and all of them have same actuator endpoint. And earlier we have added only actuator, so I have added both actuator and micrometer registry Prometheus dependency in all of our services. So for API gateway, BookStore web app, catalog, order service, notification service. So for all of them, I have added both actuator with micrometer registry Prometheus, so that I can have this API endpoint from which I can scrape the metrics. Okay, so all of these services now expose this API endpoint. Fine. So in addition to this, I have also added a set of new targets here in Taskfile. So I have added start monitoring, and then the command is docker compose. This I have added this file name here, monitoring.yaml, under docker directory, and it is going to do the same thing like restart infra, like that. So we are going to start all the containers that are defined in monitoring.yaml file. Here right now we have only Prometheus, but going forward we are going to add more, and we have stop monitoring and then restart monitoring. This is you are familiar with. So what I did, first I called restart monitoring, and then it started Prometheus server with this configuration. And one thing to note here is we are volume mounting our local file Prometheus/prometheus.yaml file into within the container. We are mapping to this path etc prometheus.yaml, and we are starting the Prometheus server by specifying the config file path as this one. So essentially it is going to use our prometheus.yaml file as the config file and start this Prometheus server. Okay, so now it is once I started this Prometheus server, I have also started all of our services by simply running task restart. Okay, now all the services are running in our Docker environment. You can see all the services, infra services, and then finally Prometheus as well. And now Prometheus is running on port 9090. Now if I go to localhost 9090, this is the default UI that Prometheus provides. Here if you go to under status targets, here you can see various services that we configured and what are their current status, are they up and running, are they down, so you can get all this information. So right now here you can see API gateway is up, and we can see this is the API endpoint that is used to scrape the metrics. And similarly we can also check the status of other services like catalog service. This is the API endpoint that is used to scrape the metrics, and you can see when was the last time it scraped and how much time it took. So you can see all these details. And now if you go to this configuration, you can see what is the final configuration that is applied to start our Prometheus server. So this is where we can see all the information, like we have BookStore WebApp configuration, API gateway configuration, so whatever we specified there, and then it also shows what are the default configuration that it applied. So effectively this is kind of a effective configuration. Okay, and next thing is if you go to graph, so here if you select this enable autocomplete and all these things, now you will be able to see various metrics. For example, we want to see, if you press control space, it will show what are all the possible metrics that are available that you can take a look at it. So let us see some JVM related metrics. So here let us go ahead and see JVM threads, live threads. Okay, now if you click on execute, it will show the same metric is available for different instances. So we have registered all these different instances, right? So what you can do, you can even narrow it down to let's say job equals to catalog service. So then you can execute and you can see only that particular metric information and then what is the current value here. So that way if you want to inspect only certain metric value, you can use this Prometheus simple UI and you can fetch the information. Also you can see it as a graph as well. So here for example, here you don't want to see only for catalog service, you want to see it for all the other service, so you can see all this information as well. Okay, but this is kind of a very simpler UI that you can use to just test out various things, various metric values, and then but we are going to see how we can use Grafana for plotting all these metrics in a much more appealing way. Okay, but this is how you can publish the metrics from your application to Prometheus. Basically, Prometheus is scraping the metrics. It is not the other way around. Okay, so this is how we can publish the metrics. Next, we are going to take a look at how we can send the logs to a centralized log server. In our case, we are going to use Loki, which is again provided by the same company. Usually it is a kind of a popular stack, like you can use Grafana, Prometheus, Loki and Tempo. So we are going to see next how we can publish our logs to a centralized Loki instance. Now let us see how we can push our application logs into a centralized log server like Loki. So here there are many ways we can achieve this one. One of the way is you can use Loki logback appender here. So there is a module called Loki for J logback, so which is an appender where you can directly configure your application logs to push to the Loki server directly. So by using this appender, this is one way. And another way is you can use a tool called Prometheus, where you can configure to fetch all the logs from the Docker containers and then pull all those log statements and push them to Loki server. So how we can do that? So we can configure in such a way that by default your container logs will be stored in a centralized location, and you can mount your Docker socket like this, and then you can configure your Prometheus configuration. Let's take a look at how this configuration looks like. So here we have Prometheus Docker config. So what we are doing, so here is the job that we defined, where we are specifying the host is our Unix Docker socket here, and then we are saying for every 5 seconds and find the Docker containers which has this label. So the label is logging equals to Prometheus. So it is not going to load all the logs from all the containers, only from the containers that has this label attached, logging equals to Prometheus. This way you can only narrow it down to only BookStore related services logs only we want to pull. So with this configuration, and then it is specified clients equals to like a URL. This is the URL where it is going to use to push the log statements to. So this name Loki is nothing but what we gave here for the container name. So we have defined the Prometheus and we have mounted the custom configuration file into this location, and then we are specifying the config file to this location. So effectively it is using this configuration file to scrape the log statements from the containers. And then we have Loki component defined here, and this is the default local configuration, and we are using it. We don't have any of our custom Loki configuration here, which is already available in the Loki Docker container. We are using that same, and we are exposing this port number 3100. Okay, and after defining this both Prometheus and Loki, we also define Grafana, where we can go ahead and check the logs. So logs, not only logs, we can also explore Prometheus metrics also. So we have defined the Grafana container, and then we have exposed the port 3000 on the host as well. And we have configured what are the default admin credentials, and we don't want to change the password, things like that. So with this configuration, we are able to restart all our monitoring related containers. But before doing that, one thing we need to do is, here as I mentioned, we configured Prometheus in such a way that it only pulls the log statements from the container which has label logging equals to Prometheus. So what we need to do, in our apps.yaml file where we defined all our microservices, I have added labels logging equals to Prometheus. So for all the services, I have added labels logging equals to Prometheus. So I have, for all the services, microservices, I have added this. I have not added this to our infra services because I don't want to pull the logs for these databases RabbitMQ. I want to only pull the logs from our microservices only. And again, this is one of the approach. This is not the best approach, or this is not the only approach. As I already mentioned, you can also follow this approach where you can use a Loki logback appender and then configure this appender, and you should be able to directly push from your application to Loki. All the messages, log statements, you can directly push it to Loki. And which approach is better, it all depends. And usually if you want to go down with this path of using Loki appender, usually you can configure your logback spring.xml file in such a way that only if the Docker profile is activated, then only use Loki appender, otherwise use default console appender, something like that you can configure. Okay. Usually during the development you don't want to directly push the statements to the Loki server, so you might want to have conditionally enable this Loki appender or not. Okay, but in this way we don't have to have anything related to Loki, because we are directly scraping the log statements from Docker container logs and then push it to Loki. So during the development you don't even aware of there is a Loki thing, and you just run it as a default console based logs. Okay, so with this configuration we can see earlier we have configured Prometheus, and then now we have configured Promptail, Loki and Grafana. With this, what I have done, I have restarted monitoring containers, and also I have rebuilt and restarted all the services by running task restart monitoring, and all the containers are restarted. Now here you can see all the services are running, Promptail and Prometheus, and also you can see Loki is running, Grafana is running, so everything is running. In addition to that, I have added a couple of log statements in our application, like in catalog service I have just added a couple of log statements in our controller. So before fetching, I have added a log statement fetching product for code, so and so, and for fetching products for the page, so that we can see these statements in our Loki centralized log system. Okay, so now that we have this, and let us go ahead to 3000, which is a Grafana system here. And first thing what we need to do is we need to add data sources. So first let us add Prometheus. And one thing to remember while giving these URL paths here, our Grafana is running inside Docker, and also Prometheus, Loki and everything is running inside Docker. So here you need to give host name with the container name, like so here container name is Loki. So for Grafana, it is going to resolve when you say hostname Loki, it knows that this is the container of Loki. Okay, so that is why while giving the Prometheus URL here, I am giving Prometheus, which is nothing but container name for Prometheus container. Okay, 1990. This is where the port is running. Okay, and that's it. If you click on save and test, so if you see this, that means it is successfully configured. Now let us go back to adding another connection to Loki. So in Loki, again we are going to add a new source and we give the name Loki, and again this is going to be Loki 3100. So if you go to Loki, this is running on port 3100. So that is what we have given here, and that's it. Save and test. So it is also added successfully. Now that we have these two, if we go to explore and go to Loki, now you can see container and service name options here. Now let us go and pick this container option, and we can see catalog service, and here let us select last 15 minutes, and by default it is not going to refresh automatically, but let us select 5 seconds to refresh. So here you can see all the logs already. Now let us go to our web application, and right now it is going to make this fetching products for page 1. Now if I go to next page, it should print page 2. So like this. Okay, so this way we can see it is similarly if we directly access localhost 8989. So let's say through API gateway, let us go and access catalog API products / P100. Okay, so we should be able to see that log statement fetching by some code. So here we can see fetching product for code, this one. So this is how we can not only catalog service. If you go to, let's say, BookStore web app. Okay, let's run this. Okay, so here if you go to home page, it should say fetching products for page 1. Yeah, so it is coming from BookStore web app. Okay, so I have added this log statement so that we can check this. So this way we can centralized sending all the logs to a central log server like Loki, and there are alternatives like ELK stack, something like that. So but we are using some of the products from the same company, Grafana. So it is a common practice to use all the components from the same provider, so that it will be much easier to glue things together. So this is how we can send all the logs to Loki. So next, let us take a look at how we can send the metrics to a component called tempo. Okay. Next, we are going to implement tracing for our applications, and there are some out-of-the-box support for OpenTelemetry or OpenZipkin Brave, and you can use the backend whichever is compatible with OpenTelemetry. So here we are going to use Tempo, which is again coming from the same Grafana company behind the scenes. They have a suite of products. So we are going to use Tempo, which is going to store our application traces. So how we are going to configure our application to store the traces? So we are going to add these 2 additional dependency. One is this micrometer tracing bridge hotel. So basically, again, as we know, micrometer is going to take care of sending the metrics to wide variety of backend stores like Prometheus and other stores, right? So in the similar way, micrometer tracing bridge is going to act as a facade, and you can plug it into a different kind of exporters. So here we are using OpenTelemetry exporter Zipkin. Okay, so using this configuration, we should be able to publish the traces to the backend, which in our case is Tempo. Okay, so I'm going to add these 2 dependencies for all the services, and then we need to configure certain properties about how many traces we want to publish, things like that. Let's check in our catalog service, and I have a section where I already configured these 2 things. Earlier we have Git information to publish full or simple, and also we have been publishing enabling access to all the Actuator endpoints, and these are the 3 additional things that I have added. So here we want to include application name as a tag for all the metrics. And for traces, by default, in our default application.properties, I am setting it to false, enabled false. So when you are running it locally, you don't need tracing. So I am by default disabling it. And also I'm configuring, if it is enabled, we want to send all the samples. By default, it only sends 10% of traces, but we want to send all the traces. So we are saying probability equals to 1.0, which is going to send all the traces. So this is the common configuration. I have added these 2 additional dependencies and this common configuration for all our microservices. Okay, and this is the configuration we need from the application point of view. Now let us take a look at what configuration we need from the Docker Compose point of view. So here I have added this tempo and I have specified this configuration file, and I am mounting that configuration file from this tempo directory. So here if you take a look at, we are specifying which is the HTTP listen port, which is 3200, and I have also mentioned what kind of receivers we are going to support. We have OTLP and Zipkin also. We are going to use Zipkin, and this is the common configuration. We can get it from the official tempo documentation, and going through these details is out of the scope for us. So the key part is what is the HTTP listen port we have and what are the receivers we are supporting with this configuration. So with this we have also mapped the ports, Zipkin port 9411 and tempo port 3200. We have mapped these ports, and now finally when we are running the application in Docker Compose, then we are going to enable this tracing. So we have added additional configuration here. So let us add enabled equals to true to set. Okay, so here we have set, basically we can change these values dynamically by uppercasing all of them and then replacing dots with underscore, right? So we have done that. So we are enabling this when you are running in Docker, and also we are setting the endpoint where we should publish our traces. So we are publishing this to tempo and Zipkin port. So here if you take a look at this, we are publishing through Zipkin port here on tempo host. So that is what we have configured. Okay, so now with this configuration we should be able to restart all of our containers, and then let us see how we can capture the traces. But before that, there is one thing that we need to update. Earlier when we are using RestClient to communicate with the other microservices, we have configured in a different way. For example, in our BookStore web app, we have this configuration where we have clients config, and here we are creating a REST client like this. But if you are creating REST client like this, the automatic instrumentation of these observations is not going to work. So what we can do instead of this, we can auto-wire REST client builder, REST client dot builder. Okay, so let's call it as builder, and we can use that to specify builder dot base URL dot build. Okay, so this way this is already instrumented to hook up with observability registry, so we can simply use this and then continue building our REST client. Okay, so let us do the same thing for this one as well. But if you create this REST client just like the way earlier we did, creating new REST client or something like that, it's not going to instrument out of the box. Okay, and also if you are using REST template, the same thing happen, like you should inject REST template builder and then use that, so that automatic instrumentation just works out of the box. So this is one place. Another one is in our order service, we are talking to catalog service, right? So let us update that as well. Here if we go to catalog service config, again we are creating this by ourselves. So what we can do, we can say REST client builder and we can use that builder. Okay, so this way instrumentation for REST client works just out of the box. You don't need to do anything else. So this is all the code changes that we need for our tracing to work. So now I'm going to restart all the services, and then let us see whether we are able to see the traces or not. Okay, I have restarted all the monitoring components. Now I have also included tempo, and also I have restarted all the services as well. Now if I go to Grafana, here in the data sources, now I want to add a new data source which is of tempo. So here I am going to add this tempo, which is nothing but tempo 3200. If you remember, we have tempo which is running on port 3200, and then we have our container name as tempo. So that's what we are giving here, and the port number is 3200. And we want to trace to logs. You can select Loki here, and let us save and test. So it is added. Fine. Okay, now if you go to explore, and let us go ahead and place a couple of orders. So here if I add a couple of products here and then place an order, now order is successfully created. Now if I go to Loki and then try to fetch the order service logs here, now I should be able to see the flow that got created, that created the order. So here order number is on, so can be delivered. So now let me see where is the order creation logic. So created order with so and so, right? So by default, when you add this tracing support, you can see in the recent versions they have already by default used this format of trace ID hyphen span ID. So that is already included in the logs. So now I'm going to copy this trace ID, and if I go to tempo and place this and search for it, here you can see all the flow that went through that is associated with the trace ID. Okay, so the flow started with placing order on the BookStore web application, and it went through some security filter chains and all, and then it go to API gateway, and then from there it went to order service. So you can see the whole flow, how it went through, and then you can also see it also talked to catalog service for product verification, and you can see how much time at each span it took. Okay, so basically this trace ID and span ID, if you are not familiar with, let's say you started some process and it performed some action in the same service, and then it called some other service, and then maybe it called some other service, but the whole process is considered as one trace. And then within that there will be multiple spans. One span can be within the same service controller, and another one can be calling to another service method, or it can be talking to another service. So each of them is considered as a span, but all of them carry the same trace ID. Okay, so that is what is linking all these logs together. So even though each of these contains different spans, they all belong to the same trace. So that is how in a typical distributed system, if something goes wrong, this is very crucial to be able to grab all the logs that are associated with one particular user action. So this is how we can obtain one of the trace ID, and then you will be able to see all the associated traces, and then you can even see maybe if some customer is complaining that some service is slow or something like that. So here you can check which span is taking more time, and then you can figure out what is going wrong and all. So this is very valuable here, and you can see how much time it is taking for each of them, and then you can even click and go to the specific logs associated with that particular span as well. Okay, so this is very valuable, especially if you are going with the microservices architecture. You should be able to have this centralized monitoring support, otherwise it's going to be very difficult. Okay, so we have seen all this Loki based log checking, and then tempo based tracing and viewing and all these things. So next we can also create some dashboards, and we can configure whatever the information we want to monitor, but we can also use some of the available dashboards. So if you go to dashboards, here you can see some pre-built dashboards here. let's go ahead and pick one of the dashboard. So here I can see Spring Boot observability. The rating is good. Let us see whether we can use this or not. So we can just copy the ID and then come here and paste this ID, and it is going to ask us where is the Prometheus data source, what is the data source for Loki, like that. And then once you select, you can click on import, and here it will already show some good metrics, and you can see how much data it is taking. So basically you can pick what are the service you want to see, and you can see you can also use different dashboards, or you can create your own. Okay, so this is how you can implement various pieces of monitoring support using the Grafana stack. We have talked about what are some of the Actuator features that Spring Boot is providing, and then we have looked at how we can implement observability using Grafana stack like Grafana, Prometheus, Loki, and Tempo. So I hope this gives you fair enough understanding of how you can implement monitoring for your own applications. But in real world, maybe different organizations use different tools for monitoring, like some companies use commercial tools, some companies use open source tools, but the concepts remains kind of similar. Okay, we have successfully completed our Spring Boot microservices course. I hope you learn something that you can use in your real projects as well. So the idea is to build a non-trivial application and to cover as many things as I can. I hope I did that in a decent way. And as always, not a single course can teach you everything. There are so many things that we always need to learn more about. And here in this course, there are some things that they themselves can become another big course, like authorizations. Like implementing OAuth itself is a very complicated topic, and that itself can be a separate series or course itself. But I think I have given enough intro or references so that you can go ahead and explore more on this one. And as part of this, I would also like to give you some references so that if you want to go ahead and learn more about either Spring Boot or some other things, that will be very helpful for you. So here, learning objectives, I think I have covered most of these things as part of the series, but we are not going to implement this Kubernetes on deployment here. But I would highly recommend you to take a look at these learning resources. Basically, this building microservices based application is not for freshers, obviously. In order to use microservice based architecture, one should be, first of all, be strong in Java itself, and then they should have a little bit of basic knowledge on Spring Boot itself. Then it comes as a next step to understand how to properly implement microservices architecture. So if any of you are new to Spring Boot itself, then I highly recommend you to take a look at some of my other series. So in the very beginning, I made a series of Spring Boot tips. It's a 10-part series where I pick up each one important topic about Spring Boot, and then I explained in very detailed manner. So this should be the first series that you can watch in order to gain the fundamental knowledge of Spring Boot and how various things actually work. So this is going to give you very strong foundation for Spring Boot itself. So the next one is I made another series which is to build a Spring Boot application as a backend, and then create a Next.js front end, and then deploy both the applications on Kubernetes. So it's not a microservice based, it's a simple front end and back end, and deploying it on Kubernetes. So if you are interested deploying application on Kubernetes or knowing Kubernetes from the developer point of view, so I would recommend to go through this series. And the third series, Spring Boot the Missing Guide, I highly recommend anybody who really want to understand how things work behind the scenes in Spring Boot. In this series, I went into very low level details about how the implementation might have happened within the Spring framework itself, so that you will understand there is no magic. Probably you might have heard Spring Boot is magic and just adding an annotation does a lot of things and all. But if you go through this series, I can assure you that you will be able to understand there is nothing magic, and you understand what is really happening behind the scenes. So I highly recommend anybody who really want to understand in a very in-depth manner, go to this Spring Boot Missing Guide series. And if you are more interested in testing, I have made another series also, which talks about how do you write using JUnit, and how to use AssetJ and various other things, how to test using Mockito, and most importantly, what's the difference between writing a unit test versus integration test, and how you can write integration test effectively using Testcontainers, and then the common use cases like how to test an API call, how to test Kafka integration, how to test a third-party REST API integration. So things like that. I have covered a lot of common testing requirements in this part of series. So if you are more interested in testing, I would recommend you to go through this series. And as part of this series itself, as I said, I haven't gone in depth into Spring Security OAuth, because I have written a complete series on how to implement Spring Security OAuth. So in this series, it's a blog post, 10-part blog post series. So in this series, I have implemented even more complex application that is secured with Spring Security OAuth. So this is going to give even more understanding of implementing security based on the OAuth 2 standard. So these are all the resources that you have. If you are interested in one particular topic, you can go ahead and you can explore further and learn more about it. So I hope this series is helpful for you, and thanks for watching. Bye bye.